Hey guys, welcome back to the channel. So today I have got something incredibly exciting lined up for all of you diving into the world of databases and SQL interviews. I have attended my fair share of data science interviews and I know how daunting SQL interviews can be. The pressure, the uncertainty, the endless sea of questions that you have to face. But fear not, we are about to change the game. I'm thrilled to announce a brand new series from this video that's going to transform the way you prepare for SQL interviews. Just picture this. So 50 power-packed questions that will become your secret weapon in acing those interviews, right? So there are 50 questions in this and the platform is going to be lead code, right? This series is not about just learning the solution to this 50 questions that usually people do with things like lead code 75 etc. No, we are not going to do that. And you might think like, why only 50 questions, right? Because in this series, when we are following this SQL 50, we will try to cover every nook and cranny of SQL intricacies, from the fundamental queries, right? So these are the fundamental queries, then basic joins, right? Aggregate functions, sorting and grouping, advanced select and joins, subqueries, advanced string function, regex, clauses, etc. Right? So we are going to do all of that. There will be in-depth explanations, tips, tricks, and we are not just solving questions. We are trying to decode, and try to crack all the SQL interviews in just these 50 questions. So whether you are a beginner getting your feet wet or a seasonal coder brushing up your skills, this series is going to be a golden ticket to your SQL interview mastery. So yeah, if you are ready to crack all your future SQL interviews, let's dive into our first question of the series, right? So the first one is recyclable and low fat products. So if you look at it, right? So this is our question and let's see what all companies this question has been asked for. So a number of questions, a number of times very recently, right? So it's a great question. Let's start with like what the question says. So we are given a table called products with three different columns: product ID, low fats, and recyclable. These are their data types. Product ID is the primary key, that is column with unique values for this table. Low fats is an enum category of type Y and N. So basically Y means yes, this product is low fat, and N means no, it is not. Recyclable is another column which is of enum category. Again, it can take Y and N. So yes or no values. Y means yes, this product is recyclable, and N means no, it's not. We are asked to write a solution to find the IDs of the products that are both low fat and recyclable. Order of the result does not matter, right? So it's a very simple question which will actually tell you how to filter based on certain conditions, right? So two or more conditions, how you can combine those both of these conditions and filter your databases or tables using that. So in this example products, we have different inputs and different product IDs, whether they are low fats and whether they are recyclable or not, right? So just by looking at it, let's see. Okay, so product ID 1 has low fat as well as is recyclable. Also product ID 3 low fat and recyclable. So in our output we should have product ID 1 and 3, right? So let's start doing this. So the first thing to write a SQL query, always start from, right? So from clause, from this table called products, right? We need to filter based on two conditions. So how do we do that? Firstly, there are two ways to filter: where and having. There is a difference between where and having. Whenever you want to filter based on aggregate functions, you need to use having. When you are not using aggregate functions to filter, you need to use the where clause. So here we are not using any kind of aggregates, right? So we are doing where. We need to filter. Firstly, you need to satisfy one of the conditions is it should be low fat. So low fats is equal to Y. You also need to make sure that it is recyclable. So you also need to make sure that and your recyclable also has the same value Y, right? So now here what we have, from this products table, we are filtering based on whether the product is low fat as well as recyclable. Once you have them, then in the output you need the IDs of the products. So which column has that? Product ID, right? So we just simply write return, right? So return that product ID, right? Return that product ID. Let's, put a semicolon at the end of the query. Okay, so I think this looks good. This is going to return whatever is required. We don't need to order this result in any manner, right? So let me go ahead and run this. Let's see what do we have here right now. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. Okay, so this is accepted and this is how we do it. So, okay, so this is the second question. It is about finding customer referee. And let's look at the companies the question has been asked for. So Amazon, Google, Apple, Adobe, etc. Right? So quite an important question. So the question reads, we are given a table called customer with three different columns, ID, name, and referee ID, and these are their data types. In SQL, ID is the primary key column for this table. Each row of this table indicates the ID of a customer, their name, and the ID of a customer who referred them. Okay. We are asked to find the names of the customer that are not referred by the customer with ID equal to 2. The order of the result does not matter. So let's go through this example, right? So here we have certain, like, 6 different customers with their names and referee IDs, and we need to return all the customers who are not referred by customer ID 2, right? So this Alex and Mark, they have been referred by customer ID 2. So everyone else except Alex and Mark. So Will, Jane, Bill, and Jack, that should be in the output. And that is what we have. Okay. Now, let's learn about something. So you might be thinking that, oh, this question is too simple. What we can do is we can just do, okay, from this table called customers, let's use the where clause to filter, which we learned in the previous video, that wherever your referee ID is not equal to 2, you just return that. And you might think that, okay, it is going to return you all the names where referee ID is not equal to 2. But let's try to do that, whether it returns what we are requiring in the output. So from this customer table, we are going to use the where clause to filter and keep only those rows where referee ID is not equal to 2, right? Because that is what we need in our output, and we need to return the names, right? So return the name column. Okay, let me go ahead and run this. Let's see what do we have here right now. Okay, so this says wrong answer. Why? Let's see the output. So in output, we only are having Jack, right? So we are only having Jack. What happened to Will, Jane, and Bill? So actually, what is happening is that we are trying to compare the referee ID, so the value in referee ID columns, with a number, right? And SQL is not able to compare null values with this one, right? And that is why it is skipping these null parts and only comparing that, okay, 1 is not equal to 2, so that is why it is keeping only this row. So obviously this is not the way to do. So this is a good learning that we need to keep in mind, that when there are nulls in a column, whenever you are trying to compare, make sure that you are also, including the null part by various methods that we are going to learn. Here we only have 6 rows, so it is visible to us that our output is not same as expected output. But just imagine there would have been 6 million rows. It is practically impossible to, just go through it manually. So make sure that you learn that. Okay, so what's the correct way? So there are multiple ways to do it. First thing that we can do is we can say, okay, you check this, and we can provide another condition, and we can also that, okay, wherever your referee ID is null, you keep that as well. And if it is not null, then you check whether it is equal to 2 or not. So we can add one more conditions, is that, okay, referee ID is not equal to 2, or, right, or your referee ID, right, referee ID is null, right? So it is going to check for these kind of cases whether referee ID is 2 or not, and in all these cases where referee ID is null, it is going to keep those as well. So let me go ahead and run this. Let's see what do we have here. So now this is accepted, right? And this output is same as expected output. Okay, now this is very explicit way of doing it. There are other ways to do this. What if before comparing, we can, substitute these null values to something else and then try to compare it with 2, right? So this is the first solution. Let's do the second part, right? So what we are doing is, where Now, before comparing, we need to make sure that we are going to substitute it. So one of the functions in SQL to do that is if null, and this is specifically for null values, right? So if null, so if the value in the referee ID column is null, then we can substitute it with anything, 0, -1, 1000, whatever you like. Let's do -1. So, and then once you substitute those null values before comparing, then you compare it whether it is equal to 2 or not, right? So now what this is doing is it's saying, okay, if this is null, so yes, for this will, it is null. So it is substituting it is as -1 and then saying only keep those rows where -1 is not equal to 2, which is true, which is going to keep this will row, right? Similarly for Jane, Bill, right? So let me go ahead and run this. Let's see what do we have here. Okay, so again, this is also accepted. The output is same as expected output. There is another method where what you do is you can use a coalesce function instead of if null. And there is a difference between these two. So if null, it only takes two parameters. So it takes one of the column that you want to check for the null. And if it is null, then you can replace it with something. But what if, there was a fourth column, right? What if there was a fourth column which also had some null values and some integer values? And now you need to check, okay, more than one column, whether it is null or not. And then you try to compare. So in that cases, right, coalesce is a function that should be used, right? So coalesce. Right. So now again, it might look like in this case that okay, these are the same stuff. But let's say if there was another column like whatever referee number or something, right? I'm just making this up. So what this will do is it will say, okay, referee ID is null, then it will see okay whether referee number is null or not. If it is null, then it will return -1. If it is not null, so it will return whatever value for that particular row is in referee number, right? So that is what is the use of coalesce. Multiple columns you can check for null simultaneously, right? So, okay. So now again doing the same thing. So it is coalescing basically referee IDs. So wherever your nulls are present, so it is basically coalescing it with -1 and then trying to compare with 2. Let me go ahead and run this again. So now this is accepted. Our output is same as expected output. Okay, so these are the various methods. Let me know if there is a fourth method or a fifth method to do this. Let me go ahead and submit it to see if it passes all the test cases. So yeah, this is accepted and this is how we do it. So easy question, but a great learning curve for us is that, there are various methods to do it. You can either explicitly write it, or you can use various functions. You can use if null, you can use coalesce. Another important thing to know about if null is only MySQL has that. There might be another versions of if null in other forms of SQL, MS SQL, PostgreSQL, etc. But coalesce is usually a standard function. Make sure that you find out the function that is in each of the versions of the SQL to do whatever you are trying to do. Okay, so this question, the third question of this series, is about big countries, and let's look at the companies this question has been asked in. So Apple, Google, Bloomberg, Amazon, Adobe, Facebook, Yahoo, right? So a lot of companies have asked this question, so it is a good question to practice. So the question reads, we are given a table called world with 5 different columns: name, continent, area, population, GDP, and these being their data types. Name is the primary key, that is column with unique values for this table. Each row of this table gives information about the name of a country, the continent to which it belongs, its area, the population, and its GDP value. Okay. It is defined that a country is big if either it has an area of at least 3 million kilometers square or a population of at least 25 million. We are asked to write a solution to find the name, population, and area of big countries. The order of the result does not matter. Okay, let's go through this example, right? So we have a table with, different countries, their continents, area, population, and GDP. So we need to return the name, population, and area of big countries. So there are two ways to determine whether a country is big or not. Either it has a area of more than 3 million kilometers. If you look in this table, there is no country which has more than 3 million kilometers area in this list. right? So we need to look at the second part. Or population is greater than 25 million, right? So Afghanistan has a population greater than 25 million, Algeria has a population greater than 25 million, and no one else. Okay, so Afghanistan and Algeria should be in the output, and that is what we have. Okay, so let me, drag it here. What do we need to do is we can go very step by step in this and learn about a function called union. There is a better way of doing it. Firstly, let me do this using union and let's learn about it. And then I will try to compact my solution as well. Okay, so basically a country is defined big with these two conditions. So let's, from this table called world, only keep those rows where your area is greater than or equal to, because it says at least, right? So greater than or equal to 3 million. And then have another table where we are returning only those rows where population is at least 25 million, and then we just combine them, right? So what I am saying is from this table called world, we are only going to keep those rows where area is at least 3 million, right? So area greater than equal to 3 million, right? And for these people, we need to return the name, population, and area, right? So this is going to satisfy the first condition. And there is a second condition that we need to do, right? So basically, if I just copy it and paste it, right? Copy and paste it here. So from world where population, right? So where population is at least 25 million, right? So population is at least 25 million, right? So now these are the two conditions that are being satisfied. But in the output, we need to have all the countries which satisfy either this or this condition, right? Because both come in the definition of a big country. So how can we do that? We can use the union function, right? So it will union the output from the first part and the second part. So let me go ahead and run this. Let's see what do we have here. Okay, so this is accepted, right? Let me drag it back here. Okay, so this is accepted. Our output is same as expected output, but this is very explicit way of doing the question, right? This is very explicit way of doing this. There is another way where you can achieve the same solution in a more compact way. So basically what we are doing is instead of doing these two things in two different segments and then performing a union, we can do the same thing using the where clause as well as the or clause. So what I'm saying is where area is greater than equal to 3 million, right? On this entire thing, right? So this entire thing can be compressed to or your population is at least, greater than equal to 25 million, right? So this entire thing is compressed into just one line. So let me go ahead and remove this, right? And then let me run this again. So now if I drag it above, okay, so this is also accepted. Our output is again same as expected output, right? Let me go ahead and submit it if it passes all the test cases or not. Okay, so this is accepted and this is how we do it. So yeah, not a very difficult question, but we learned about a concept of union. So basically, when there are multiple conditions that you need to satisfy, firstly think of it in a union sense that okay, satisfy condition 1, satisfy condition 2, satisfy condition 3 and all that, and you have to merge it, right? And once you are able to think in that terms, then you can say that okay, instead of doing by union, you can perform the entire thing using the filter clause where and or and, right? Depending upon the condition. If the question would have said a country is defined big if the area is greater than 3 million kilometers as well as the population is greater than 25 million. Here you would be writing and, right? Okay, so this is the fourth question, article views one, and let's look at the companies this question has been asked in. So Amazon, Yahoo, Bloomberg, Google interviews in the past 6 months, right? So highly important question. Let's look at what the question is saying. So we are given a table called views with 4 different columns: article ID, author ID, viewer ID, and view date. There is no primary key column with unique values for this table, so it can have duplicate rows. Each row of this table indicates that some viewer viewed an article written by some author on some date. Okay, so basically this table has information about an article, who wrote it, who viewed it, and on what date the person viewed it. Note that equal author ID and viewer ID indicate the same person. Okay. We are asked to write a solution to find all the authors that viewed at least one of their own articles. Okay, at least one of their own articles. Return the result table sorted by ID in ascending order. Okay, let's go to this example, right? So here we need to find out all the authors who viewed at least one of their articles. So what does that mean mathematically in this case? So basically your author ID should be equal to your viewer ID, right? At least in one of the rows. So for example, this article number 1 was written by a person with ID 3, right? So if in this table there is a row where this same person would have viewed this article, then it would have viewer ID as 3 as well. But for article ID 1, there is no such row, right? So this article was not viewed by its author. Then article ID 2, written by 7, and yes, on 1st of August 2019, it was viewed by the author itself. So author ID 7 is a person who has viewed his or her article at least once, right? And then similarly for article ID 4, there is only one row. For article ID 3, okay, so written by author ID 4 and then viewed by the same person as well. Okay, so basically there are two people that we found out, author ID 4 and 7, who viewed at least one of their articles. And since we need to sort them by ID in ascending order, so it should be 4 and 7. And that is what we have in the output. And also make sure that the name of the column is ID and not author ID, right? Okay, so to do this, we can use the previous knowledge that we gained from the first 3 videos where we learned about the where clause to filter, right? So basically we are only interested in those rows where author ID is equal to viewer ID, because that is going to satisfy the need of the question, right? So authors that viewed at least one of their articles. Okay, so let me go ahead. So from this table called views, we are only interested in those rows where author ID is equal to viewer ID. Okay, so this is going to keep all such rows. Let me go ahead and do select star. Select star is basically keep all the columns, satisfying all these conditions, right? Okay, let me run this. This is not yet complete, so it is going to return a wrong answer, but we are interested in learning more, right? Okay, so if I scroll down, so this is our output. So where our author ID is equal to viewer ID. Okay, now this question also said, just by looking at it, right? So there is no primary key. So this row can have duplicates. So obviously we do not need duplicates in the output. Okay, this is one thing to consider in mind. So now we got the author IDs that we have in the output, right? 4 and 7. But this should be ordered by ID in ascending order, right? So ordered by ID, ID is basically an alias for author ID in this case, right? So once you have this, so this select star from views where author ID is equal to viewer ID, this is the output of them. Then we also need to sort this. How can we sort in SQL? There is a clause called order by, right? So after getting this output, let's order by, right? So order by the author ID in ascending order. It says ascending order. So by default, when you write the name of a column after order by, it is going to sort in ascending order. So you do not need to write it explicitly, but I am writing it here just for learning purposes. If you want to do just decreasing, you need to write DESC. Okay. So author ID, and then let me go ahead and run this. Now let's see what do we have here. Okay, so our output, so this is now sorted by author ID in ascending order. But again, there is one thing that is missing, that we need to drop duplicates, or we do not need to have duplicates. So how can we not have duplicates? We need to write distinct, right? So if I write distinct star, right, distinct star, and then let me go ahead and run this. Okay, so now if we look at it, so now we drop the duplicate part. Now there is one learning here. when I write distinct star, right? So this means that all the columns, right? So combination of all the columns, that should be different, right? That should be different. It is not trying to keep distinct author IDs. So do not think that this drop was only because there was 4 and 4 in the author IDs in two rows. So one of them was dropped. No, let me go ahead and, revisit this. So let me remove this distinct part. Let me run this again, right? It will make it very clear. Let me go ahead and run this. Okay, so here when I write, right, when I write distinct star, so basically it is going to take all the columns, combine them, and then try to find out whether, there was a distinct part. So remember, here we have two rows, right? Here we have two rows. However, if instead of 21st of July 2019, this would have been 22nd of July 2019, even if these three columns have same values for these two rows, if this is different, so it is going to keep these both of these rows, right? So when you do that, so remember that, so that is what we need to avoid, right? That is what we need to avoid, because there could be, so in this particular test case that is not a case, but in other test cases that could be the case, right? And there your solution will fail. So we need to make sure that we are only keeping distinct authors, right? So now if I write distinct author ID, right, distinct author ID, then this problem is solved for us, right? Why? Because now it is saying that you take the author ID column and then you only keep the distinct ones, right? So let me go ahead and run this now. Still says wrong answer. Why? Because even though our output is same as expected output, the name of the column is not. How can you change the name of a column in SQL? You can simply use alias, right? So you can simply write as whatever is required in your output. Let me go ahead and run this. Let's see what do we have here. Okay, so our output is same as expected output. Let me drag it below. Yeah, so this is the entire solution. Let me go ahead and submit it, so if it passes all the test cases or not. So this is accepted, and this is how we do it. So remember, whenever we need to have an output from a table which can have duplicates, remember we can do distincts, or there is another way is when you can perform groups, right? So after, let's say from views where author ID is equal to viewer ID, you can also do group by, which we are going to learn subsequently. But there is another way. Just remember that there is another way where you can remove the distinct part, right? The way to sort in SQL is using order by clause, and you can change the name of the columns using as alias. Okay, so the fifth question of the series is invalid tweets, and let's look at the companies this question has been asked in. So Amazon and Twitter over the past 6 months. So important question, right? So let's jump right in. The question reads, we are given a table called tweets with two different columns, tweet ID and content. Tweet ID is the primary key, that is column with unique values for this table. This table contains all the tweets in a social media app. We are asked to write a solution to find the IDs of the invalid tweets. The tweet is invalid if the number of characters used in the content of a tweet is strictly greater than 15. Order of the result does not matter. Okay, let's go through this example, right? So here there are two tweets. One is vote for Biden, and second one is let us make America great again. Okay, so now once we have these two, if you count the number of characters, right? So 1, 2, 3, 4, then space is 5, 6, 7, 8, 9, and then 10, 11, 12, 13, 14. So strictly greater than 15 is invalid. So it is less than 15, right? So this is a valid tweet, but this is clearly greater than 15. So this is an invalid tweet. So what is the tweet ID of the tweet that is invalid? 2. And that is what we have in the output. Okay. So to do this, what we need to do is basically we are going to use a filter clause where, but to do the filter, we need to firstly count the number of characters in the column called content. So what we need to do is from this table called tweets, we are only required to keep those rows. So where the length of the characters in the content column is greater than equal to 15, because it says strictly greater than 15. Now you might be thinking, okay, so there is a function called length in MySQL, and we can directly use it. But I will just tell you that technically it is a wrong solution, even though it will pass all the test cases, even though it is accepted by MySQL. Why? I will tell you. So let me do this, right? So where length in the content, right? Length in the content column is strictly greater than 15, you need to basically return the tweet ID, right? Return the tweet ID. Let me put a semicolon. Let me go ahead and run this, right? Let me go ahead and run this, and this is accepted, right? Our output is same as expected output. Let me also go ahead and submit it to show you that this is going to pass every test case. So you see, it is accepted as well. But there is a problem with this. So what is happening is the length function, right? This counts length in form of bytes and not in number of characters, right? So basically, this is counting the length of the value in the content column by number of bytes. Since this is written in plain English, so every character is basically 1 byte. So that is why this is working in this case. However, let me go ahead and show you a difference. So let me open a online compiler and show you how the difference comes, right? And before showing that, the correct function to use here is char length. So basically, the question says the tweet is invalid if the number of characters used, right? So we need to make sure. So the question is written explicitly number of characters, right? Here we think we are counting the number of characters, but in the background it is not doing that, right? Let me open that compiler and show you. Okay, so just look at it. So here, do not worry about the code that is written here. All it is doing is basically it is setting up a variable called a, and there is a, so because these are tweets, right? So this question is about tweets, and people use a lot of emojis, another symbols, etc., right? So this is one of the symbols basically usually is used to represent the copyright symbol, right? And we are converting it into a UTF format. Do not worry about the format as well. So basically, and what we are doing is we are trying to count the length using char length function as well as the length function that we just used. Let me go ahead and run this. So obviously, like if you just look at this, right? How many characters are this? One, right? There is only one symbol, so one character. But let me go ahead and run this and tell you that, okay, so see, do you see this? The length, it is counting it as 2. Why? Because this converted into UTF-8 is actually assigned 2 bytes. So length is counting the number of bytes and not the number of characters. But char length always counts the number of characters, right? So that is why it is good, and to make our solution pass every test case, we need to use char length. Right, so we need to write char length. So now what we are doing is we are actually doing what the question is asking us to do. So from the table called tweets, we are only keeping those rows whose tweets are invalid, and the way to know is the number of characters. So char length in the content of the tweet is strictly greater than 15, and for them we are returning the tweet ID. Let me go ahead and run this now. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases or not. So yeah, this is accepted and well and passes all the test cases. So be aware that even if you think something is doing the right thing, but in the background it is not, right? So it is one of those cases where it's kind of deceiving, because length function, just the name suggests that it is going to count the length, but it is not, right? So make sure to use char length instead of length when such type of questions arrive. This is where in your interviews the interviewer is going to trick you, right? But if you are able to answer this, this is going to be very impressive as well. Okay, so this is the sixth video of the series and the first of joins. This is question regarding replacing employee ID with unique identifier, and this question has been asked in Google, Amazon, Point 72 over the past few months, right? So which is very important question. Let's jump right in. The question reads, so we are given a table called employees with two different columns, ID name, and ID is the primary key column with unique values for this table. Each row of this table contains the ID and the name of an employee in a company. Okay. Another table, employee uni, basically again two different columns, ID and unique ID, and the combination of ID and unique ID is the primary key, right? Combination of columns with unique values for this table. Each row of this table contains the ID and the corresponding unique ID of an employee in the company. We are asked to write a solution to soak the unique ID of each user. If a user does not have a unique ID, replace just so null. Order of the result does not matter. So basically, let's go through this example, right? So here we have information in basically two different tables. So just by looking at it, since the question is asking for something which needs to be extracted from table 1 and table 2, that is why the concept of join comes in SQL. Okay, so now here we have the employees table, their IDs and name, and then employee unit table where their IDs and unique IDs, and it asks us to basically return the unique IDs and the names of the employees. If there is a unique ID, you return the unique ID. If not, you return a null, right? So if we go by this, right? So ID1, right? For Alice, ID1 is not present in employee uni, right? So the unique ID of Alice is null, right? Similarly for Bob, but for Meyer, 11 is present and the unique ID is 2. So 2 and Meyer, 90 is also present. So 3 and Winston, and 3 is also present. So 1 and Jonathan. And that is what we have in our output. So let's learn about joins. So usually there are certain types of joins in MySQL. One category is inner join. So inner join you can basically think of in this way that let's say I and you, we both are persons and we are talking, and whatever is common between us is the output, right? Now another type of joins are called outer joins. So there are two categories in it, left join and right join. So basically what it does is when we do left join, right? So whatever table is in the left, it keeps everything from that, plus it tries to get more information from the next table. Okay, so let me go ahead and show you, right, really quickly how the different joins will work in this case. For inner join, I said that whatever is common, right? So from this table called employees, right? From this table called employees, and it's better to alias the names of the tables to one or two characters because you don't have to write the full name of the table again and again, right? So aliased as E1. So now I can refer the entire employees table with E1, right? Let me do inner join, right? So inner join, the another table is called employee uni. Let's alias this as E2. And inner join and outer joins are always performed using an on clause, because if you are joining two things, right, so you need a link between these, right? So how you are going to join this? So you need to give the name of the column. Now one thing to keep in mind is people usually think, and just by looking at this example also, people might think that okay, ID in this and ID in this, so they are since the same column and they contain the same values, so this is okay to do. And in this particular case, yes, you are correct. But in many examples and in real day life, do not make that as a law. Just look at the columns in different tables and the type of values they contain and what they are represented, and then use that. So it is possible that in this particular table 1 you have a column with different name, in second table you have a column with another name, but they have the same values and represent the same thing, and you have to join it, right? Okay, so since we are performing an inner join and inner and outer joins are performed using on clause, so we do even dot id is equal to e2 dot id, right? And after performing a join, let's keep everything, right? So select star, so return all the columns. Let me put a semicolon. By the way, this is not the correct solution for the question, right? I'm just showing you how the inner join look works, right? Okay, so this says obviously wrong answer. So see, what did I say? I said that when you perform an inner join between these two, whatever is common is being kept. So here 11 Meyer, right? So 11 is present here as well. So 11 is common in these two, 90 is common in these two, 3 is common in these two. So whatever information you get from table 1 employees and table 2, right, you keep all that information. outer joins. So in outer joins, what we are basically doing is, if I do, the first example is left join. So whatever comes before this, right? So this table employees is on the left of the left join keyword that we wrote. So every row in this table is going to be present in the output, and in that, columns from employee unit table are also going to be present, but their values are null or not depends upon whether whatever you are joining on is present or not, right? So what I mean by that is, here, if I write this exact same thing, right, what is this doing? So it is taking, okay, employees, right? So all these 5 rows of the employees table are going to be present. Now, what are the values of the columns ID and unique ID that comes after this going to contain? So one, it will try to search in the employee uni table ID and see, okay, there is nothing which is equal to 1 here. So it will populate null and null. 7 again tries to search here. No, null and null. 11, it founds a match. So it will populate 11 and 2. 90, yes, 90 and 3. 3 it finds, okay, so 3 and 1. So this is what we need to understand in case of left join. Let me go ahead and run this. Let's see if this is what the exact thing we are trying to get. Okay, so yeah, now we have the, so this first two columns, everything from the employees as it is, whatever is in our question, and these two values are coming from the employee unit table based on whether this ID is present in E1 and E2 or not, right? Basically, returning only the unique ID and the name, right? So if I return unique ID, and the good way or the syntax that you should follow is always use the name of the table from which the column you are trying to extract. So in our output, we need unique ID first and then the name. This column after performing a join is coming from employee uni, that is E2, right? So always try to write if names of the columns are unique, right? So if the names of the columns after performing a join is unique, even if you do not write this, it is not a problem. But you just look at it, right? So if you do return ID, SQL will get confused. ID from this or ID from this? Which one of the columns do you need? So it is always better to specify the name of the column. So E2 dot unique ID, right? And the second one we need is name. Name is coming from this one, right? So E1. So E1 dot name. Let me go ahead and run this. Let's see what do we have here. So now this is accepted. Our output is same as expected output, right? Similarly, the right join is just the opposite of it. So instead of, keeping everything from this and trying to find in this, it will keep everything from this and try to find in this, right? And there is a fourth type is called cross join. Cross join is basically every row is going to make a sequence with this. So what it is basically doing is, here you have 5 rows, here you have 3 rows. So in the output you are going to have 5 multiplied by 3, that is 15 rows. How? So first row 1 Alice 3 1. Second row 1 Alice 11 2. Third row 1 Alice 93. Fourth row 7 Bob 3 1. Fifth row 7 Bob 11 2, and so on, right? So if you do this exercise, you are going to give 15 rows. So yeah, this is about joins. Let me go ahead and submit it. So if it passes all the test cases. So yeah, this is accepted and this is how we do it. So not a very difficult question, very basic join, but I try to convey different things about joins, different types of joins you need to keep in mind: inner joins, outer joins, cross joins, and their respective outputs. So what we did was, from this first table, we performed a left join. So this is a basically short form of left outer join. Left outer join, employee unit 2 kept only columns unique ID and name, and that is what we have in the output. So this is the seventh question of the series, product sales analysis part 1, and this question has been asked in Google, Adobe, Amazon interviews over the past few months. So quite an important question. Let's look at the question. So the question reads, we are given a table called sales with 5 different columns: sale ID, product ID, year, quantity, price, and these being their data types. The combined column sale ID and year is the primary key, that is combination of columns with unique values of this table. Product ID is a foreign key, the reference column to the product table. Okay. Each row of this table shows a sale on the product ID in a certain year. Note that the price is per unit. Okay. Another table is product table with two different columns, product ID and the name of the product. Product ID is the primary key of this table. Each row of this table indicates the product name of each product. Okay. So two tables and different information. We are asked to write a solution to report the product name, year, and price for each sale ID in the sales table, right? So we learned in the previous video as well, where there was a similar language of the question. So when it says each sale ID in the sales table, so everything in the sales table on this table has to be in the output, right? So what does this signify? We learned that how to identify whether inner join is better, left join is better, right join is better, cross join is better, etc. So this language, since we need to keep everything, right, since we need to keep everything from this, so it is better to do a left join, right? Okay, so let's go through this example, right? Order of the result does not matter. So here we have the information in sales table as well as product table, and then we need to return the product name, year, and price. Okay, so just look at it, right? So we have product ID here, and the question reads that this column is a foreign key for this one. We can use the product ID to join the information because we need to get product name, year, and price, right? So since the information is distributed in two different tables, right? So we need to perform a join, and by the language of the question we already deciphered that left join is the best type of join in this case. Okay, so what we can do is we can start with it. So from this table called sales, let's alias this as S because it makes our task easier. We need to do left join of the product table aliased as P. Which column we are using to join? Because we need a link to join tables, right? So we are going to use product ID column in the sales table and the product ID column in the product table. So inner and outer joins are done using on clause, and left join is a type of outer join, right? So on S dot product ID is equal to P dot product ID, right? P dot product ID. For the time being, let me return every column, right? Let's see what do we get when we run this. Okay. So not yet complete, that is why wrong answer, but let's look at this, right? Let me drag it on the left, right? So now we have sale ID, product ID, year, quantity, price, product ID, product name. So these first five columns are coming from the sales table, and the product ID and product name are coming from the product table. But we are not required to keep every column, right? We are only required to keep the product name, year, and price, right? So product name, year, and price, right? So obviously we learned in the previous video, whenever you are trying to extract a column out of a table, it is better to write the name of the table also. So what I mean by that is we need, firstly, the first column should be product name. Product name is coming from which table? Product table, right? So and we alias the product table as P, so we can write P dot name of the column, right? So product name. Then after that we need the year part. Both year and price are coming from the sales table, so we write S dot year and S dot price. Okay, let me go ahead and run this. Okay, so now this is accepted. Let me go ahead and again drag it on the right. Okay, so this is accepted. If I look at our output is same as expected output, right? So let me go ahead and submit to see if it passes all the test cases or not. So yeah, this is accepted. So not a very difficult question, very easy question. The only trick was to identify what kind of join we need to perform, and by the language of the question, right? By the language of the question that each sale ID in sales table, we were able to identify that. We also know that inners and outer joins are done using on clauses. We also identify the columns in each of these tables on which we are going to perform the join. And once we have the join, then out of all the columns that we got, we were only required to keep three different columns. One of them come from the product table and two of them comes from the sales table. So this is the eighth question of the series, customer who visited but did not make any transaction. And if we look at the companies this question has been asked in, is Amazon, Apple, Adobe, NerdWallet. So a lot of great companies. So kind of important question. So let's look at the question. We are given a table called visits with two different columns, visit ID and customer ID. Visit ID is the column with unique values for this table. This table contains information about the customers who visited the mall. Okay. We are given another table called transaction with three different columns, transaction ID, visit ID, and amount. Transaction ID is the column with unique values for this table. This table contains information about the transactions made during the visit ID. Okay. We are asked to write a solution to find the IDs of the users who visited without making any transactions and the number of times they made these types of visits. Order of the result does not matter. So basically, you have two tables. One is visit and the customer ID. So these are the customer who visited the mall, and this another table called transactions where there are various transactions and who made that transaction and what was the amount. We are asked to return all those customers who visited the mall but did not have any transactions and how many times they visited the mall and did not have any transactions, right? So basically from this table we are going to get the customer ID, and from the transactions table we are going to use this table to know whether this customer performed a transaction or not in the visit, and if yes, how many times the transaction was made and how many times the transaction was not made. So since this information is in two different tables, so that is why this question is being solved using the join. Now, how to identify what type of join? Because in the sixth video of the series, when we started working on the joins part, we learned there are various types of joins in SQL, right? Inner joins, outer joins, cross joins, etc. In outer joins, again, there are two types, left join, right join on the basic level, right? So basically, what does it say? So just think about it, right? So the question asks for every customer who visited but did not have any transaction, right? So if you are going to do a left join, you need to keep this table on the left and this one on the right. Why? Because if you do the reverse part, if you do a left join with this table on the left and this one on the right, here in the transactions table, you only have those people who transacted in their particular visit, right? So for example, visit ID 5 and 1 and 2, right? So these are the customers. So 1 is customer ID 23, 5 is 54, and 2 is customer ID 9. So if you take the left join by keeping transactions on the left part, you are going to basically ignore these kind of people, right? So 30, 96, 54. But that is what the question is asking, right? People who visited but did not have any transactions. So you understand why on the left join we are going to keep visits table on the left part and transactions on the right part. Okay, so we have established that we need to do a left join by keeping visits table on the left and transactions table on the right. Now we've learned that inners and outer joins need to be done using an on clause. So we need to find a link. How can we join these two tables? We know the visit ID column of the visits table and the visit ID column of the transactions table are same and have the same type of information. So you can use that. Okay, so let's start building this query. So from the visits table, aliased as v, short form, so that we don't have to write the name of the table again and again. We learned this in the previous videos. We need to perform a left join. We established this, right? On transactions, let's again alias this as t. We also established we are going to use the on clause and the columns visit ID from both of these tables. So v dot visit ID is equal to t dot visit ID, right? And let me return all the columns for now, right? We will go step by step. Firstly, let's try to get all the information at one place. So let me run this. Okay, wrong answer because not yet complete. Let me drag it above. Yeah. So if I look at the output, so we have visit ID and customer ID coming from the visits table, and then transaction ID, visit ID, amount coming from, let me drag it somewhat. Yeah. And the amount coming from the transactions table, right? So obviously, if you look at this, right? So 123 and 1, it was able to find that, okay, there is 1 in the visit ID of the transactions table. So it populates this. Similarly, customer ID 9. So visit ID 2, you can find it here. So obviously these rows where you have nulls in the transaction ID, visit ID and amount are basically what we require. Why? Because these are the people. So customer ID 30, the person visited the mall, right? So because we have a visit ID associated with this customer, but there was no transactions in the transaction table, and that is why you have nulls in these columns, right? So customer ID 30, 96 and 54, these are the people who visited the mall but did not have any transaction. So we are only interested in these rows, right? Because that is what the question is asking. Customer who visited but did not make any transactions. So how to keep only those rows which we are required to, right? So we can use the where clause. So where we need to make sure, then you can take any of these columns, but like it's better and logically to keep the transaction ID, and transaction ID is coming from the transactions table, right? Transaction ID is coming from the transaction table. So where t dot transaction ID is null, right? So is null is used to check, okay, wherever this transaction ID value is null, you only keep those rows. Let me go ahead and run this again. Let's see what do we have. Okay, so now we are left with only those rows where customer visited the mall but did not have any transaction. Okay, now the question asks, for every customer we need to also get the number of times this happened. You can use the group by, right? So what we need to do is, let's group by, right? So group by customer ID. Customer ID is coming from the visits table, right? So v dot customer ID. Let me drag it somewhat down. Okay, so v dot customer ID, we grouped by this. Now one thing to remember for group by is, if you do this, right, select star, and if you are grouping by, the only columns that you can return in the output is the one that you are grouping by, right? So if you have, let's say, 5 different columns you are grouping by, you can only return those. If you try to return a column that is not in the group by function, you are going to get an error. So now we return the customer ID, right? So v dot customer ID, and then we also need to count, right? So how do we count? We need to count the number of visits, right? You can count the number of visits to basically tell that, okay, these are the customers who visited the mall but did not have any transactions, and these are number of times such things happened. So you can go ahead and do count of, right? Now you have two columns, right? Visit ID and visit ID with the same name. So that is why, that is why having these abbreviations before the name of the column is important, so that SQL does not get confused. So we are going to count visit ID column from the visits table, right? So v dot visit ID, and this should be aliased as whatever is required in the output, right? So as count of number of transfer. Okay, we are not required to order this, so we don't have to write anything regarding order by. Okay, let me go ahead and run this. Let's see what do we get here. So yeah, this is accepted. Our output is same as expected output, right? Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. So easy question, but we have to firstly identify what kind of join we need to perform first thing. Then once we identify that it is a left join, which table to keep on the left, which one to write, right? Depending upon the question. Then we also identify on what column to perform that join, and then we are only interested in where people visited but did not have any transaction, so we use the filter part. And then for every customer, right, so we learned in the first few videos of this series that there is a way of getting like for every person or every distinct people. So we either you can use distinct, but in this case group by is the most efficient way to do it. So group by the customer ID, and then we counted the number of times this happened. Now, one question that might come into your mind, I just said that once you have a group by, right, whatever column you are grouping by, you can only return that column. So how we are, returning visit ID or using visit ID? So we are not returning the visit ID. We are counting the visit ID, right? So any aggregate functions, and this is the next thing that we are going to learn, but any aggregate, so sum, minimum, maximum, count, etc., right? So any aggregate functions you can perform once you are, grouping by as well. So this is not a problem. However, if you remove the count part, then it is going to be a problem and an error will occur. So yeah, this is the ninth question about rising temperature. And if we look at the companies this question has been asked in, so Google, Adobe, Bloomberg, Amazon, Yahoo. So a lot of important companies. So kind of an important question. So yeah, let's see what the question says. So we are given a table called weather with three different columns: ID, record date, temperature. ID is in column with unique values for this table. This table contains information about the temperature on a certain day. We are asked to write a solution to find all the dates ID with higher temperatures compared to its previous dates. So order of the result does not matter. So just by looking at it, right, the first striking thing you might think is that we are working on the joins part. And right now we have been talking that, to perform joins, we need two different tables. We need to find a link between those two tables, that we put in the on clause, right? But here only one table is given. So how can we perform a join, right? So that is where when you join a table on itself, that is what we call a self join, right? Okay. Now, once that is clear, let's go through this example. So here we have a weather table with four different, entries. 1st of January, 2nd, 3rd, and 4th. So it says IDs of all those dates where temperature is higher than the previous date, right? The exact one day before that. So there is nothing before this. So obviously not this in the output. 2nd of January, temperature is 25 higher than the previous day. That is 1st of January. So ID2 should be in the output. 3, 20 is less than 25. So it should not be in the output. And for 4th of January, so 30 is greater than 20, so 4. So 2 and 4 are the IDs of the dates whose temperature is more than the previous day, right? And that is what we have in the output. So now you might think, like, what will we achieve with the self join? So if I join this table on itself, what will we achieve by that? So basically you need to compare, right? So you need to compare the temperatures of the current date and the next date, or the current date and a day before that, right? So there are various ways, and once we will learn about window functions, there is something called lead and lag functions which can be used to solve this question as well. But during interviews, the interviewer will ask you one question and multiple solutions, so it is better to know different ways to solve a particular question, right? So let's try to solve this question using self join. Okay, now the second question that will come into your mind is, okay, so let's say we are doing self join. So for a join to happen, we need to find a column in table 1 and table 2 that is going to be the link. So how can we get the link in this? So here you just think about it, right? The question itself is giving you a hint of how to get that link. It says all dates with higher temperatures compared to its previous dates, right? So basically, let me go ahead and start writing this. So from this table called weather, and remember, whenever you are doing a self join, you should always use an alias for the table, and the aliases should be different. So from the weather aliased as W1, I am trying to do a left join on the same table weather, but it should be aliased as a different name, right? You cannot write W1 again here. You have to write something else. You can write whatever you want, but not the same. So I'm just writing W2. Now we need to use the on clause to find a link. Then how can we do this? So basically, you need to compare the temperature of a particular date with the previous date, right? So what if you take this record date, right? Record date column from the first version, that is W1, right? And subtract 1 from it. So that is going to give you the previous date, and that is equal to the date from the W2 part. Okay, might be confusing right now, but let me just write it for the time being, and I will just explain what is happening. So record date minus 1 is equal to W2 dot record date, right? W2 dot record date. Okay, so now just think of it, right? So let me explain what this is happening. Okay, so assume this is W1, right? Weather table, and the same table you have here as well. Assume this is W2, right? Same table, two different aliases. Now, when I do W1 record date -1, look at the second one, right? Okay, the cursor comes here. 2nd of January, it subtracts 1 day. So it will become 1st of January 2015. And it will try to find out whether there is 1st of January 2015 in W2. Yes, it is. So it will populate in the second row after this is 1st of January 2015 and 10. Similarly for this and for this. Okay, let me go ahead and return all the columns for the time being, right? This is just for explanation purposes, right? Let me go ahead and run this. Let's see what we are trying to get. Okay, so if I let me just drag it on the left so that it's easier for us. So you see, first, so if you subtract 1 day from this, so 1st of January obviously present, 2nd of January already present, 3rd of January already present. So you are populating the columns that is coming from W2. Okay, so now once we have this, we are only interested in those rows where the temperature is greater than the previous date, right? So this is your current date and this column is your previous date. So we are now going to filter, right? And compare the temperatures of the current day and the previous day. And we are only required to keep those rows where the temperature is higher than its previous date, right? How can we do filtering in SQL? We use the where clause where w1 dot temperature, right? w1 dot temperature is greater than w2 dot temperature, right? So these three columns are coming from W2 version and these three columns are coming from the W1 version. And this is the current date and it should be, the temperature on the current date should be greater than the temperature on the previous date, right? Let me go ahead and run this. Let's see what we are getting. Okay, so now these are the only two dates, right? So 2nd of January where the temperature was 25 and 1 day before this, that is 1st of January 2015, the temperature was 10. So 25 is greater than 10. So it is in the output. Similarly for this. So now once we have this, we need to return the IDs of those dates. So this ID column is coming from W1, right? So all we do is W1 dot ID. Okay. I think this looks good. Let me go ahead and run this. Let's see what do we get here. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. This still says wrong answer. Can you think of why one of the test case will fail in this case? Okay, let me tell you what the problem is, okay, and how to debug this code. We don't have to change this code entirely. We just need to add one thing and this code will start working accurately and pass all the test cases. But let me, show you what the problem is. Okay, so for example, so let me open this, input raw, right? So this is the input. Now, let me, take you to one of the examples. Okay, so look at the end case, right? So 875, this is the ID, and this is the date 1st June 1999. The temperature is 79, right? The temperature is 79. Let me control find and do 1999. So 1 day before 1st June 1999 is going to be 31st of May 1999, right? So May 31st. So minus 97, right? Minus 97. Obviously, the temperature on 1st June, right, is greater than 1 day before this, right? So 875, this ID should be in my output, right? Let me try to open raw for this and try to find whether I have 875 or not. So you see no results. So 875 is not in my output and in the expected output, right? So this is the list of expected output. And if I try to find it, so in the correct answer, 875 is also present, right? So you see, this is the problem that we are having. So what actually is happening, if I look at my code, is that for 1st June 1999, when I'm doing a -1 directly, so it is not going back to 31st of May 1999. It is actually coming out to be 0 June 1999. So you see, that is the problem because in that case, it will try to find 0 June 1995. in the W2 version, obviously there is nothing called 0 June, right? So it will populate nulls in those case, and obviously we won't be able to compare the temperatures, right? And that is why 875 is not going to be present in our output. So how to fix this is we need to tell SQL that, hey, one is not a number that you are subtracting from a date. One is a day that you are subtracting from the date, right? So the way to do this in SQL is you write interval 1 day. So take the record date and subtract 1 day out of it. If I now go ahead and run this, so obviously this is going to be accepted, but if I now go ahead and submit it, it is going to pass all the tests. So you see, it is passing all the test cases and is being accepted. So yeah, this is how we do it. So very important thing that we learned in this video is firstly, how to perform a self join, and secondly, direct subtracting a number from a date is not going to reduce or add days. You need to make sure that you tell SQL that, hey, we are subtracting or adding 1 day in it, right? So that is important thing to do. So yeah, this is the 10th question of the series, average time process per machine. And if we look at the companies this question has been asked in, so Amazon, Apple, Bloomberg, Microsoft, Adobe, so kind of very big companies, so important question. So let's look at what the question is saying. So we are given a table called activity with 4 different columns: machine ID, process ID, activity type, and timestamp, and these being their data types. This table shows the user activities for a factory website. The combined columns, machine ID, process ID, and activity type, is the primary key, that is combination of columns with unique values of this table. Machine ID is the ID of the machine. Process ID is the ID of a process running on the machine with ID, machine ID. Activity type is an enum category which can take values start or end. Timestamp is a float representing the current time in seconds. Okay. Start means the machine starts the process at the given timestamp, and end means the machine ends the process at the given timestamp. Okay. The start timestamp will always be before the end timestamp for every machine ID process ID pair. Okay. There is a factory website that has several machines, each running the same number of processes. Write a solution to find the average time each machine takes to complete a process. The time to complete a process is defined as the end timestamp minus the start timestamp. Average time is calculated by the total time to complete every process on the machine divided by the number of processes that were run. Okay. The resulting table should have the machine ID along with the average time as processing time, which should be rounded to 3 decimal places. Okay. The order of the result does not matter. Let me drag it here, right? And let's look at this example. It would, because the question is so lengthy, let's look at the example. So here we have 3 different machines, right? 0, 1, and 2. Each runs equal number of processes. So each is running 2 processes, 0 and 1. This is the start time and this is the end time. So for machine ID 0, process ID 0, it starts at 0.712 seconds, ends at 1.52 seconds. Similarly, for process ID 1, starts at 3.14 seconds, ends at 4.12 seconds. Right. So what is the average time for machine ID 0 to complete all the processes? It is basically what? 1.52 minus 0.71 plus you add the 4.12 minus 3.14. So whatever comes, you divide the entire thing by 2, and that is what you get in the output, right? So if you look at it, so that is what the processing time, average processing time of machine ID 0, 1, and 2. Okay. Now the first question that should come in your mind is, again, since we learned that while performing joins, we need 2 tables, right, and try to find out a common link between those 2 tables, right? But here we are again given with only 1 table, right, just like in our previous video. So we learned that whenever such is the case, whatever type of join we do, it is called self join. Basically we are trying to join the table on itself. Okay. Now once we establish that we are trying to do a self join, now self join can be done using left join, right join, inner join, etc., right? So in this case, what do we get by performing this self join? Okay. So here, if you look at it, right, so you have, for each row states that, okay, this is the start and this is the end. to get the average, the numerator part, right? So you need to have a subtraction, right? So end minus start is going to give you the time taken by this machine and this process to complete, right? So basically you need to have the values in the end part, right, as columns, right? So here you should have, okay, machine id 0, process id 0, start at this timestamp, end at this timestamp, right? So in that case you can use a self join. We learned that, okay, to do a self join, basically you need to get the same table, but you should always alias it as two different things. So from activity aliased as a1 left join, right? Let's write left join for the moment, and let's see after this, like, whether any other type of join would be a better one, right? Activity again, but this time this should be aliased as something else, a2, right? On the columns that you try to get is activity type end, and timestamp is whatever your process ends at, right? So basically if you look at it, so your machine id and process id is going to be the same. Your timestamp at the start part will be less than the end part, right? So just look at it, right? So if I write a1 dot machine id is equal to a2 dot machine id, and a1 dot process id is equal to a2 dot process id, and a1 dot timestamp is less than a2 dot timestamp. Okay, so just look at it, what is happening here, right? So here, like, this is the same table, right? So this is right, so this is basically the first row, and this one is the right, so this part is the second one, right? This one 0 0 end and start, right? So just look at it, right? So here it will say, okay, on a1 dot machine id, and consider this one as a1 and this part as a2. So it says, okay, machine id is equal in both of these, so 0 is equal to 0, right? It will go row by row, right? So 0 is equal to 0, process id is also same, right? So 0 is equal to 0, and it says a1 dot timestamp should be less than a2 dot timestamp. So here it will say, okay, 0.712 is equal to 0.712 and not less than, right? So it will skip this row. Now it will look, okay, so 0 is equal to 0, 0 is equal to 0, and 0.712 is less than 1.52. Yes, so here it will populate the column. Now another thing that you should be able to see here is, here if you are doing a left join, right? So we understood for first row, right? Machine id 0, process id 0. Here we have the start part, and here we will be having the end part. Okay, now what about this one, these kind of rows, right? So the end one, so you already have the end part, right? So here it will try to see whether 0 is equal to 0, and then 0 is equal to 0. This one obviously is not less than this one, so this will skip this row. This second row is also 1.52 is equal to 1.52. Again, this will skip this row, and every other row it won't be having. So here it will populate nulls, right? But that is kind of redundant, right? Because we already added the, for machine id 0 and process id 0, we already added the end activity and the timestamp, right? So instead of doing a left join, wouldn't it be a better idea to do a inner join? In the sixth video of the series, when we started the basic joins, we learned that inner joins is basically the common thing, right? So from this activity, so the same table, activity and activity, which satisfies all these three conditions. So when satisfying all these three conditions and is common, that is what is going to be returned in our output, right? So that is why doing a self join using inner join is the better way to do it. Okay, so right, okay, now once we have this, then let me return, right? So let me return all the columns from a1, right? So the way to do it is a1 dot star, right? And let me only return the activity type and timestamp from a2, right? So a2 dot activity type, right? And a2 dot time stamp. Okay, let me go ahead and run this. Let's see what do we have in the output. Let me drag it on the left. Okay, so further left. Okay, so now what do we have here? We have that, okay, for every machine ID and process ID, this is the start time and this is the end time, right? Again, for process ID 1, start time, end time. So now once we have these start and end times, we can simply go ahead and get the average. How can we do that? In the output, we require every machine ID, right? So we group by, right? So we group by machine ID is coming from the A1 part, right? So A1 part. So it's better to, specify that. So A1 dot machine ID. And once you are grouping by, so we also learned that the thing with group by is whatever you are grouping by, you need to return only that, right? If you try to return any other column, it is going to give you an error, right? So A1 dot machine ID, and then we need to get the average. So average is basically subtract these two and divide by the count, right? And for every machine ID. So either you can directly use the average function, or you can use the sum in the numerator and count in denominator. Okay. So I let me, try to do both. So a2 dot timestamp. So whenever your process ended, and you subtract whenever your process started, right? Timestamp. So that is going to give you, so for example, machine ID 0, process ID 0. This is the time taken to complete this process, right? And once you have this, you can directly go ahead and do an average, right? So that is going to give you the average for, because we are grouping by the machine ID, right? Group by machine ID. So that is going to give you the average processing time of each machine. Or you can do the another way is, basically have the same thing, right? Basically have the same thing, but you use the sum part. So sum, and paste it here, right? So sum and this, and wait, let me just drag it down here. Okay, so sum. So this is going to give you a numerator, and basically you need to divide it by the count part, right? So that is how you calculate averages, right? You sum the numerator and divide by the total count, right? And let me as average 1, and this is just for demonstration purposes, right? As average 2. Let me go ahead and run this. Let's see what do we have here. Okay, so if I look at my answer, so it is exactly the same thing, right? Since the question is talking about, the time to complete is basically end minus start, and then you divide by the total count. So let's keep this one. This is like more logical in the in this particular question, right? So sum of this, and it should be aliased as like whatever is required in our output. So in our output, this should be processing time, right? So we can write this as processing time. Let me go ahead and run this. Let's see what do we get here. Okay, one last thing that is remaining here to do is we need to round this to 3 decimal places, right? So round this entire thing, right? Round this entire thing to 3 decimal places. Okay, let me go ahead and run this now. Let's see what do we get here. Okay, so now this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how I do it. So yeah, somewhat tricky question and kind of lengthy, but we learned that, okay, we can perform a self join using inner join, and we can have multiple statements in the on clause. And once we had that, when we grouped by each machine ID and then got the average processing time. Again, once we learn more about window functions, this can be done in another way as well using window functions. But here we try to use the join part to solve this question. So this is the 11th question of the series, employee bonus. And if we look at the companies this question has been asked in, so Google, Amazon, NetSuite, so kind of an important question. Let's look at the question. We are given a table called employee with 4 different columns: employee ID, names, supervisor, and salary. Imp ID is the column with unique values for this table. Each row of this table indicates the name and the ID of an employee in addition to their salary and the ID of their manager. We are also given a second table called bonus with 2 different columns: employee ID and bonus. Employee ID is the column of unique values for this table. Employee ID is also a foreign key, that is a reference column to employee ID from the employee table. Each row of this table contains the ID of an employee and their respective respective bonus, we are asked to write a solution to report the name and bonus amount of each employee with a bonus less than 1000. Order of the result does not matter. So basically, if we look at it, right? So here we have the employee table, four different employees: Brad, John, Dan, and Thomas. And we have the bonus table, some of them and their bonuses, right? So if we look at it, right? So what is employee ID 2, right? So employee ID 2 is Dan, bonus is 500, which is obviously less than 1000. So this should be in the output. The employee ID 4 is Thomas. The bonus is 2000, obviously greater than 1000. So it should not be in the output. So Thomas should not be in the output. Dan should be in the output. And for Brad and John, we do not have anything in the bonus table, right? So in the output, we are also keeping Brad and John. So basically, what we are assuming is that if there is no bonus in the bonus table for a particular employee ID, that person did not get any bonus. That is, the bonus is 0. 0 is less than 1000, and therefore we are keeping that in our output. Okay, so since in the output we need the name and also the bonus part, we need to perform a join, right? And secondly, we should perform a left join, keep employee table on the left and bonus table on the right, right? Because we need the names of all the people irrespective of whether they have a bonus or not, right? Okay, so what we can do is from this table called employee aliased as E, let's left join the bonus table aliased as B on, and this we establish that employee ID is the primary key for this table. Employee ID is a reference key or a foreign key for bonus table, right? So we can use the employee ID column to join this two tables. So E dot employee ID is equal to B dot employee ID, right? And let me, return all the columns and see what we are getting. Okay, so let me do select star. Let me go ahead and run this. Let's see what do we have here. Okay, so wrong answer because not yet complete. But if we look at our output, right? So we have the employee ID, name, supervisor, and salary from the employee table, and employee ID and bonus from the bonus table. Now, there is one thing that we should keep in mind. So here the question says that, okay, bonus should be less than 1000. If we directly go ahead and filter that, okay, wherever your bonus is less than 1000, you see this is not going to return us the correct answer. Let me do this where bonus is coming from the bonus table. So B dot bonus is less than 1000, right? This should return all these three rows, but it is not. Let's see our output. So it is only returning for Dan. What is happening to Brad and John, right? So what is happening is that SQL is unable to compare null values with a certain number or an integer, right? So that is why what do we need to do is either you can do the explicit way that whatever we wrote, right? So where B dot bonus, right? B dot bonus is less than 1000, and we know that we also need to keep the nulls one. So we can write or B dot bonus is null, right? B dot bonus is null, and in our output we are only required to keep the name. Name is coming from the employee table, right? So if I go ahead and write e dot name and bonus column, so B dot bonus, let me go ahead and run this. Let's see what happens. So yeah, this is accepted. Our output is same as expected output, right? But this is very explicit way of doing this, right? Another way to do this is like where we can condense these two lines into one, is that instead of, so let me go ahead and remove this part, right? Let me remove this part and run this again. So what if before comparing the bonus column to 1000, assign a certain value, any value less than 1000, so that we do not have to write the or clause. So what I'm saying is, what if, so when it is null, so let's do where if, the value in the bonus column from the bonus table, so B dot bonus is null, right? Then you can replace it with anything less than 1000. Ideally, let's do it with 0. Then you compare it whether it is less than or equal to 1000 or not, right? Let me go ahead and run this again now. So yeah, this is accepted as well. Our output is same as expected output. So you can do any way. Both of them are equally good, but this is a more condensed way. Your code will look more cleaner, right? And let me go ahead and submit to see pass all the test cases. So yeah, this is accepted and this is how we do it. So not a very difficult question. All we had to do was, merge the information from these two tables because we need the name from one table and bonus from another. And then we also learned about how we can compress two or clauses into one. If you are having a null, you replace it by 0 and then compare it with 1000, then you are able to compare with 1000, right? A number. So SQL is able to do that and it returns whatever is required in our output. So this is the 12th question of the series, students and examination. If I look at the companies this question has been asked in, so Amazon and Yahoo, so kind of an important questions. Let's go through this question. So we are given a table called students with two different columns, student ID and student name. Student ID is the primary key, that is column with unique values for this table. Each row of this table contains the ID and the name of one student in the school. Okay. There is another table called subjects with one column, subject name, which is a variable character. Subject name is the primary key, again column for unique values for this table. Each row of this table contains the name of one subject in the school. And we are also given a third table called examinations. Again, two columns, student ID and subject name. No primary key column with unique values for this table. It may contain duplicates. Each student from the students table takes every course from the subjects table, right? This is a very important line because this is going to tell us a type of join that we need to perform. Each row of this table indicates that a student with ID, student ID, attended the exam of a subject name. Okay. We are asked to write a solution to find the number of times each student attended each exam. The result should be ordered by student ID and subject name. Okay, let's go through this example, right? So we have four different students, Alice, Bob, John, and Alex. There are three different subjects, and we have various examinations in this table. So which student took which exam and how many times, like if you see student ID 1 took math once, twice, thrice, right? So three times. So student ID 1 is Alice, right? So Alice took math examination thrice, right? And similarly Alice will take another like physics some number of times, programming, etc., right? So here if I look in the output, let me drag it on the right. Okay, so Alice took math examination thrice, right? And similarly for every other student and subject combination. Okay, so here we are given with three tables, right? So whenever such is the case, always start with two tables and then you can keep on performing the join n number of times. So here this line, right? Each student from the students table takes every course from the subjects table. So basically let's start with this. So each student from the student table, right, takes every course in the subjects table. What does this mean? In the sixth video of this series, when we started with joins, we learned about inner join, outer join, cross joins. Which of this is the perfect way to go in this case? Cross joins, right? Because for every student ID and student name combination, we need to get the number of subjects in the subjects table, right? How can we do that? We need to do a cross join. So let's go ahead and do that, right? So let me drag it back here. So from this table called students aliased as st, let's cross join the subjects table aliased as su. And do we need an on clause for a cross join? No. Why not? Because cross join returns you all the possible combinations, right? So having an on clause does not make any sense in cross join. Okay, let me go ahead and return all the columns. So let me do select star and let me run this. Let's see what do we have in our output. Let me drag it above. Okay, so our output is, so for every student ID and student name, right? So in our example, so we have four different people, right? And three subjects. So how many total combinations? 4 multiplied by 3, that is 12. And if you look at it here, you have 12 rows. So now we are done with this part of the question, that each student from the students table takes every course from the subjects table. Now we need to count the number of times they took the examinations, right? And we have the examinations table where we have the student ID and the subject name, right? So we have from joining these two tables, students and subjects, we have the student ID as well as the subject name in this as well. So treat this as a table, right? They treat this thing like all these three columns and all the 12 rows as one table. And now we can do a left join on examinations using student ID as well as the subject name columns, right? But you might be thinking what purpose that will solve. Okay, just think about it. Here you have one unique row for every possible combination. So student ID 1, Alice, programming, right? And in our examinations table, we have one programming once. If we go for one Alice and physics, so we have one physics once and one physics twice, right? So basically, if you go ahead and perform a left join, so it will have those many rows in the output, the number of times this a particular student took the examination, right? So when you get those many rows for every student, the number of times that took the examination, all you will have to do is count those number of rows, and that will give you what you need in the output attended exams, right? Okay, let me go ahead and do this. So after this, we are going to perform a left join with the examinations table, right? Aliased as E on. Now you need to have student ID as well as subject name. So student ID, right? Student ID in this is coming from the students table, right? Let me drag it below on. So st dot student ID is equal to e dot student ID and also the subject name. Subject name in this cross join is coming from the subjects table, right? So su dot subject name is equal to e dot subject name. Okay, let me go ahead and run this. Let's see what do we have. Okay, so if we look at our output right now, let me drag it on the left. Okay, so now we have that, okay, one Alice programming. So we saw that, right? For programming, Alice took the examination only once, physics twice, math thrice, right? So you see, this is the purpose of doing a left join with the examinations. That now you have basically for every student ID and student name, how many times they took the examination, you have those many number of rows, right? So now you have this. Now in our output, we need, right? So in our output, we need student ID, student name, subject name, and attended exams. So basically, what we can do from this case, we can group by student ID, student name, and subject name. And we learned about group by, right, in our previous videos. So what we can do is we can go ahead and group by, right? So let me group by. Firstly, we need the student ID. Student ID is coming from the students table. So st dot student ID. Then we also need the student name. Student name is again coming from the students table. So st dot student name. Then we need the subject name. Subject name is coming from the subjects one, right? Remember, these first two columns are from the students table. This one is from the subjects table, and these two are from the examinations table, right? So student name and then subject name. So su dot subject name, right? Now we learned about group by, that whatever you group by, you can only return those columns, and we need these three columns in the output, right? So let me go ahead and copy this, paste it here because we need this in our output. Then how do you count? Now, once you will learn about case when statements further in this series, we can go ahead and do this using case when statements as well. But just think about it. We do not need to use case when statements here. Doing a count will also do. Remember one property of count, that when you do count star, right? So basically count all the rows. Even if those rows have null, it will count it. But if you count a particular column, it will return you only the count of non-null rows, right? So why will this work in this case? So here, when I do group by student ID, student name, and subject name, right? So it is grouping by student ID, student name, and subject name. So first group would be one Alice and programming. And if we count this column, right, student ID coming from the examinations table, or you can count the subject name as well, does not make any difference. But let's take each student ID for our conversation here. So when we do count, right? So first one Alice programming, it will count, okay, there is one non-null row, right? So it will return one. For physics, it will count there are two non-null rows. For math, it will count 3 non-null rows, right? Similarly, for Bob, for programming, it will count 1, right? But for physics, it will count, this is a null row, right? In student ID. So it will return you 0. There are no non-null rows for the group 2 Bob physics, right? So you see, that is how count is going to work and give you what you require, right? Because in our output, if you look at it, right? So in our output, you need to have 2 Bob physics and 0. Bob physics 0, right? So you can get that. Let me go ahead and do the count part. So count, right? Count this, and we are counting, like you can do anything, student ID or subject name. I am doing student ID. This student ID column is coming from the examinations table, right? So E dot student ID, and alias this as, so it is in our output as attended exams, right? Attended exams. So attended exams, and this is not yet complete because we also need to sort this by student ID and subject name, right? So let me go ahead and do order by st dot student ID and su dot subject name. Okay, I think this looks good. Let me drag it below. So this is the entire solution. Let me go ahead and run this. Let's see what do we have here. So yeah, this is accepted. If I drag it above, our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. So not a very difficult question, but we were able to practice that, okay, we can perform n number of joins one after the other. So do not get worried if you are having more than 2 tables when you are working on joins. You can keep on doing the joins as many number of times, but just start with the 2 most important ones and then continue further. We also learned that cross join does not need an on clause, and also learned about if you use count on a particular column, it is going to return the count of non-null values in that particular column. However, count star is a different thing. So yeah, this is the 13th question of the series, managers with at least 5 direct reports. And if you look at the companies, this question has been asked in Amazon, Apple, and Bloomberg interviews. Let's look at what the question is saying. So we are given a table called employee with 4 different columns: ID, name, department, and manager ID, and these being their data types. ID is the primary key column with unique values for this table. Each row of this table indicates the name of an employee, their department, and the ID of their manager. If the manager ID is null, then the employee does not have a manager. No employee will be a manager of themselves. Okay. We are asked to write a solution to find the managers with at least 5 direct reports. Order of the result does not matter. Again, we learned in our previous videos that only one table is given, and we are, working on the join part, right? So whatever type of join we perform, it is going to be called a self join, right? And self joins can be performed using inner join, left join, right join, etc. Right? So let's go through this example. So here we have certain people, right? Certain people, name of the employee, their departments, and their managers. Okay. So once we have this, so basically we need to return the name of the manager who has at least 5 direct reports. So if we look at it, right? So Dan, James, Amy, Anne, and Ron all report to manager ID 101, and 101 is basically John, right? So in the output, we need to have John. Okay. So since we already established that we need to perform a self join, then what we can do is we can use 2 different versions of the employee table. So, let me just drag it above. So what we are saying is, let's consider this as E1 and E2, right? Because we learned that if we are performing a self join, we need to have the same table name, but the aliases should be different. So this is E1, this is E2. Now, if we join manager ID of E1 with the ID of this one, right, E2, then we can get the names of the manager, right? So here you can have another column called name of the manager, where you can have the manager. Also, should we use inner join or left join to perform this self join? Just think about it, right? So if you perform a left join, even if rows such like this, right? John is a manager who does not have any other manager, right? So if you perform a left join, in left join, every row from the left column is kept, right? However, such rows does not make any sense for us because we need to count all the managers who have at least direct reports, right? So the better way would be to use a inner join. So let me go ahead and do this. So from this table called employee aliased as E1, let me do inner join of employee, right? So self join on same table, but the alias should be different on even dot manager id is equal to e2 dot id. Okay, let me return everything, right? Let me return everything from this and let me run this. Let's see what do we have here. Okay, so if I look at this, let me drag it on the left. So now we have ID, name, department, and manager ID. So these four columns coming from the E1 version and these four coming from the E2 version. So now we have the name of the employees, their manager ID, and the name of the manager. Okay. So once we have this, then we need to say that, okay, every manager who has at least 5 direct reports, right? So we need to group by the manager. And this is where most of you will make a mistake and the interviewer will reject you. So what most of you will do is that, okay, we need to return every manager that has at least 5 direct reports. So if I group by, right, group by the name, right, and name, this is the name of the manager, right, these are the name of the employees. So name of the manager is coming from the E2 version, right? So E2 dot name, and since we learned by group by that whatever you are grouping by, you can return that part as well, right? So E2 dot name, right? Also, until now, we have learned one way of filtering, that is using the where clause, right? So where we need to check one condition in every row, right? But when you need to filter by an aggregate function, right? So here you do not need to filter row by row. Here you need to find that only those names of the manager who have at least 5 direct reports, right? So in that case, filter we use having clause. So what we do is we write having, right, and then having count the number of direct reports by counting the id of the employees, right? So count, and this column is coming from E1 version, so E1 dot id. You can also use the name part, does not matter. So having count of E1 dot id, so basically at least 5 direct reports, right? So greater than equal to 5. Now if I run this, this is saying, okay, this is accepted, right? But if I go ahead and submit it, right, it is going to fail. Let me drag on the right. So this says wrong answer and does not pass as cases, right? And one of them is that expected is John and our output is John. Can you think of the problem that might be occurring? Okay, the thing is that we grouped by the name, right? It is possible that there are two different managers with two different IDs but with the same name, right? So that is why grouping by e2.name is not a sound way of doing it, right? So let me go ahead and cut this part out, and let's go back to the whatever we had in our join. So let me go ahead and run this. Okay, so if I drag it on the left, so we had this, right? Now, instead of grouping by the name, we should group by the IDs, right? So even if they have same name, the IDs will be different, right? Because ID is a unique column, right? So if I group by, right, group by E2, right? So this column is coming from E2 version, right? So E2 dot ID and then by name, right? And in our output we learned that whatever we group by, we can only return those columns, but it is not mandatory that whatever columns that you group by, you return all of this. So even though we are grouping by e2.id, we can return only the name part, right? So e2.name, right? And then we can have that, okay, filter. So having, right, so let me drag this down. So having count of, right, having count of e1.id at least 5. Okay, let me go ahead and run this. Let's see what do we have here. So this is again says accepted, but let me submit it to see if it passes all the test cases or not. So yeah, if you look at it, it passes every test case, right? So yeah, this is how we do it. So not a difficult question, but we had to, firstly perform a self join. We found out which columns to use. And secondly, in group by, we need to be careful because people can have same names, but their unique IDs will be unique, right? So group by the IDs and not names. So whenever such questions come, try to keep that in mind. And we also learned about how to filter based on aggregate values. So we can use having clause, and do a count. Okay, so this is the 14th question of the series, confirmation rate. And if I look at the companies this question has been asked in, so Amazon in last 6 months, so kind of an important question. Let's look at what the question is saying. We are given a table called signups with two different columns, user ID and timestamp, and their data types being integer and date time. User ID is the column of unique values for this table. Each row contains information about the sign up time for the user with ID, user ID. We are also given another table called confirmations with three different columns, user ID, timestamp, and action, and the data types being integer, date time, and enum category respectively. The combined columns user ID and timestamp is the primary key, that is combination of columns with unique values for this table. User ID is a foreign key, that is a reference column to the signups table. So now we already know how to join these two tables. Action is an enum category of the type, and it can take values either confirmed or timeout. Each row of this table indicates that the user with ID, user ID, requested a confirmation message at timestamp, and that confirmation message was either confirmed or expired without confirming. In that case, it would be timeout. The confirmation rate of a user is the number of confirmed messages divided by the total number of requested confirmation messages. The confirmation rate of a user that did not request any confirmation messages is 0 as well. Round the confirmation rate to two decimal places. We are asked to write a solution to find the confirmation rate of each user. Order of the result does not matter. Okay, so basically what this question is saying, let's try to look at through this example. So here we have four different users in the signups table and their confirmation request, right? So we need to calculate the confirmation rate. So total number of time confirmed divided by the total number of time the request was sent. So for example, let's look at user ID 3, right? So user ID 3 has two rows in the confirmations table and both are timeout, right? So basically the request was made two times and zero times it was confirmed. So 0 out of 2 is 0% confirmation rate, right? Similarly, if we look at user ID 7, so we have three rows in the confirmations table and all the three times user ID 7 has been confirmed. So 3 confirmed divided by total request 3, that is 100%. For user ID 2, we have one confirmed and one timeout, so 50%, right? And for user ID 6, since there is no request, so the question says that if there is no request, we also consider them as 0, right? So that is what we have in our output, right? So basically, since we need to use information from both the signups table and the confirmations table, we need to perform a join. That is for sure. But what kind of join? So here, in our output, irrespective of whether we have a user mentioned in confirmations table or not, just like we saw, right? So 6 is not in our confirmations table, but still we had that in our output. So basically this gives us a sign that we need to keep every user in the signups table. So this tells you that we need to perform a left join where we need to keep the signups table on the left and confirmations table on the right, right? So let's start with it. So from this table, right, we know we are performing a left join. So from this table called signups, right, signups aliased as S, right? So signups aliased as S. Let me do a left join of confirmations, right? Confirmations table aliased as C on. We already identified during the question that we need to use the user ID, right? So user ID is equal to confirmations dot user ID, right? Let me go ahead and return all the columns for this. So select star, let me go ahead and run this. Let's see what do we have here. Okay, so if I look at our output, let me drag it to the left so that it is easy visible for us. So here, if we look at it, right? So here for every user ID, we are now having the number of rows we have in the confirmations table. And for the user ID that we do not have in our confirmations table, we have one row where it is populated null for the columns coming from the confirmations table, right? So now once we have this, then we need to perform a group by, right? Because for every user ID, we need to get the confirmation rate, right? So let's go ahead and do a group by, right? So group by the user ID, and we are going to use the user ID column from the signups table, right? So s dot user ID, and we learned about group by that if you are grouping by a certain column, you can return that column as well. It is not mandatory, but you cannot return a column that you are not grouping by, right? It is going to give you an error. So s dot user ID, and now how do we calculate the confirmation rate? So basically, confirmation rate is number of times confirmed divided by the total number of times applied, right? So total number of times applied is very simple. Just you just count all the rows you have for a particular user, right? So that is the number of times the person has applied. But to count whether how many times the person has been confirmed, you need to either use case when statements or using the if function. But in both of these cases, the basic idea is that to calculate the number of times confirmed, we need to firstly replace confirmed with a value, let's say 1. And if it is not confirmed with 0, and then you sum it up, right? So if I go ahead and use the if function, right? So if I write if your action, right? So action column is coming out from the confirmations table, right? So c dot action is equal to confirmed, right, is equal to confirm, then you replace it with 1, else you replace it with 0, right? So this is going to replace all the confirmed as 1 for a particular group, right? And then what do you need to do is you need to sum it up, right? So it is going to count the number of times they were confirmed, right? Because total number of times confirmed divided by the total number of time requested is the definition of confirmation rate, right? So this is your total number of times confirmed, and we just established that the way to calculate the total number of times applied is just do a count star. So basically count all the rows for a particular user ID, right? You just did that, and we also need to round this, right? So if I drag it slightly on the right, so round it to 2 decimal places, right? So we can go ahead and round it as well. So round this entire thing to 2 decimal places, right? And this should be aliased as whatever is required in our output. So this should be called confirmation rate, right? So confirmation rate. Okay, let me go ahead and drag it down and go. Let me go ahead and run this. Let's see what do we have. So this is accepted. Our output is same as expected output. Let me drag it on the right so that it's easier for us. Okay, now if I go ahead and submit it, let's see if it passes all the test cases or not. Yeah, this is accepted, and this is how we do it. Again, this question can also be done by case when statements. The only difference in this code is going to come in this part, right? So instead of using if function, you just do case when your action is equal to confirm, then 1, else 0, and then you perform the sum part, right? So exact same thing you can do either if function or you can do the case when statements, right? But the basic funda is you need to replace confirmed by such as 1 so that you can easily perform a sum. Now, isn't it surprising that you can use a sum function to basically count? Because here, what we are basically doing, we are counting the number of times the person confirmed, right? Isn't it a good trick to know? So this is the 15th question of the series called Not Boring Movies. And if I look at the companies this question has been asked in, so Amazon and Apple, so kind of an important question. Let's look at what the question has to say. We are given a table called cinema with 4 different columns: ID, movie, description, and rating, and their data types being integer, variable characters, and float respectively. ID is the primary key, that is column with unique values for this table. Each row contains the information about the name of a movie, its genre, and its rating. Rating is a 2 decimal places float in the range 0 to 10. Okay, we are asked to write a solution to report the movies with an odd numbered ID and a description that is not boring. So these are the two filter conditions that we need to use. Return the result table ordered by rating in descending order. Okay, let's go through this example and see what do we need to do in this question. So here we have 5 different movies, their name, their description, and their rating. The first filter condition is that we are only considering IDs which are odd in number. So 1, 3, and 5. Now in this, we need to only keep those movies where description is not boring. So obviously out of 1, 3, and 5, 3 has the description of boring, 1 has great 3D, and 5 has interesting. So we are ignoring or excluding ID equal to 3. So we are only left with ID 1 and 5, right? The movie names are War and House Card, their ratings being 8.9 and 9.1 respectively. So in our output, we need to order by rating in decreasing manner. So the first row should be ID equal to 5, movie name House Card, description interesting, rating 9.1. Second row would be ID equal to 1, movie name War, description great 3D, rating 8.9. And that is what we have in our output. So to do this question, firstly, we need to start from this table. So from this table called cinema, we need to use two filters. So to do filtering, we need to use where clause, where ID is an odd number. So the way to identify a odd number is if you divide it by 2, you are left with a remainder of 1. So we can use ID modular 2 is equal to 1. If you use this symbol, so that is going to give you the quotient. But if you use this percentage sign or modular sign, it is going to give you a remainder. So any number divided by 2, if it is giving you a remainder of 1, it is an odd number. So our first filter is satisfied. Secondly, the description should not be boring. Now, here you already have boring written, right? But it can be a very lengthy statement because it is a description about the movie. So it can be very lengthy description, which can have certain key words, and in between it can have boring. Secondly, we are assuming that people are writing the description. There can be typos or boring. The first alphabet could be in uppercase and rest of them could be lowercase. Someone else writing boring is entirely uppercase, etc. To avoid all such combinations, the best way is you should convert the entire description into either uppercase or lowercase and then perform that filter. So we are not going to exclude rows based on the cases of a description. So first is done, and we also need to make sure that, so let's do the lowercase. So to do a lowercase in MySQL, you just use the lower function. So lower the description part, right? So description column should not be like, so not like, and then in quotes, you need to write percentage boring percentage. What does this mean? That anything before boring and anything after boring is okay as long as this description does not contain the word boring. We are okay to keep it. Okay, so now we are done with both the filters that we needed to do. Odd numbered ID and the description is not boring. Okay, so for them, what do we need to do? We need to return in our output all the columns. So we can simply go ahead and do select star, and also we need to order by rating in decreasing manner. So we can go ahead and write order by rating in decreasing manner. Okay, so I think this looks good. Let me go ahead and run this. Let's see what do we have here in the output. So yes, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how it. So not a very difficult question. All we had to do was we need to perform two filters. Firstly, how to identify a number is odd or even. We learned about modular function. And secondly, when we are dealing with text, it's always better to either do a lowercase or uppercase so that we are not going to exclude just because something is written in upper or lower case. And at the end, we just ordered by rating in decreasing manner. So this is the 16th question of the series called average selling price. And if I look at the companies this question has been asked in, so Amazon and Adobe, so kind of an important questions. Let's look at what the question has to say. We are given a table called prices with 4 different columns: product ID, start date, end date, price, and their data types being integer, date, and integer respectively. The combined columns product ID, start date, and end date is the primary key for this table. Each row of this table contains the price of the product ID in the period from start date to end date. For each product, there will be no two overlapping periods. That means there will be no two intersecting periods for the same product. We are also given a second table called units total, again 3 columns: product ID, purchase date, and units, and their data types being integer, date, and int. This table may contain duplicate rows. Each row of this table indicates the date, units, and product ID of each product sold. We are asked to write a solution to find the average selling price for each product. The average price should be rounded off to 2 decimal places. Order of the result does not matter. Okay, let's look at the question through this example. So here we are basically having two different products and several start dates and end dates and their prices in that date range. And then we have a unit sold table where we have on a certain date how many units were sold. So for example, for product ID 1, how can we calculate the average price? So this purchase was made on 25th of February 2019, and between 17th of February 2019 and 28th of February 2019, the price was 5. So you multiply 5 to 100 units, that is the total money spent is 500. Similarly, for a purchase of 15 units on 1st March 2019, the price from 1st March 2019 to 22nd March 2019 was 20. So 15 multiplied by 20, that is 300. So initially you have 100 multiplied by 5, that is 500, plus 15 multiplied by 20, that is 300. So in total you have spent 800, and you need to divide by the total number of units sold, that is 115. Whatever you get, that is your average price for product ID 1, and similarly for product ID 2, and that is what we have in our output. Yeah, so basically what we need to do is, since the information that we need to use to calculate this average price is basically in two different tables, we need to firstly join these. Now we are going to learn a very new method of joining things. So until now we were only using equal to sign on the on clauses, but in this we need to use something else as well. From this table called prices aliased as P, let's left join the table units sold aliased as U, units sold aliased as U, on. Now here the first thing that we need to make sure that we are joining on the same product IDs, but that is not all. We also need to make sure that the purchase date lies between the start date and the end date ranges, because we need to use the price of that particular range to calculate the average. So we do P dot product ID, P dot product ID is equal to U dot product ID, and our U dot purchase date, U dot purchase date is greater than equal to P dot start date, and U dot purchase date is less than equal to P dot end date. Why we are doing this is, not only we need to make sure that our product IDs are same. So let's go row by row. Let's look at for row number 1 in prices table. So here we have product ID 1, and product ID 1 is going to find that okay, there are two rows where we have product ID 1 in the units table. Then it will also look at there are other two conditions where this line can be stated that start date should be less than or equal to purchase date. So is start date less than or equal to purchase date? Yes. And end date should be greater than equal to purchase date. Since all these three conditions are satisfied for row number 1, then it will populate product ID 1, purchase date of 25 February 2019 and 100 units after this row. But if I look at for first row and the second row in units table, we are going to see even if product ID is same and purchase date greater than the start date 17 February 2019, but purchase date is not less than the end date, and that is why this is going to be ignored in our output. Okay, so once we are performing this join, let me do a select star to keep all the columns, and let me try to run this to see what happens. So let me drag it above and also on the left so that we are able to see this easily. So if we look at our output, right, so we have the four rows that we had in our prices table, along with it the product ID, purchase date, and the number of units. Okay, now once we have the prices and the units, we need to calculate the average price for every product ID. So for every product ID, we can go ahead and group by the product ID coming from the prices table. So product ID, and since we are grouping by product ID, we can make sure that we are able to return it. So select product ID, then we need to calculate the average. Now, to calculate the average, firstly, we need to get the total money spent, that will be price multiplied by units and divide by the total number of units sold. So to calculate the total money spent is basically P dot price multiplied by U dot units. And if I sum this thing, because we are calculating it for every group, so sum this thing, so that is going to give you the total money spent for buying all the items that were bought for that particular product ID. And if you divide it by sum of u dot units, that is going to give you the average, and this should be rounded to two decimal places as the question suggests, and should be aliased as average price. Okay, let me go ahead and run this. Okay, so we have accepted, and if I look at our output is same as expected output. Let me go ahead and submit it. Does it pass all the test cases? Okay, so this says wrong answer still. Can you suggest why this is happening and not passing two of the test cases? Just think about it. Even though we did a left join, that is, we are going to keep every product ID from the prices table. So we are going to have 1, 2, and 3, even though if we look at in our unit sold, we do not have 3, right? But the problem is, since we do not have 3 here, all the columns coming from units sold are going to have null, null, and null values. Now, when you multiply the price to calculate this, right? The numerator, multiply the price 30 into null, that is going to give you null, and then you are dividing by sum of null as well. So, in the output, we are going to get null, but it should get 0. Although this question has not explicitly mentioned that, so this is their fault as well. So in your interviews, always ask this to your interviewer as well, whether in the output having a null is okay. If not, what it should be replaced is. Otherwise, you are going to get the wrong answer. Okay, so it is very simple fix. We learned about this as well, that okay, after calculating this average and rounding off to two decimal places, if this is still null, right, if any value is still null, you just replace it by 0. So how can we do that? We can simply go ahead and do if null. So if this entire thing still comes out to be null, just replace it with 0. Let me go ahead and run this again. So again, accepted, our output same as expected, but let me go ahead and submit it to see if it passes all the test cases or not. So you see, now this is accepted. So yeah, this is how we do it. Even though it says easy question, but I don't think it is that easy. We need to be, thorough with our concept of left join, as well as using the on clauses effectively. Then we also need to make sure that we do not use directly AVG aggregate function. We need to manually calculate that average using the sum function, then round it off. Then also need to make sure that if it still comes out to be null, replace it by 0. So this is the 17th question of the series, Project Employees Part 1. And if I look at the companies this question has been asked in, so Amazon and Facebook in the last few months. So kind of an important question. Let's look at the question. So we are given a table called project with two different columns, project ID and employee ID, and their data types being integer for both. The combined columns project ID and employee ID is the primary key of this table. Employee ID is a foreign key to the employee table. So we already identified that using employee ID, we can join the two tables. Each row of this table indicates that the employee with employee ID is working on the project with project ID. We are also given another table called employee, three different columns in this: employee ID, whose data type is integer, name, whose data type is variable character, and experience years, whose data type is again integer. Employee ID is the primary key of this table. It's guaranteed that experience years is not null. Okay. Each row of this table contains information about one employee. We are asked to write a SQL query that reports the average experience years of all the employees for each project, rounded to two decimal places. The order of the result does not matter. Let's go through this example and try to see what this question is asking. So here we have project table. We have two different projects with several employee IDs associated with those projects. And then we also have an employee table where we have the employee ID, their name, and the experience years. And the question says experience years won't be null. It is guaranteed that. So to find the average experience years, so let's say for project ID1, for every project we need to get the average experience years. So for project ID1, there are three employees that are working on it. Employee ID 1, 2, and 3. One has experience of 3 years, 2 has experience of 2 years, and 3 has experience of 1 year. So total experience is 6 years and 3 people are working. So the average experience for project ID1 is 2 years. So, and similarly for project ID2. So that is what we have in our output. So basically, since we need to use the experience years from employee table and the project ID from the project table, we need to perform a join. Also, what kind of join we need to perform? So for every project, we need to have the average number of experience years. So again, in these cases, it is safe to do a left join so that every project ID, even if it is not mentioned in the employee table, we are able to have that in our output. So to start this, we need to do from this table called project. Let's alias this as P. Let's do a left join of table employee aliased as E on, and we already established that we are going to use the employee ID column because employee ID column is a foreign key in a project table. On P dot employee ID is equal to E dot employee ID. Okay, let me go ahead and return all the columns so that we can see what do we have right now. Let me go ahead and run this. Let's see what do we have here in the output. Okay, let me drag it above. So if we look at our output, let me drag it on the left. So we have project IDs, employee IDs, the names, and the experience years. Now, once we have this, then for every project ID, we need to get the average experience year. So since we are dealing with every project ID, the best way to do this is group by. So we go ahead and do group by P dot project ID and return the P dot project ID, and we need to calculate the average using the experience years column. Experience years column is coming from employee table. So we do average of E dot experience years, and we also need to round this to two decimal places. So we do round off this entire thing to two decimal places, and this should be aliased as whatever is required in our output. So in our output this should be average years. So average years, and order of the result does not matter. So I think this looks good. Let me drag it down. Let me go ahead and run this. Let's see what do we have here. Drag it to the right. Okay, so our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases or not. So yeah, this is accepted, and this is how we do it. So this is not a very difficult question. All we had to do was firstly perform a join. We also identify which column to join on, and then simply grouped by the project ID and had that in our output, as well as we calculated the average of experience years and rounded to two decimal places. So this is the 18th question of this series, the percentage of users attended a contest. Let's look at what the question has to say. We are given a table called users with two different columns, user ID and username, and their data types being integer and variable character respectively. User ID is the primary key, that is column with unique values for this table. Each row of this table contains the name and the ID of a user. We are also given a second table called register with again two different columns, contest ID and user ID, and the data types being integer for both of them. The combined columns contest ID and user ID is the primary key, that is combination of columns with unique values for this table. Each row of this table contains the ID of a user and the contest they registered into. We are asked to write a solution to find the percentage of users registered in each contest rounded to two decimal places. The result table should be ordered by percentage in descending order, and in case of a tie, by contest ID in ascending order. Okay, so let's go through this example and try to see what this question needs in our output. So we have users table with three different users, Alice, Bob, and Alex, and their user IDs. And then we also have registered table with various contest IDs and the users who registered in them. So if we go by different contest IDs, so for example, for 215, contest ID 215, so user ID 6 is registered, and then user ID 7 is also registered. So two people out of three are registered. So what is the registration percentage? 66.67% rounded to two decimal places. Similarly, if we look at 209, contest ID 209, user ID 2 is registered, 7 is registered, as well as 6 is registered. So all the three people are registered. So the percentage registration is 100 for 209, and similarly for all the different contests. And if we arrange by contest ID and percentage, so this is what we get. Okay, 99.9% of the people will solve this question using subqueries or common table expressions. But if you want to be in those 0.1% people and stand out in front of an interviewer, I'm going to share a solution that is just 5 lines, incredibly easy, and will blow your interviewer's mind. And I promise I won't use any advanced or fancy concept of SQL. This question will really test how deeply you understand the basics of SQL. Let me switch to Excel so that I can demonstrate this concept very easily. So these are the two tables that we have: users, these three different people, and the register, right? Various contest ID and user ID. Let me just take 1 minute of yours and share why 99.9% of the people will be using subqueries, which is a very inefficient way of solving any question. The reason I am saying is that when we will be learning about subqueries, we will get to know that for every row, a subquery is calculated again and again. So, highly inefficient manner of solving a question. The question is asking us for every contest ID, what is the percentage of users registered? To make this even easier, let me sort this in ascending order so that we are easily able to count. Okay, so just by looking at it, if I say that what is the percentage of users registered in contest ID 207, only one person out of the three is registered, right? So that is why most people are going to use subqueries, that they are just going to go ahead, group by the contest ID, count the user ID, and then use a subquery to basically have the number of different users in the users table. And here you will be getting for 207 number of different users 1, and what is the total number of people in the users table? 3. So 1 divided by 3 is 33.3%. Similarly for 208 you have 3 different people, 3 divided by 3 is 100%, and so on. But this question can be solved using joins as well. I challenge you, pause this video for a second. Just think of which type of join is able to solve this question. Is it left join? Is it right join? Is it cross join? It is a self join or any other kind of join? Maybe some of you are able to guess it, but if not, let me share what we need to do in this case. Actually, this question can be very easily solved using cross join. Let me go ahead and write 2 lines of code, and then we will come back to this Excel and then see how that cross join is going to solve this question. So what I'm saying is we need to perform a cross join. So from this table called users aliased as you, let's do a cross join of register table aliased as R. And since we learned about cross joins, it will give you all possible combinations of rows of users and the register table. If I, return all the columns of these two after performing a cross join, what is this basically going to return us? Let me switch back to Excel. So I'm saying cross join. So cross join is basically take row 1 and create all possible combinations. So first row would be 6 Alice 215 6. Second row would be 6 Alice 209 2. Right? Okay. So since we are returning all the columns, so first two columns user ID and username are coming from the users table, and the next two columns contest ID and user ID are coming from the register table. So when I'm doing a cross join, so basically what is happening? Okay. So take the first one, right? Take the first one and then populate so all the possible combinations. So okay, take this one, right, and put it here, then again make another possible combination. So you see how all the possible combinations are going to be made. So similarly for this, let me go ahead and populate the entire thing. Okay, so I have populated everything, the result of the cross join. So since there are 3 rows here and 12 rows here, so in total there would be 36 different rows. Okay, so now once we have this, then just think about it. And for our simplicity purposes, let me go ahead and sort this in ascending order. We don't need to write that in our code when what we are developing, just for understanding purposes so that it is easier for us to count, right? So let me do this. Okay, so now for 207, we saw that, right, if I jump back for 207, we saw that the percentage is 33.33, right? 1 out of 3 have only registered. Okay, let me go ahead. 207, we have 3 different rows. Okay, but just see here. So if you count the distinct from the user ID column that is coming from register, that is going to be 1. And if you divide by the number of distinct people in the user ID coming from users table, that is going to be 3. right? So 1 divided by 3 is 33.33%. Again, 208, we had 100%, right? How many distinct you can see find here? So 208 has so many rows, right? But distinct are, so you have 2, you have 6, you have 7, 2, 6, 7, 2, 6, 7. So it is repeated. So 3, and then here, how many you have? So 6, 2, 7. So 3. So 3 divided by 3 is 100%. And if you look at for 208, we have 100%. So you see, that is what is going to happen, and that is what we need to do. And this is so simple. So what did we say? That if we group by the contest ID and count the user ID columns coming from the register as well as the users table, then we are able to get our fraction or percentage. So what I'm saying is group by the contest ID. Now contest ID comes from the register table. So r dot contest ID, and we are going to return the contest ID column because that we need in our output. And then to calculate the fraction, we need to do on the numerator distinct distinct people who have registered in that contest ID. So that is going to be r dot user ID, right? Just like we saw here, r dot user ID. And if I divide that by count of distinct values coming from users table user ID, right? So user ID, again let me switch back. Okay, so if you count this part, then it is going to tell you the total number of people in the users table. Okay, so this is going to give you a fraction, but it should be converted to a percentage. So we can multiply this by 100. Then we also need to round this to 2 decimal places, round this entire thing to 2 decimal places, right? And then we also need to alias this as percentage, and the result should be ordered in descending order by percentage. So we need to write order by percentage in descending order. We learned about this, and it says if there is a tie, so if the percentage are same, then by contest ID in ascending order. So all you have to do is just simply write contest ID here. So in all the ties, it will sort the values by contest ID. Okay, let me go ahead and run this, and let's see what do we have in our output. So you see this is accepted, our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases or not. So did it say this is accepted and this is how we do it? So yes, it does say it is an easy question, but only if you do this using a subquery, which is an inefficient method of doing this. If your interviewer asks you that what is a second solution or what is the best solution to do this, you should try and think hard and try to do this using this. Because if you are able to do this, it tells your interviewer that you have very deep understanding of the very basic SQL, and you don't have to jump to higher advanced concepts of SQL just to solve a very basic question as well. So this is the 19th question of this series, queries, quality and percentage. And if I look at the companies this question has been asked in, so Amazon and Facebook, so kind of an important question. Let's look at what the question has to say. We are given a table called queries with 4 different columns: query name, result, position and rating, and their data types being variable character, integer and integer respectively. This table may have duplicate rows. This table contains information collected from some queries on a database. The position column has a value from 1 to 500. The rating column has a value from 1 to 5. Query with rating less than 3 is a poor query. We define query quality as the average of the ratio between query rating and its position. And also poor query percentage is defined as percentage of all queries with ratings less than 3. We are asked to write a solution to find each query name, the quality and the poor query percentage. Both quality and poor query percentage should be rounded to 2 decimal places. Order of the result does not matter. Okay, let's look at this example and try to see what we need in our output. So we have 2 different query names, dog and cat, and these are the different results, the position of the query as well as the rating. Now we need to calculate the quality. Quality is average of the ratio of rating and position, And secondly, we also need to make sure what is the poor query percentage. So for dog, we have 1 out of 3. So 33.33% is the poor query percentage. Similarly, for cat, if we look at it, so again, there is one query which is less than 3 rating. So 1 out of 3, that is 33.33%. So yeah, this is what we get in our output. Okay, let me switch to Excel so that I am able to explain the concept clearly. So this is the table that we have. We have query name, result, position, and rating. Now, the quality is defined as, right? So the column called quality is basically defined as rating divided by position, right? So this is what we have. Okay, so the question says, so for every query name, so for dog, we have the ratio of rating and position, and the average of this is going to give you the quality. So if I switch back and write from this table called queries, let's group by the column called query name, because for every query we need that quality, right? So select query name, and then we need the quality, and we just saw that if we do rating divided by position, that is ratio of rating and position, and if we calculate the average of this, and this should also be rounded to two decimal places. So if I round this to two decimal places and alias this as whatever is required, so as quality. So if I run this, if I look at my output, so for query name, dog and cat, this is the quality that we get. So if we look at our output, we are done with the quality part. Now we also need to calculate the poor query percentage. Okay, so to do the poor query percentage part, we need to calculate basically what percentage has the rating less than 3. So we can use the if function in this case. If the value in rating is less than 3, then you assign the value 1, else you assign the value 0. What is this going to do in this case? Let me switch back to Excel. So here it will say, okay, rating less than 3, no, right? So it will assign value 0. Here again 5, so no. 1 is less than 3, so yes, it will assign value 1. 2 is less than 3, yes, assign 1. 3 is less than 3, no, right? And 4 is less than 3, no. Okay, so we have this. Now if we go ahead, and since we are grouping by the query name, right? So this is one group, so these three are one group. So we have, once we have assigned these values ones and zeros, if we go ahead and calculate the average of this, so average would be sum these all three, so 1 plus 0 and divide by count, so 3. So that is going to give you the poor quality percentage. So let me switch back. So if once we have this, then we are going to calculate the average of this part, calculate the average this, and then we also need to multiply it by 100 because we need it as a percentage. So this is the percentage that we get. Now this should also be rounded to two decimal places as is asked in the question, and should be aliased as poor query percentage. Okay, let this looks good. Let me go ahead and run this. Let's see what do we have here. Okay, so this says accepted. Let me drag it to the left and to up. Okay, our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. Okay, so this says wrong answer in this case and says one of the test cases it did not pass. Now, if we look at this, so this is a problem and this is not mentioned in the questions. So this is not our fault. They should have mentioned that query name could take a null value. So basically, if there is a null query name, we don't need that in our output. So since we did not filter for null values, we have that in our output. So it is a very easy fix. What do we need to do in this case is just apply a where clause. Whenever you are taking the rows from the queries table, just filter and make sure that where query name, how to check it is not null, you just simply write is not null. If let me go ahead and run this. Okay, so again, this is accepted, not a big deal, but let me go ahead and submit it. So now this is accepted and this is how we do it. So yes, kind of an easy question. All we had to do was Firstly, use the ratio between rating and position to calculate the average that is going to give you the quality. And also we use the if statement to assign ones and zeros to the quality part and then use to calculate the average that gave us the poor query percentage. This question can also be done using instead of if. This entire thing is basically what? Case when rating less than 3, then 1, else 0, end. If you know how to use case when statements, well and good. If not, we will be learning in this series as well. So this is the 20th question of the series, monthly transactions part 1. And if I look at the companies the question has been asked in, so Adobe and Wayfair. Okay, so let's see what the question has to say. We are given a table called transaction with 5 different columns: ID, country, state, amount, and transaction date, and their data types being integer, variable character, enum, integer, and date respectively. ID is the primary key of this table. This table has information about incoming transactions. The state column is an enum of type which can take values approved or declined. We are asked to write a SQL query to find for each month and country the number of transactions and their total amount, the number of approved transactions and their total amount. Order of the result does not matter. Okay, let's go through this example. So there are 4 incoming transactions in the transactions table, and some of them are approved or declined based on the country, amount, as well as the transaction date. So we are required for every month and country, what is the count of total number of incoming transactions, how many of them were approved, what is the total sum of incoming transactions, and the sum of transactions that were approved. So let's take the example of, so for December of 2018. So we are not interested in the dates. It says for every month. So December of 2018, there are 2 rows and the country is US. So December of 2018 and US, how many incoming transactions are there? 2. How many of them have been approved? 1. What is the total amount of incoming transactions? So 1000 plus 2000, that is 3000. What is the amount of the approved transactions? So 1000. And that is what we need to have in our output. Okay, so let me just drag it to the extreme right so that we are able to view this table properly. Okay, so for December of 2018 and US, 2 incoming transactions, one of them was approved. Total transaction amount that came in was 3000 and approved total amount is 1000. Okay, so that is what we need to do. Let me switch to Excel so that we can understand how to do this better. Okay, so this is the transactions table, and for every month and country, we need to find out the 4 things that are given in the question. So the first thing that should come in your mind is that how can we remove the days from the dates in MySQL? So to format this date so that it only has month and year part, there are several ways to do it. Most of the people, what they will do is they will use a substring function. So it's called substring. This is a function in MySQL where you can provide the name of the column, right? So the syntax of that is name of the column, starting index, and then after the starting index, how many characters, right? So the number of characters you want extracted. But the problem with this is it is kind of hard coding the thing. That is, you only can get a set of substring from a given string. A better and a more powerful function exists in MySQL called date format, where using the data type of a column, you can extract anything out of it. Unlike substring, where you can only get whatever is written exactly, a part of it, if you use date format, you can not only get this 12 as a number, you can also get it as December, you can get the year, you can get week, month, hour, like anything, and it is very powerful. So in the sheet 2, I have listed down all the, so these are the various formats and we will learn about it, how to use it. But if you look at it, you get the numeric month name, you can get the abbreviated month name, weekday name, day of the month, hour, minutes, second, day of the hour, AM, PM, seconds, everything, like, right? So it is very, very powerful function, and that is what we need to use. So what we can do is we can use the date format. The syntax is you write it as date format, then the name of the column, and then the format in single quote. So we need year part and the month as a number. because that is what we had in our output. Let me go back. So year and month as a number. So in this case, if I go back to the list, how do we get the year part? We need to use, let me scroll down. Okay, so if I use percentage capital Y, it will be year as a numeric 4-digit value. So let me go ahead and switch to sheet 1. So if I write percentage capital Y, and then we also need a dash, and then how to get month as a number between 0, 0 and 1, 2. If we go above, we can find that, okay, if I use percentage small m, then that will do our trick. So here, if I write percentage small m, and this thing should be entirely in parentheses, so this is going to give you, this is going to, this part is going to return you. So here, instead of column, we need to write transaction date. So because we are going to use the transaction date part, right? So here, if I do 2018-12, this is going to return this, then 2018-12, then this is going to return 01, and 2019-01. So this is what we will get. So if I go ahead and start writing this query, let me switch back to lead code and let me drag it on the left. So from this table called transactions, if I group by the thing date format, transaction date, and in this particular format, and then we need to also return the country for every month and country. So we also need to group by the country part, and then let us return this. So return this, and this should be aliased as month. So as month, then country. And now the first thing that we need is transfer count. So here, how many transfers in a particular, so we grouped by this thing, right? So this is what we are calling now as month. Okay, so this is our month now. For a particular month and country, we need the count of total incoming transactions. So if we just count this ID, and the ID contains unique value as given in the question. So if we count the ID column, that is going to give you the total number of transactions for a particular month and country. So if I do count of ID, and that will give us transaction count. Now, how can I get the approved count? Let me switch back. So how can I get the approved count? So here in this one, right? So this is one group. This, the highlighted part, is one group. So in this, one is approved, one is declined. So what we learned in our previous video is that if we use the if function to check a particular condition, and if that condition is true, we can assign one value. If it is not true, then we can assign another value. So if we check state is equal to approved, assign the value 1, else you assign the value 0, and then you sum that part up. So that will give you 1 plus 0 is 1, and that is what? The count of approved transactions. So 1, so since approved 1, declined 0, approved 1, approved 1. How are we getting this? We need to write this part of the code. So if the state is equal to approved, then you assign the value 1, else you assign the value 0. And what do we need to do now? Sum this up. So sum this up, and that is going to give you the approved count. Okay, now we need to get the transfers total amount. So it is kind of very simple. You just sum the amount column, in this, and that is going to give you the total transfer count. So here we can simply go ahead and do sum of amount, and that is going to be aliased as transfer total amount. And we also need the approved total amount. So approved total amount is, again, here we can use a slight different version of the if function that we already used for ones and zeros. Here what we can do is, if we check whether state is approved, then you return the same amount. But if it is not approved, then you return the value 0. So what I'm saying is, so approved, so return the amount But if it is declined, you return 0. Then approved. So this is amount 2000 and again 2000. Okay, so in this group, right, the first group, if I sum this part up, that is going to give you the approved total amount, and that is what we see here as well. And in this particular case, it will add these two as well. Okay, so if I go ahead and do if the state is equal to approved, then you return the value in the amount column, else you return 0, and then you sum it up. That is going to give you the approved total amount. So we have this. Okay, and since we do not need to order this by anything, so I think this looks good. Let me put a semicolon here. Okay, let me go ahead and run this. Let's see what do we get in this case. So this is accepted. Let me go ahead and submit it to see if it passes all the test cases or not. So yeah, this is accepted, and this is how we do it. Not a difficult question, but very lengthy in the terms that we need certain values. But if you apply the very basic concept of grouping by certain columns and how to extract date, and then how we can use some function to basically perform a count, and also we use the appropriate use of some function as well. Also, one thing here, you can even improve this query that once you write this, then instead of writing group by, actually you can just give the number of the column. So this is the first column that is going to appear. This is the second column that is going to appear. So here, even if I change this to 1 and 2, that is going to run and pass all the test cases. So let me go ahead and run this again, accepted, and let me submit this as well. So again accepted. So but like this kind of seems counterintuitive in the first pass, but this is what you can do to even improve your formatting of the code. So this is the 21st question of this series, immediate food delivery part 2. And if I look at the companies this question has been asked in, so DoorDash. Let's look at what the question has to say. We are given a table called delivery with 4 different columns: delivery ID, customer ID, order date, and customer preferred delivery date, and their data types being integer for first two and date for last two columns. Delivery ID is the column of unique values of this table. The table holds information about food delivery to customers that make orders at some date and specify a preferred delivery date on the same order date or after it. If the customer's preferred delivery date is the same as order date, then the order is called immediate, otherwise it is called scheduled. The first order of a customer is the order with the earliest order date that the customer made. It is guaranteed that a customer has precisely one first order. We are asked to write a solution to find the percentage of immediate orders in the first orders of all customers rounded to two decimal places. Okay, let's go through this example and see what we need in our output. So we have 7 different rows in this delivery table and 7 different delivery IDs of various customers, their order date and their preferred delivery date. So we need to find out the percentage of first orders that were immediate. So let's look at, for all these customers, what were their first orders. For customer ID 1, this is their first order and it was scheduled because it is not the same date as the order date. For customer ID 2, this one is their first order and it is an immediate. So right now 1 out of 2 is immediate in the first order. Then for customer ID 3, this is their first order and this is also scheduled. So 1 out of 3 as of now. And if we look at customer ID 4, there is only one order. So that is going to be their first order and it is also an immediate. So 2 out of 4 are immediate orders on the first orders of the customer. So that is going to be 50%, and that is what we have in our output. In this video, let's try something different. I am going to show you how, by using the same logic, the solution code can be written at a beginner, intermediate, or advanced skill level. This will give you the confidence that you do not need to think something differently or extraordinarily to become a pro in SQL. Let me switch to Excel so that we can start developing the logic and then look at the 3 solutions. So this is the delivery table and let's develop the logic. So our first step should be to find for every customer ID what is their first order date. So step 1 should be find first order date. Then step 2, because we are only interested in the first orders, so keep only first orders, and then we need to get the step 3 is going to be percentage of those first orders that are immediate. So this is the 3-step logic that we develop. Now let's begin with how a beginner will approach this. So our first step is find the first order date. How can we find the first order date of every customer ID? Simply, if you just group by your customer ID and find the minimum order date, that is going to give you the first order date. So let me go ahead, let me go back, let me drag to the left so it is easier for us to see. From this table called delivery, let's group by, let's group by the customer ID, return the customer ID and the minimum of order date, and this is going to be as first order date. Okay, let me go ahead and run this. Let's see we are done with the first step or not. Okay, so if we look at our output, yes, for every customer ID, we have the first order date. Okay, so we need to add the first order dates of every customer so that we can perform the filter. So what we can do is we can say that, okay, this entire thing gives you this table. So if we put this entire thing in a parentheses, if we put this entire thing in parentheses, this is going to give you one table. Now, what do we need to do is from this table called delivery, let's alias this as D. Let's treat this entire thing as another table. Let's call this as table F and just perform a left join, because in this table, in this delivery table, we are basically adding another column called first order date. So what do we do is from this delivery D, let's left join this table, this entire table called F on customer ID. So on D dot customer ID, let me drag this down so that it is easier. Customer ID is equal to F dot customer ID. Okay, so now once we have this, let's return all the columns from delivery table and just keep the first order date from the table that we created. So first order date. Let me go ahead and run this. Let's see what do we get in this. Let me drag it above. If we look at our output, okay, so this is our output. Let me drag it to the left so that it is easier for us to view. Okay, let me drag above. So for every order, now we have the first order date of that particular customer. Okay, so our first step is done. Okay, now moving to the second step, keep only the first orders. We are going to use the where clause. So where your order date is equal to first order date, then that is the first order for every customer ID. So what we can do is we need to perform where the order date is coming from the delivery table. So d dot order date is equal to f dot first order date. Okay, let me go ahead and run this. Let's see what do we have here. Let me drag it above. Okay, so if we look at our output now, so these are the first orders for every customer. So now we are done with second step as well. Then we need to find out what percentage of them are immediate. So we are going to use the knowledge that we gained in our previous videos of using if function. So what do we need to do is return if your order date is coming from the delivery table. So d dot order date is equal to d dot customer preferred delivery date. Then you assign the value 1, else you assign the value 0. What is this going to do? So if your order date is equal to the customer preferred delivery date, that means that this order is immediate. If not, then it is scheduled. We need to find the total percentage of them being immediate. So if I just let me go back here and let me just populate the first order date so that it is easier for us to visualize. Okay, so after step one, these are the first order dates. Then we are only keeping first orders. So let me just highlight all the rows that are first order. Okay, so now these are the first orders and these are the rows that we're interested. And then what we basically did is we said that if your order date is equal to customer preferred delivery date, then you assign the value 1, else you assign the value 0. So since we are only considering these four rows, is this equal? No. So this will assign a value 0. Is this equal? Yes. So 1, 0 in this case, right? These two are not equal. And again, 1 in this case. So now once you have this, then you just, if you go ahead and calculate the average, so that is going to give you 2 divided by 4. So if I just go ahead and do average of this entire thing, that is going to give me the average, but we need percentage and that too rounded to 2 decimal places. So for percentage, you just multiply this by 100 and then round this entire thing to 2 decimal places, and this should be aliased as whatever is required in our output. Let me see what it is saying. So in our output, it should be called immediate percentage. Okay, so as immediate percentage, I think this looks good. Let me go ahead and run this. Let's see what do we get. Okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it if it passes all the test cases. Okay, so this is accepted and this is the beginner level solution. Now let's look at how the solution will look like for an intermediate skill level at SQL. Okay, let me go ahead and remove this entire thing so that it's easier for us to develop from scratch. Now, same logic, how an intermediate will think about it. So our first step was find the first order date. Okay, so they will also try to find the first order date by, okay, from this table called delivery, let's group by the customer ID, and let's return customer ID and the minimum of order date, because that is going to give you the first order dates. Now they are, instead of performing a join, they will think that okay, the second step is we are only interested to keep the first orders. So this means we need to perform a filtering, and since the filtering should be row by row, we need to use the where clause. So if I do where, right, so if this entire thing again goes into parentheses, but this time not to perform a join, we do is where your combination, so where your combination of customer ID and order date is in this one. So what does this mean? So whatever you have in the table, if you perform this filtering, that your combination of customer ID and order date, so combination of customer ID and order date are the ones that resembles their first order date. So that is again this part. And if I just write and complete this code, so from this table called delivery, we are keeping only those rows where the customer ID and order date combinations is in the customer ID and their first order date combinations. And let's return all the rows for this. So select star and let me go ahead and run this and let's see if we end up with the highlighted rows in Excel that we have. Okay, so if we look at our output, let me drag to the left. So if you look at it, right, so these are the same four rows that are highlighted right now here. And after this, they are going to do the same thing that we did in the beginner level. Okay, so let me go ahead and run this. Let's see what do we get. So again, this is accepted. Let me go ahead and submit it to pass all the test cases or not. This is accepted as well. And this is how a intermediate would solve this. Now, if you are advanced in SQL, then what a person is going to do using the window functions. Again, here they will do the same thing, but let me go ahead and delete these two parts. Again, the concept remains the same, that find the first order date. So they will do this by ranking, that okay, for every customer ID, let me rank their orders based on their order dates. So for customer ID 1, this is going to be their first order and this is going to be their second order rank. So this is what we have for customer ID 1. For customer ID 2, this is going to be their first order and this is going to be their second order. For customer ID 3, this is going to be their first order, this is going to be their second order, and since for 4 there is only one order, this is going to be their first. Now, keep only first orders. So wherever your order rank is equal to 1, that means we are only going to keep that. And then after this, we can simply go ahead and find percentage immediate. So let's look at how the solution will look like in that case. So if I again, let me go ahead and remove this entire thing. So from this table called delivery, let me rank. So how do we rank? Select all the columns, because we are adding another column called order rank, and there are three different ways. And don't worry if you are not following this along at that moment, we are going to learn this in detail, but just a brief overview. There are three different ways to rank in SQL. First one is a rank function, second one is called dense rank, third one is called row number. That there is a difference, but just remember that in this case dense rank is a best solution, because it won't skip a rank if there is a tie. Dense rank, and whenever we are writing a window function, we need to write over clause, and for every customer we need that. So that is why we need to create partition by customer ID, and the first order should come first. So order by order date in ascending order, and let's alias this as order rank. Okay, let me go ahead and run this. Let's see what do we get in this case. So okay, wrong answer, not a problem, but still not complete yet. Let's see our output. So if you look at it, right, so for every customer ID you have ranks 1 2, like which is their first order, second order, etc. So now we can treat this entire thing as a table. So what we can do is we can put this into parentheses, that okay, so this is what we have, and then we are also, this is a table. So we can write from this table, this entire thing, the value of this is this table that we just got. We are only interested in keeping the first orders, right? The second step of our solution. So where order rank is equal to 1, let me go ahead and do a select star so that we can see what do we get in our output. Select star. Okay, so let me go ahead and run this. Let's see what do we get. Okay, so these are the 4 rows that we again got the same 4 rows, and then we can simply go ahead and calculate the percentage just like we calculated in the previous 2 cases. So okay, let me go ahead and run this. Let's see what do we get in this case. So this is again accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. This is accepted, and this is how we do it. So you see how by using the same logic, 3 different people at different skill levels are going to solve this problem, and how the solution becomes compactor and compactor. But if you see, there is no difference in the logic. The only difference comes in the functions that they choose to do this. So that is why you do not need to think something extraordinarily to become a pro in SQL. You just need to learn more and more functions and then try to optimize your solutions. So this is the 22nd question of the series, gameplay analysis part 4. And if I look at the companies this question has been asked in, so Adobe and GSN Games, let's look at what the question has to say. We are given a table called activity with 4 different columns: player ID, device ID, event date, and games played, and the data types being integer for first 2, date, and then integer for the last one as well. The combined columns player ID and event date is the primary key, that is combination of columns with unique values of this table. This table shows the activity of players of some games. Each row is a record of a player who logged in and played a number of games, possibly 0, before logging out on some day using some device. We are asked to write a solution to report the fraction of players that logged in again on the day after the day they first logged in, rounded to 2 decimal places. In other words, we need to count the number of players that logged in for at least 2 consecutive days starting from their first login date, then divide that number by the total number of players. Okay, let's go through this example and see what do we need in our output. So here we have various players, their different device IDs, their event dates, and the number of games they played. So what is the fraction of people who from their first login date logged in at least 2 consecutive days? If I look at player ID 1, their first login date was 1st March 2016, and the next login was on 2nd March 2016. So player ID 1 logged in for 2 consecutive days from the first login date. For player ID 2, since there is only one row, obviously we are going to ignore them. And for player ID 3, the first login was on 2nd of March 2016, but the next login was on 3rd of July 2018. So not consecutive days. So one out of three players have logged in 2 consecutive days at least from their first login date. So 1 out of 3 is 0.33 rounded to 2 decimal places, and that is what we have in our output. Let us switch to Excel and try to develop a logic to solve this question. So here is the table activity, and these are the information exactly same as what we have in our question. Then the logic should be, firstly, we are concerned about the first login dates of every player ID. So our step 1 should be to identify first login dates, right? Okay, so once we have the first login dates of every player, then our step 2 should be identify the players that have logged in the next consecutive day from their first login day. So identify players, and then once we identify the players, step 3 would be find the fraction. The first step is find the login dates. Just like our previous video, the way to do that is group by your player ID and find the minimum of the event date, and that is going to give you the first login dates. So let me switch back and let's do, okay, from this table called activity, if I group by the player ID, group by the player ID, and then return the player ID and minimum of the event date, this is going to give me first login date. So let me alias this as FLD, which stands for first login date. And if I go ahead and run this, let's see what do we get in our output. So if I drag it above, so our output is for every player ID, we have the first login days. I'm going to call it T. So let me just make that table here so that it's easier for us to visualize everything at one place. Okay, so this is the table that we have, table T, where for every player ID, we have the first login dates. Now, step 1 is complete. Step 2 is identify the players which from their first login dates logged in at least one time more in the consecutive date. So for people who followed my previous video, it might look similar that we can just go ahead and add this first login dates here and then perform a where clause. But it is slightly different because here we are also concerned with the next date. We are not only talking about the first login date, the next date from the first login date, there should be a login as well. So those are the players that have logged in at least 2 times consecutively from the first login date. So to do that, we need to apply a join, but in a smart way. So let's try to do that. So we were calling this table as T. So let me put this in parentheses, and this is our table T. Now, what do we need to do is from, so let me just drag it down. It's easier for us to view. From this table, our initial table activity, what we are doing is we are left joining because we are trying to identify the players who have logged in the next day as well from their first login day. So left join this table, the table T that we just created here, to this table and this table, we are performing a join. Firstly, how are we going to perform a join? Player ID is equal to player ID. So on, let me alias this activity as, let's say, A, on A dot player ID is equal to T dot player ID. Okay, but we also need to make sure that the login was made on the next day as well. So just see how the join is working. So activity and table T, it says, okay, let's go row by row. Player ID 1 is equal to player ID 1. Okay, that makes sense. This row is not providing us as much information as we want. Our main concern is whether from this first day there is another row for the second or the next day where the same player ID has logged in or not. So what can be done? Think about it. Apart from comparing the player IDs, we also do that, okay, from your event date, subtract one day and try to see whether the first login date is present in the table T for that particular player ID. Now, some of you might be confused that why we are subtracting one day and not adding one day. Just think about it. Here, we for a fact know that player ID 1 is a person who has logged at least 2 times from their first login date. Let's say if I do add one day here. So for player ID, it is going to find a match, and when it is adding one day, so it will become this will become 2nd of March 2016. But will that find a match in this? No. If I go to this row, 2nd of March, when you add one day, it is going to become 3rd of March 2016. Will it find a match in this table? No. So you are not going to find any match. That is why if you apply a clever logic that instead of adding one day, you subtract one day. So here, if you subtract one day, you end on February of 29, 2016. Yes, you do not have any match in this case, but when you subtract one day from 2nd of March, that is going to give you the 1st of March 2016, and that is present in this table T. Similarly, you can do the same for this. So this is only one row. So once you subtract one day from here, this is going to be 24th of June 2017. Obviously not here. For this, first login is 2nd of March 2016. Subtract one day, 1st of March 2016, not here. Again, this one, not here. So you see, if you perform a join using where player ID from activity table is equal to player ID from the table T, and one day minus the event date column from the activity table is equal to the first login date, then you can identify the player IDs who actually logged in the next day from their first login dates. So what I'm doing is, now once we identified that we need to subtract one day, how can we do that in MySQL? So simply there is a function called date sub. So if I do and date subtract, so it will subtract something. From which column we are going to subtract? The event date column coming from the activity table. So a dot event date, and then you need to subtract. Remember, in our series in few videos back, we learned that just by doing -1 won't be a good way to do. Always write interval one day. So it will subtract one day out of it and not do it mathematically, because these are dates. So we write interval one day is equal to T dot first login date. And let me go ahead and select. So let me keep all the columns from the activity table, and we are only concerned about the player IDs from the table T. So if I go back and keep T dot player ID, let me go ahead and run this. Let's see what do we get in our output. Let me drag it to the left and above so that we are able to visualize properly. Okay, 1 is equal to 1, but 1 they subtract from this, that is not here. So there it won't find a match, and there is null. 1 is equal to 1, and 1 day subtracted from this is present in the first login date of the table T. So that will be populated 1. And for everything else, if you cannot find the match, so null, null, and null. Okay, so since now from this we can get the numerator as well as the denominator. How? Just count the number of distinct values in the player ID column. So this is going to give you 1. Count the number of distinct values from the player ID column coming from the activity table. That is going to give you the total number of people, and that is going to give you the fraction. So if I go ahead and do this, that instead of count, right? So count distinct of player ID coming from the table. So T dot player ID divided by count of distinct player ID column coming from the activity table. So that is what we get. Let me alias this as fraction, but we also need to round this to 2 decimal places. So what do we do is round this entire thing to 2 decimal places. Let me go ahead and run this. Let's see what do we get in our output. Okay, so if I drag it above, so this is accepted. Our output is same as expected output. Let me go ahead and submit it so if it passes all the test cases or not. So yeah, this is accepted, and this is how we do it. Now, using the same logic, we can use window functions as well to do this, or we can use multiple subqueries to do this as well. Try this using the window functions or the subqueries or any other method that you think can solve this question as well. So yeah, this is the 23rd question of this series called number of unique subjects taught by each teacher. And if I look at the companies, this question has been asked in Cape Gemini. Okay, let's look at what the question has to say. We are given a table called teacher with 3 different columns: teacher ID, subject ID, department ID, and all of them has a data type integer. The combined column subject ID and department ID is the primary key, that is combination of columns with unique values of this table. Each row in this table indicates that the teacher with teacher ID teaches the subject ID in the department ID. We are asked to write a solution to calculate the number of unique subjects each teacher teaches in the university. Order of the result does not matter. So let's look at the example here and try to see what we can get in our output. We have certain rows for various teacher IDs, their subject IDs and the department IDs, and we need to output for every teacher how many unique subjects are being taught by them. So for teacher ID 1, there are two unique subjects with subject ID 2 and 3. Their departments are different, but what we need in our output is number of unique subjects each teacher teaches in the university. So 1 teaches 2 and teacher ID 2 teaches 1, 2, 3 and 4. So 4 different subjects, and that is what we have in our output. So all you have to do is group by the teacher ID and count the number of distinct subject IDs. So if I go ahead and do from this table called teacher, if I group by the column called teacher ID, and if we are grouping by teacher ID, we can also return that column. This is what we learned about group bys in this series earlier as well. So count of distinct subject ID, and this should be aliased as count. So as count, and if I go ahead and run this, let's see what do we get in our output. So this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how we do it. So very simple question. All we had to do was group by the teacher ID and count the number of distinct subject IDs. The reason being we need to find the number of unique subjects, and this is one way of doing it. So this is the 24th question of the series called user activity for the past 30 days part 1. And if I look at the companies this question has been asked in, so Facebook, Bloomberg, Zoom, kind of an important question. Let's look at what the question has to say. We are given a table called activity with 4 different columns: user ID, session ID, activity date and activity type, and the data types being integer for the first two, date and then enum. This table may have duplicate rows. The activity type column is an enum category that can take values open session, end session, scroll down or send message. This table shows the user activities for a social media website. Note that each session belongs to exactly one user. We are asked to write a solution to find the daily active user count for a period of 30 days ending 27th of July 2019 inclusively. A user was active on some day if they made at least one activity on that day. Order of the result does not matter. Let's go through this example and see what do we need in our output. So here we have several users, their different session IDs, their dates and activity type. And 30 days before 27th of July 2019, including this date, we need to say that, okay, on every particular date, how many different users or unique users were active. So if you just calculate the 30 days before this date is going to be 28th of June 2019, because we need to include those two dates as well in that 30-day period. So on or after 28th June 2019 and on or before 27th of July 2019, we need to keep only those rows. So if we look at it, this 20th of July 2019 and 21st of July 2019 lies in that period, but 25th of June is before 28th of June and it is falling outside that bracket. So we are only concerned about these two dates, and then for each of these two dates we need to find the number of unique users. So on 20th of July 2019 there are two different unique users, user ID 1 and 2. On 21st of July 2019 there are again two different unique users. So that is what we have in our output. So the first step of this is we need to perform a filter using this activity date, and we have to say that, okay, whenever your date is between 30 days before this and this date, then you only keep those rows. So if I go ahead and perform the filtering, so from this table called activity, we are only going to keep those rows where activity date, so activity date is between includes these two dates. Here you see, right, it says inclusively. So whatever dates you write between A and B, so A and B will also be included. So between 30 days before this and this date. So how to subtract days from a date column? We learned about this. We can use date sub, then from 2019 July 27 we need to subtract 30 days, interval 30 day, And so this is one day, 30-day before this, 27th of July 2019, and 2019 07 27. Okay, so what is this going to do? This is going to keep only those rows which are in this date range. Let me go ahead and do select star so that it's easier for us. Okay, if I run this, let me drag it above and let me drag it to the left. So now we are only left with those rows which are in that date range. And we saw that the 25th of June part was not in that date range. Now, once we are here, then all we have to do is we can group by the activity date and count the different number of or the unique number of user IDs. So if I go ahead and do group by activity date, activity date, and I'm going to return the activity date. So return, because for every activity date we need that, and this should be aliased as day, because in our output this is aliased as day. So as day, and then we need to count distinct user ID, and this should be aliased as active users. Okay, let me go ahead and run this and let's see what happens. Now, even though this question says for a period of 30 days ending 27th of July 2019 inclusively, and that is what we are doing, we are subtracting 30 days from it. And even after running it, it says accepted. But if you submit this, it is going to fail. You see, wrong answer. Why did it fail? The reason being we missed something. Let's look at what does it say again. Daily active user count for a period of 30 days ending 27th of July 2019 inclusively. Now think about it. 27th of July 2019, this is what we have, and we are subtracting 30 days out of it. We know if you do it on your fingers, 30 days before 27th of July 2019, including 27th of July 2019, is going to be 28th of June 2019. But if you subtract 30 days directly from this, it is going to land you on 27th of June 2019. Think about this in a better way. For example, let's say today is 14th of January 2024. I say subtract 2 days from today. That is going to land you on 12th of January 2024. But if I say 2 days before 14th of January 2024, that includes 14th of January 2024, then it should go to 14th of January 2024 and 13th of January 2024. So you say that is a problem. That is why the fix for this is instead of subtracting 30 days, it should be actually 29 days. Now let me go ahead and run this. So obviously accepted, not a problem, but if now submitted, it will pass. See, this is accepted and this is how we do it. So we need to be very careful that even though it says something, but it can mean entirely different thing, or you might miss something. So be very careful about this, because these are the places where interviewer is checking your knowledge and conceptual understanding. So this is the 25th question of the series, product sales analysis part 3. And if I look at the companies this question has been asked in, so Amazon, kind of an important question. Let's look at what the question has to say. We are given a table called sales with 5 different columns: sale ID, product ID, year, quantity, and price, and all of them have a data type integer. The combined column sale ID and year is the primary key, that is combination of columns with unique values of this table. Product ID is a foreign key, that is a reference column to the product table. Each row of this table shows a sale on the product ID in a certain year. Note that the price is per unit. We are also given a second table called product with 2 different columns, product ID and product name. Product ID is the primary key, that is column with unique value of this table, and each row of this table indicates the product name of each product. We are asked to write a solution to find the product ID, year, quantity, and price for the first year of every product sold. Order of the result does not matter. Let's look at this example and see what do we need in our output. So we are given sales table and we have certain products, their year, quantity, and price, and also the product table. And in our output for every product in their first year, what is the product ID, their first year, quantity, and price. If we look at product ID 100, the first year it was sold is 2008. The quantity sold was 10 and the price was 5000. For product ID 200, only one row. So first year sold is 2011, quantity 15, price 9000. And that is what we have in our output. If you think about it, you don't even need this second table to solve this question. You can solve the entire question just by using this table. But then you might think, why is this second table given then? Because just remember, this is a part 3, so there are another parts of this question where the second table might be useful. That is why the second table is given. Okay, so people who are following this series thoroughly, this question is exactly based on the same logic as video number 21 and 22. So let's switch to Excel and try to develop a logic for this. So this is the same table sales, and first step of this logic should be to find for every product ID what is their first year of sale. So product first year, right? First year of sale. And then after you have that, second step should be to keep only those rows where your year is equal to first year, right? And once we have this, then our step 3 should be to get required columns. So this is the logic that we need to follow. Okay, now this can be done in multiple ways. In video number 21, I showed you the beginner, intermediate, as well as advanced level solution. Okay, so step 1 is product's first year of sale. So every product, how can you get the first year of sale? So from this table called sales, if I group by the product ID, return the product ID, and get the minimum of the year, that is going to be the first year that product was sold. So we can alias this as first year. Let me go ahead and run this. Let's see what do we get in our output. So obviously not yet complete, but for every product we have their first year when they were sold. Now what we can do is we can treat this as one table. Let's call this table T. So this is called table T. And now what we can do is we should add the first year of sale. So here let's add a column called first year, and for every product we need to add the first year this particular product was sold. So we can have a table called T. Let me get that here. So this is the table T that we just saw. And then if we join these two tables on product ID, we can get the first year of every product. So if I do, okay, so we are treating this as a table, and then if I do from this table called sales, let's alias this as S, left to join this table, this entire thing as table T on S dot product ID is equal to T dot product ID. And if I keep all the columns from the sales table, so select S dot star, all the columns from sales table, and let me just keep the first year from the table that we created. Okay, let me go ahead and run this and let's see what do we get in our output. So if we look at our output, let me drag it above and to the left, easier for us to view. So this is what we have. So sale ID, product ID, year, quantity, and price. And for every product, what was their first year they were sold. So here, same thing like how the join is happening. So product ID 100 goes into T and tries to find, okay, 100 first year is 2008. So it will populate 2008. Similarly, again, next row 100 finds 2008. Okay, then 200 finds here, okay, product ID 200, the first year is 2011. Okay, so once we have this, then our step 1 is complete. Then our step 2 is to only keep those rows where year is equal to first year. So this is one of the rows that where year is equal to first year, right? So let me just highlight this so that we know that, okay, this is one of them that we need to have. Here your year is not equal to first year, so we are ignoring this row, and here your year is equal to first year, so again this one is also required. Okay, so these are the two rows and this is the step 2. So let's perform this. How can we do this? Using the where clause. So if I go ahead and do where is this year column coming from sales. So s dot year is equal to first year is coming from the table called T. So T dot first year. Let me go ahead and run this. Let's see what do we get in our output. So if we look at it, we would be left with only those two rows. Yes, now these two rows are there, and from these two rows we only need certain columns in our output. Product ID, first year, quantity, and price. So product ID is coming from the sales table, so it should be s dot product ID. Then we need first year coming from table T. Then quantity and price both belong to say table S. So quantity and s dot price. Okay, let me drag it to the left and let me go ahead and run this. Let's see what do we get in our output. So this is how our complete solution looks like, and this is accepted as well. Our output is same as expected output. Let me go ahead and submit it so it passes all the test cases. So see, this is accepted and this is how we do it. And we can also do this, apply the same logic using a where clause, but we do not have to perform all this. So what we can do is, instead of doing and making another table, what we can do is, from this table called sales, we are only going to keep those rows where the combination of product ID and the year, combination of product ID and year. So combination of product ID and year is in, for every product ID, what is their first year of sale. So if I go ahead and write where combination of product ID and year is in, and then what do we need to do is, from this table called sales, if I, from this table called sales, let me just, okay, from this table called sales, if I group by the product ID, and then for every product ID, so select product ID and the minimum of year is equal to your first year. Then, so basically what we are doing is, from this table called sales, the table called sales, if I just drag it to the left, okay, so this is your sales table. I am doing is, the combination of product ID and year is should be the first combination of product ID and their first year of sale. So if I go ahead and keep only, so if I go ahead and run this, let's see what do we get in our output. This is a runtime error. Why? Because we are using aliases which we are not using. So s dot product ID is good, but t dot first year does not make any sense because there is no t here. So what we can do is, we can just go ahead and remove all these aliases. It does not matter to us now because we are not performing a join. So if I go ahead and run this, so if I look at it, our output, product ID, year, quantity, and price, still says wrong answer. Why? Because we need to alias this as whatever is required in our output. So this should be first year. So if I go ahead and write as first year, and then let me go ahead and run this, let's see what do we get here. So now this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So you see, this is accepted as well. So these are the two ways you can do. You can also do this using a ranking function. So what you can do is, for every product ID, you can have a column called rank, and this would be assigned rank 1, this would be assigned rank 2, because this was sold earlier and then this was sold. And then for product ID 200, this will be assigned rank 1. Then you can perform the same thing. So we found the product that was first year of sale by using rank. Then wherever your rank is equal to 1, it basically is your year is equal to first year, and then you can get the required column. Let me know how the solution will look like in that case. So this is the 26th video of this series called Classes More Than 5 Students, and let's look at what the question has to say. We are given a table called courses with two different columns, student and class, and both of them have the data type variable characters. The combined column student and class is the primary key, that is combination of columns with unique values for this table. Each row of this table indicates the name of a student and the class in which they are enrolled. We are asked to write a solution to find all the classes that have at least 5 students. Order of the result does not matter. Let's go through this example and see what do we need to get in our output. So here we have several students and various classes they are enrolled into, and we need to find all the classes that have at least 5 students enrolled in it. So if we look at math, so math has 1, 2, 3, 4, 5, and 6. So 6 different students are enrolled in math. So math should be definitely in our output. English only has 1. Biology only has 1. Computer only has 1. So the only thing that we need in our output is math, and that is what we have. To do this question, the first thing that we should do is, from this table called courses, we should group by the classes and count the number of students that are enrolled in each of these classes. So if I do, from this table called courses, if I group by the class, right, and then if I return, so if I go ahead and do return the class, and let me count the number of students. So if I count the number of student, and let me alias this as number of students, and let me go ahead and run this, and let's see what do we have in our output. Okay, if I look at it, so for every class we have the number of students, and obviously we only need to keep those where number of students is at least 5. Okay, So this is a case where we need to filter based on an aggregate. After performing a group by, we need to keep only those rows where our number of students is greater than equal to 5. Okay, in that case, using where won't work. Why? Because, for example, if I go ahead and let's say our question was simply find out all the students who are enrolled in, let's say, class math. So here, row by row, you need to find that wherever your class is equal to math, you return the student. But here it is not asking that. It is asking the class which has at least 5 students enrolled. So from this table called courses, group by the class and then only keep those classes where the aggregate, where the count of the student is greater than equal to 5. So in that cases, we need to use having. So having count of student greater than equal to 5. After performing the group by, it will say, okay, the count of student is greater than equal to 5 for only math, and then you return the class math. And if I run this, let's see what do we get in our output. So now this is accepted. Also, this will also tell you why where clause is written before group by and having clause is written after group by. Because if you think about it, when I said find me all the students who belongs to class math, we had to do from this table called courses where class is equal to math, return the student. That is why we are performing the filtering using where before grouping by, but having is used to filter after you perform the groups. So that is the reason why where clause comes before group by and having clause comes after group by always. Let us go ahead and submit it to see if it passes all the test cases. So this is accepted and this is how we do it. Not a very difficult question, but it clears our concept of when to use where clause and when to use having clause and what is the difference between them and why where comes before group by and having comes after group by. So this is the 27th video of this series, and if I look at the companies this question has been asked in, so this question has been asked in Tesla interviews. Kind of an important question. Let's look at what the question has to say. We are given a table called followers with two different columns, user ID and follower ID, and both are of data type integer. The combined column user ID and follower ID is the primary key, that is combination of columns with unique values for this table. This table contains the IDs of a user and a follower in a social media app where the follower follows the user. We are asked to write a solution that will for each user return the number of followers and return the result table ordered by user ID in ascending order. So let's look at the example and see what do we need in our output. So for every user, we need to find out the number of followers and it should be ordered by user ID in ascending order. So for user ID 0, how many followers user ID 0 has? 1. User ID 1 has 1 follower, user ID 2 has 2 follower, and therefore our output should be 0 1 1 1 2 2, and that is what we have in our output. So to do this question, what do we need to do is from this table called followers, so firstly we need to group, then count, and then order. So from this table called followers, we need to group by the user ID and then return every user ID because we need that in our output. If you see, we need the output, then we need the followers count. How do we get the followers count? We count the follower ID and alias this as followers count, and we need to sort this by user ID in ascending order. So we do finally order by user ID in, if you do not write ASC, it is by default ascending order, but you can write as well. I am writing is just for explanation purposes. Okay, so I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted as well, and this is how we do it. Not a very difficult question, but all we had to do was group by the user ID and then count the number of followers, alias this to followers count, and then order by user ID in ascending. If you do not write it, by default, it is going to order in ascending order. This is the 20th question of this series called biggest single number. And if I look at the companies, so this question has been asked in Apple interviews a lot of times. Okay, so let's see what the question has to say. We are given a table called my numbers with one column number and the data type being integer. This table may contain duplicates, that is there is no primary key for this table and each row of this table contains an integer. A single number is a number that appeared only once in this table. We are asked to find the largest single number, and if there is no single number, report null. Remember, this is very important line. Let's look at this example and see what our output should look like. So here we are given certain numbers and we need to find out the biggest number that only appeared once in this table. So 8 appeared twice, 3 appeared twice, 1, 4, 5 and 6 appeared once. So what is the biggest number out of the numbers that appear only once? 6, and that is what we have in our output. There can be a second case as well. What if the example is like this? Here 8 appears twice, 7 appears twice, 3 appears thrice. So there is not one number that appears only once. So in that case your output should be null. So by now we know that our first step should be we need to group by this number and try to count each number how many times they appear. How can we do that? So it's very simple. What we can do is we can do from this table called my numbers, we can go ahead and group by the number column and then return the number column and do count star, and let's alias this as count. Okay, let me go ahead and run this. Let's see what do we get. This is not yet complete. We are just building our logic step by step. So now we have in our output the number and the number of times they appear. Okay, now once we have this, we are only interested in those numbers whose count is equal to 1. Okay, so we remember that once we group by and then if we want to do a filtering, we need to use having, not where. Why? Because we are going to do a filtering based on an aggregate. So we are grouping by and then we can do having count is equal to 1. So here if I do having count of star is equal to 1. Okay, let me go ahead and run this. Let's see what do we get here in our output. Okay, so now we are only left with those numbers which only appeared once. Okay, now since we know the count of each of this is 1, we do not require this part, right? Because this is redundant. So we return all those numbers whose count is equal to 1. So they appear only once in this table. Okay, now once we have those numbers, then out of this, we need to return the maximum. Now from this point, we can take two routes. The first route is we need to order this entire output in descending order and then the first one, the biggest one. So what we can do is we can do order by the number in descending order. So if I run this, so this will be sorted in descending order. So 6 comes very first. Now we need the biggest number in our output. We need the largest single number. So how can we limit this to only return the largest single number? We can do limit 1. So out of all the input, just limit the first row. And if I go ahead and run this, let's see what do we get in our out. So for our first example, this passes the test case. Our output is 6, expected output is 6 as well. But this is not going to pass the second case. The second case that we looked at was this, that if there is nothing, you need to return null. In our case, it is going to return an empty thing. Why? Let us switch to Excel and try to learn that. So this is the first example that we had where once we grouped by and counted how many times each of these number appears in this table. So we had this and we were only interested in the count star being 1. So we were only interested in these 4 highlighted ones, and out of this we got the output 6 after rearranging it. Okay, once we are done with this, but the problem is coming with the second example. So this is the second example where once we count that this all these numbers appear different number of times and none of these numbers are appearing only once. So just let me go back to the code and see what the problem is having. Once we group by and try to filter where count star is equal to none. In this second example, this group by, if it does having count star is equal to none, what is this going to return? Since there is no row that satisfies this, it is going to return you an empty thing. So this entire thing is returning you an empty thing. And then Once you order by nothing, there is nothing to order by, so it remains empty. You limit one, again remains empty. So that is why in our second case, our output is coming out to be an empty, but in these cases, we need the output to be null. How can we do that? So the trick is, so if I put this in parentheses and write return this entire thing, and this should be aliased as whatever is required in our output. So as number, this should be the name of the column, and let me go ahead and run this. Let's see what do we get. So now it is accepted in both of the cases. So here in this also it is returning you null. Why? Because in the second case, this entire thing we just saw that is returning an empty thing. And once you do a return of an empty thing, then this returns you a null value. So this is the first solution that you can do. There is another method that you can apply. So let us go back to the point where I said that, okay, after this you can take two approach, and that point was this, that after having this we are only interested in this one. So basically we are here, we are at this point, right, or at this point, depending upon the example. Now obviously out of these numbers we are only interested in getting the maximum of this. So what we can do is, the group by thing, we can treat this as a table. So we can do, okay, this entire thing, in parentheses is our table. Let's alias this as table T, and from this table T, what do we need? We need the maximum value. So return the maximum value from the number column. So T dot number, and let's alias this as number. Let me go ahead and run this. Let's see what do we get in our output. So now this is also accepted in this case. So maximum of things, and again, if there is nothing, it will maximum always returns null. Let me go ahead and submit it to see if it passes all the test cases. So see, this is accepted, and this is how we do it. Even though this says easy, it is a very tricky question. And what makes it tricky is this statement that if there is no single number, report null. Had it been not the case, it would have been very easy. But we learned that, okay, either you can do a return of a entire thing, and returning an empty thing gives you null, or you can use the max function to do the same. So this is the 29th video of this series, customers who bought all products. And if I look at the companies this question has been asked in, so Amazon and Adobe, kind of an important question. Let's look at what the question has to say. We are given a table called customer with two different columns, customer ID and product ID, and both of them have data type integers. This table may contain duplicate rows. Customer ID is not null. Product ID is a foreign key that is a reference column to product table. This is the most important line of this question. Let's look at the second table called product with one column, product key, and the data type being integer. Product key is the primary key, that is column with unique values for this table. We are asked to write a solution to report the customer IDs from the customer table that bought all the products in the product table. Order of the result does not matter. Let's go through this example and see what do we get in our output. So here we have two different products in the product table and various customer IDs and the product key, basically what they bought. So if we look at it, what all customers bought both these products, 5 and 6. So customer ID 1 bought 5 as well as 6. So customer ID 1 should be in our output. Customer ID 2 only bought 6, so not in the output. Customer ID 3 bought 5 and 6. So customer ID 1 and 3 should be in our output. So to solve this question, we need to learn an important concept about foreign keys, because the entire solution depends upon this. Let me switch to Excel and let's try to develop a logic. So when I say this column, product key of customer table, is a foreign key to the product table, this means the values in this column can only take values from this or can be null. So what I mean by that is, since this product key is a foreign key to the product key column of the product table, and the product key column of the product table has 5 and 6, and these are unique values, as the question says that product key of the product table is a primary key, so non-null unique values, so 5 and 6. So values in this product key column of the customer table, since this is a foreign key, can only be either 5 or 6 or can be null. It cannot take a fourth value. Once we know that, then this question becomes kind of easy, because now our first goal should be, for every customer ID, count the different number of products they bought. So what we can do is from this table called customer, group by the customer ID and count distinct product keys. That will tell you the number of different products that each customer bought. So let's go ahead and write this query. So from this table called customer, if I group by the customer ID and return the customer ID and count the distinct number of product key, and let me alias this as count, and let me go ahead and run this. Let's see what do we get in our output. So now for every customer ID we have how many different products they bought. So this is what we get after grouping by the customer ID in the customer table. So this is what we have. Now we can clearly see that customer ID 1 bought two different items, and in the product table there are two different items. Similarly for customer ID 3, but customer ID 2 only bought one item, whereas in the product table we have two different items. So just by this we know that our logic should be to compare the number of items bought by each customer ID to the distinct number of items present in the product table, and we will have the output. So what we can do is, after we group by, then since we are grouping by and we need to compare the aggregate, so for every customer we counted the different number of product keys. Also, why we are using a distinct here? Because this question says this table may contain duplicate rows, so we do not want to count the same product more than once. Since we need to filter, that is only keep those customers who bought all the products in the product table. That means we need to use having to filter. So we can do having this count that we got for every customer ID. So let me go ahead and cut it here. So having count of distinct product keys of the customer, that is distinct product keys, these are the distinct product keys count, should be equal to count of different product keys in the product table. So should be equal to, and there here we need to write return count of product key from the table called product. Okay, let me go ahead and run this. Let's see what do we get here. Okay, so this is accepted. Our output is same as expected output. Now you might realize the importance of this line. Product key is a foreign key, that is reference column to product table. Think about this. If this would not have been mentioned, that product key is a foreign key, so that would mean that this column can take any value. So even though you have 5 and 6 in your product, if let's say one bought say a product called 7 and 8, here if you count for customer ID 1 the number of distinct products that they bought, 7 and 8, that is 2. And here if you go back to your code, so you will count, okay, for customer ID 1 we have two different products bought, which is equal to two different products. But is 7 and 8 same as 5 and 6? No. So you see, you realize the importance of this statement that this is a foreign key. Because this is a foreign key, it can only take values in the product key or can be null. That is why this logic and this code works. Had it not been the case, this question would be really difficult to solve. So yeah, let's submit it. Let's see if it passes all the test cases. So this is accepted, and this is how we do it. So very tricky question, and you realize the importance of one single line and phrase in SQL questions. So be very attentive during interviews. Pay attention, because that gives you a key to what logic to use to arrive at the solution. This is the 30th question of this series, and if you look at the companies this question has been asked in, so Amazon and Coderbyte, kind of an important question. Let's look at what the question has to say. We are given a table called employees with 4 different columns: employee ID, whose data type is integer, name, which is a variable character, reports to, an age, and both of them are integer. Employee ID is the column with unique values for this table. This table contains information about the employees and the ID of the manager they report to. Some employees do not report to anyone, that is, reports to is null. For this problem, we will consider a manager and an employee who has at least one other employee reporting to them. We are asked to write a solution to report the IDs and the names of all managers, the number of employees who directly report to them, and the average age of the reports rounded to nearest integer. Return the result table ordered by employee ID. Okay, let's look at this example and see what do we expect in our output. Here we have various employees, their names, who they report to, and their age. So let's look at who of them is a manager. So obviously there are two people, Alice and Bob, that report to a person with ID 9, and 9 is Hersey. So in our output we need to have the employee ID 9, the name of the manager is Hersey, how many people they report to is 2, and the average mean is 41 plus 36 divided by 2, and that is what we have in our output. Since in our output we also need the name of the person, that is the name of the manager, and here we have the IDs of them. So this is a classic example of using a self join. Now we learned earlier in the series that self joins can be done using inner joins, left joins, right joins, etc. In this case, inner join will be the best case because we are only concerned about people who have the potential to be a manager. Let us move to Excel and try to learn how this join will work. So here we have the employees table, and these are the 4 employees, their names, who they report to, and their age. Okay, so when we do a self join, what do we basically do? So for example, we take the same table and alias this as two different things. So for example, this is aliased as, let's say, A1, and then let us take another exact thing. So another version of this table, let me paste it here, and this, let's alias this as A2. Okay, now what we can do is from, so let me go back and start writing this query. So from this table called employee aliased as A1, let me inner join the employees table aliased as A2 now. So this is a self join on. Here we need to find, okay, reports to. So these are the IDs of their managers, and to get their name, we need to have them joined on the employee ID of the second version. So what I mean by that is reports to. So 9, it goes and look into the second version, that is A2 version, and tries to find out, okay, this is the employee ID 9, this is their name and other information. So we can write on A1 dot reports to is equal to A2 dot employee ID. Okay, let me switch back to Excel again and let's see how this join will work. So here, row by row, it will say, okay, here firstly we have null, which will obviously be ignored. Okay, one thing to note here, do not think that here, let's say there was a fifth row, let's say called null, and like whatever a person's name ABC and reports to say 8, and then averages being 50, let's say. Okay, now do not think that here it will say, okay, null, it will go and find out that, okay, this is also null, so it will perform a null. No, it will perform a join. No, that is not how SQL works. So this will be ignored. So let me just delete this part. Okay, so obviously this one is being ignored. Now cursor moves to row 2, 9, it will find a match and it say, okay, 9 Henry null and 43. So let me go ahead and copy this here, and if we are returning everything, so this is what it will populate. Then again the same thing 9, so here again also the same thing happens, and then again null, so obviously ignored. So since we are performing an inner join means which is common between both of the tables. So this will only keep these two rows. So if I, let me go ahead and highlight this so that it's easier for us. So these two rows are only in our output. Now once we have this, then what do we need in our output? We need the employee ID of the manager, their name, the number of people who directly report to them, and the average age of the people who report to them. So very simple, all we can do is we can start and group by the employee ID, and if I just copy this, so these are the 4 columns that are being coming from the A2 version, right? So in group by the employee ID and their name, and then we can count the employee ID coming from the employees table or the first version, that will give you the number of people who report to them, and then you calculate the average of this. So if I go ahead and do group by the columns coming from A2 version, because A1 versions are the employees and A2 versions employee ID is the manager ID. So we need the managers in our output. So we do A2 dot employee ID, and we also need their names in our output, right? So we need the name, and then we can return the same thing. So A2 dot employee ID as well as A2 dot name. And then since we learned that we can count the number of employee IDs from the A1 version. So count A1 dot employee ID, and that will give you as reports count. Why we are not doing distinct employee ID? Because of the thing that question says that employee ID is the unique values for this table. So basically this is a primary key. So we do not need to do distinct. Okay, once we have the reports count, we also need the average age. So average age is average of A1 dot age. Average, so comma, average of A1 dot age. However, this needs to be rounded to the nearest integer. So what we can do is we can simply write round to nearest integer. So the way to do is round to 0 decimal places. That will round to the nearest integer, and that should be aliased as average age. So average age. Also, this should be ordered by employee ID. So, and this employee ID, what does it mean? It's basically the employee ID of the manager, because in our output we have the managers, right? So we need to write order by A2 dot employee ID. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output, let me go ahead and drag it to the left and to upper so that, okay, so our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how to do it. So even though it says easy question, actually it is somewhat tricky, because firstly we need to know how a self join works. We identified which columns to add to, how to group by, and how to count the number of people reporting as well as their average age, and how to round to the nearest integer. So this is the 31st question of this series, primary department for each employee. And if you look at the company this question has been asked in, so this has been asked in Facebook. Kind of an important question. Let's look at what the question has to say. We are given a table called employee with three different columns, employee ID and department ID, both of them having data type integers, and a third column is primary flag, which is a variable character. The combined columns employee ID and department ID is the primary key for this table. Employee ID is the ID of the employee, department ID is the ID of the department to which the employee belongs, and primary flag is an enum category of type yes or no. So if a flag is Y, the department is the primary department for this employee. If it is N, the department is not the primary department. Employees can belong to multiple departments. When the employee joins other departments, they need to decide which department is their primary department. Note that when an employee belongs to only one department, their primary column is N. We are asked to write a solution to report all the employees with their primary department. For employees who belong to one department, report their only department. Order of the result does not matter. Okay, let's go through this example and see what should be in our output. So here we have a list of various employees, their department IDs and their primary flag. So here, after reading the question, we learned of two conditions. Firstly, if an employee belongs to only one department, that becomes their primary department. If an employee belongs to more than one department, then we need to look at the primary flag whether it is yes or no. So for example, for employee ID 1, only one department, so that is their primary department. For employee ID 2, two different departments, and Y is with department ID 1. So 2 1 should be in our output. For employee ID 3, only one department, so this should be in our output. And employee ID 4, three different departments, and Y is in department ID 3, so that is what we should have. So 1 1 2 1 3 3 and 4 3 is what should we have in our output. This question would have been very easy if this line would not have been written here. So here it says if an employee belongs to only one department, their primary column is N. So this is the way this table stores data. Had it been that if this table stores wherever your primary flag is equal to Y, that is your primary department, then this question is very easy. All you have to do is from this table called employee, wherever your primary flag is Y, return the employee ID and department ID. But here that is not the case. Let me give you an example. So in today's world, there are people who have one phone number and there are people who have multiple phone numbers. I have only one phone number and someone asks me what is the primary number that I should call you. Since I only have one number, that is my primary number or the best number, you can contact me. But there is a person who has, let's say, 5 different numbers. The person can and specify, okay, this is my home number, this is my office number, etc. Similarly here, since you are belonging to one department only, that becomes your primary by definition. But if you have more than one department, then you need to select, okay, this is my primary flag. Knowing the count of the departments every employee is enrolled in is very important. So let's switch to Excel and try to develop a logic. So we learned that step one, which is very important, is count of departments. So count of departments per employee. That is should our main concern. How can we get that? So from this table called employee, if we group by the employee ID and count the department IDs, that will give us the count of department. So if I do from this table called employee, if I group by the employee ID and then return the employee ID and count the department ID, let me alias this as number of department, and let me go ahead and run this and see what do we have in our output. So if we look at our output, we have for every employee the number of department they are enrolled into. So after grouping by, let me copy paste this in our Excel so that it's easier for us to view. So this is the result of the group by. So now for every employee ID, we know the number of departments. What do we need to do is we should, for every employee ID, try to get this number of departments attached to here, because based on that we need to perform a filter, because from these values we are only required to keep the primary departments. That is defined on two definitions. If there is one department a employee is enrolled in, that is your primary department. If the employee is enrolled in more than one department, so you need the primary flag Y. So to do that, we need the number of department columns attached. So basically we can perform a join. So let's call this group by thing as table T. So what we can do is let's put this as entire and treat this thing as a table. So let's call this as table T. And now what we are doing is from the table, so from the table called employee, alias this as, let's say, E, let me left join this entire table. So let me just drag it down. So this entire table T on E dot employee ID is equal to T dot employee ID, and let me keep every column from the employee table, so E dot asterisk, and then let me just keep the number of department column, so T dot number of department. Let me go ahead and run this. Let's see what do we get in our output. So now if we look at it, for every employee, department and primary flag, we also know that the number of departments they're enrolled into. So we see that, okay, one is only enrolled in one department, then employee ID 2 is enrolled in two different departments, etc. So if we go ahead and try to populate it here, so here we will be having number of department, one only enrolled in one, two is enrolled in two, and then three is enrolled in one, and then four is enrolled in 3. Okay, now once we have this, then what do we need to do is we need to perform a filter. Filter row by row. When your number of department is equal to 1, simply return the employee ID and department ID. But if your number of department is greater than 1, then you look at the primary flag. So just look at it. So obviously number of department is 1. So we need these two. So let me just highlight this. Okay, so this is 1. Now for employee ID 2, we have number of departments greater than 1 and primary flag is Y for this row. So this is what we need in our output. Similarly for 3, only 1. So this is what we need in our output. And finally for employee ID 4, 3 different, but Y is in this row. So this is what we return in our output. So yeah, these are the 4 rows that will be in our output. So what we can do is we have these values and then we need to keep only those rows where firstly check that, okay, T dot number of department is equal to 1. So either you check this one or you need to check the two things. Firstly, if the number of department is greater than 1, in that condition you need to make sure that you also check the primary flag. Primary flag is from the employee table, so primary flag is equal to Y. So in these two cases you need to return the E dot employee ID and E dot department ID. Okay, let me go ahead and run this. Let's see what do we get. Okay, let me just drag it above. So this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how I do it. So yes, it is an easy question, but kind of lengthy. And so that is why we need to develop a logic first. The first thing that we did was to perform a filtering in this case. Firstly, we needed to add an additional column called number of departments, because based on that only we can filter, because there are two conditions that we need to look at. When the number of department is equal to 1, that condition is different, and if it is greater than 1, we need to look at additional flag, and that is when we get our output. So this is the 32nd video of this series called triangle judgment, and if I look at the companies this question has been asked in, so Amazon and Apple, kind of an important question. Let's look at what the question has to say. We are given a table called triangle with three different columns, column X, Y, and Z, and their data types being integer for all. In SQL, the combined columns X, Y, and Z is the primary key column for this table. Each row of this table contains the length of 3 line segments. Okay, we are asked to write a query to report for every 3 line segments whether they can form a triangle or not. Order of the result does not matter. Okay, let's look at this example. So here we have two different rows and we have X, Y, and Z values for them, and then based on these values, basically based on these 3 line segments, we need to find out whether these 3 line segments can form a triangle or not. When we are given 3 line segments, how can we check whether these will form a triangle or not? The way to do it is the sum of the two sides should always be greater than the third side. So what it means is X plus Y should be greater than Z, Y plus Z should be greater than X, and X plus Z should be greater than Y. If all these three conditions satisfy, then only those line segments can form a triangle. So for example, if we do that, so X plus Y is 28, which is less than 30, right? So we're not satisfying our very first condition. So these three cannot make a triangle. So this will be no. 10 plus 20, 30 is greater than 15. Okay. 20 plus 15, that is 35 is greater than 10. Okay. And then 10 plus 15 is 25 is greater than 20. So all these three can make a triangle. So no for this and yes for this. And that is what we have in our output. Now, why do you think these kind of questions are asked in FANG interviews, even when you know that you do not need to form any logic in this? You either know how to determine a table based on line segments or you don't. The reason is that it checks whether you know that SQL is not just for data querying and manipulation. You can also perform certain mathematical functions in that. You can do square root, you can do power, you can do absolute values, etc. So let's do that. So from this table called triangle, we need all the three columns in our output. So we can just simply go ahead and write select star, and then we need a fourth column called triangle based on whether they can form a triangle or not. So we can use the if function that we learned earlier in this series, where we need to check one condition, and if that is true, then you return a certain value. If not, you return another value. So now here we need to check three conditions one after the other. That is, X plus Y should be greater than Z, and Y plus G should be greater than X, and X plus Z should be greater than Y. If all these conditions are true, then they can form a triangle. So you return yes. If any of them fails, then you return no. And this should be aliased as triangle. So if I do as triangle, okay, I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. Not a very difficult question. All we had to do was use the if function that we learned, and we already have to know how to check whether 3 line segments can form a triangle or not. Now let me know, if this question would have asked whether these line segments can form a right angle triangle or not, how would you do that? What are the conditions? Basically, you will have to use a Pythagoras theorem. If the sum of the squares of 2 line segments is equal to the square of the third line segment, then you can form a right angle triangle. So you can use a power function in that case. So you see, you can perform various mathematical functions in SQL as well. So this is the 33rd video of this series, consecutive numbers. And if I look at the companies this question has been asked in, so Adobe, Amazon, Facebook, Apple, Uber. So kind of an important question. Let's look at what the question has to say. We are given a table called logs with two different columns, ID whose data type is integer and number who is a variable character. In SQL, ID is the primary key for this table. ID is also an auto increment column, and this is very important for the logic that we are going to develop. We are asked to find all numbers that appear at least 3 times consecutively. Order of the result does not matter. Okay, let's look at this example. So here, what is the number that has at least appeared thrice consecutively? Number 1 has appeared consecutively at least thrice, and then number 2, no. So only number 1, and that is what we have in our output. In this question, what we need is, for that particular row, what is the value in the number column in the next row as well as the next row? Because if the values in the current row, next row, and the next to next row is same, that means that number has been repeated at least 3 times consecutively. Now, for people who know advanced SQL, this can be done using a window function as well called lead, but we are going to solve this using our basic join, and that to a self join. So basically we are going to join this table on itself 2 times to get what is the value in the next row as well as the next to next row. Let me switch to Excel so that we can develop the logic. So what we need is, for in this particular row, if I can get the value of the number column in the next row here and value of the number column in next to next row here, then I can compare that. Okay, if these three are same, that means this number has been repeated at least thrice. So how do I perform a self join? Let me just copy this part, copy this here and paste it here, logs table, and let's alias this as L1 so that it's easier for us to see L1, and let me alias this as L2. Okay, so now if I do L1 dot ID, so ID column of this L1 version plus 1 is equal to L2 dot ID. Why I'm doing a plus 1 is that, here, just think about it. I need what is the value in the second row. So here is, this is ID equal to 1 and the number here is 1. Now I want the second row, right? So what is the ID equal to 2? What is the value in the number column? So if I do, let me just go back and write this query so that I can explain it further. So if I do from this table called logs aliased as L1, let's say do a left join of logs, but this time aliased as L2, and this is what we call a self join, joining a table on itself, and we are doing on L1 dot ID plus 1 is equal to L2 dot ID. So see, how is this going to work? So I'm saying L1 dot ID, so 1 plus 1, so that becomes 2, and it goes and finds where is 2. So 2 is here and it will populate, okay, whatever is here as well as the number in the number column. So here it will populate 2 and 1. Similarly, it will do L1 dot ID, so 2 plus 1, 3, tries to find out, okay, 3, we have 1. So here if we will be having 3, 1. Now for this 3, it will try to find out 4, 2, right? So you see how this is populating the value in the next row. So now we have this, right? So these are the numbers in the next row. Similarly, if we do the same thing again, that there is another one called L3, and we do L2 dot ID plus 1 is equal to L3 dot ID, we are again going to have what is the value in the third row as well. So this is what you will have after performing a join. So if I just do and then left join logs aliased as L3 and on same stuff, so L2 dot ID plus 1 is equal to L3 dot ID, and if I just do select star, right, so select star, so it basically return everything. This is what we will get in our output. So if I just drag it above and here, so this is the same thing that we see here. So now it is very simple to know, okay, where we have at least 3 repetitions. So if your L1 dot number is equal to L2 dot number and L2 dot number is equal to L3 dot number, that means that particular number has been repeated at least 3 times. So we can do here, after performing a join, we need to make sure we are only left with those rows where L1 dot number is equal to L2 dot number and L2 dot number is equal to L3 dot number. Let me go ahead and run this. Let's see what do we get in our output. So now we are left with only one row, and this is this row, because only in this row we have equality, whereas this is equal to this is equal to this. So we have that, and then we simply need to return the number part. So because in our output we need the number that has repeated at least 3 times. So here we can just go ahead and do return L1 dot number and alias this as consecutive numbers. And if I go ahead and run this should be accepted, but still not complete yet because we are missing one thing. Even though this says accepted, the thing is, just think about it. Here, instead of this one repeating thrice, had it been, this one is also one, then we would be having this another row number 2, where this instead of being 2 would have been 1 as well, right? So here if you have 4 and 2, if instead of that it was 4 and 1, here we would be having 4 and 1. So if you do L1 dot number is equal to L2 dot number and L2 dot number is equal to L3 dot number, then you would be left with 2 rows, but you do not need the repetition in an output. So that is why you need to do, you return, even if there is repetition, just return the distinct values. So distinct L1. Let me go ahead and run this. Obviously this will show accepted, but now if I go ahead and submit it, it will pass all the test cases. So I see it passed all the test cases, and this is how I do it. So yes, somewhat difficult question, but you can solve this using joins as well, specifically self join. Once we learn about window functions, this can also be done by the same concept, right? So instead of performing a join, you can find what is the value in the next row of a particular column using the lead function. So it's called lead function. This is a window function which you can use. What is the value in the next, and not only the very next. Here if you find right lead from which column you want and how many rows, or like do you want the next, next to next, etc. So if you do 1, it will get the next. If you do it 2, so it after this it will skip 1 row, and in the second row what is the value, and so on, right? So you can use that as well. Okay, so this is the 34th question of the series called product price at a given date. And if you look at the companies this question has been asked in, so Google and Amazon, and quite a number of times, so kind of an important question. Let's look at what the question has to say. We are given a table called products with 3 different columns: product ID, new price, both of them have data type integers, and change date, which is a date type. The combined columns product ID and change date is the primary key, that is combination of columns with unique values of this table. Each row of this table indicates that the price of some product was changed to a new price at some date. Okay. We are asked to write a solution to find the prices of all products on 16th of August 2019. Assume the price of all products before any change is 10. Order of the result does not matter. Okay, let's go through this example and see what do we need in our output. So here we have certain different products, their new prices and the change date. Now we need to return for every product ID on 16th of August 2019, what was the price. So if we look at product ID 1, so product ID 1, we have 3 different rows. So the price was changed on 14th of August to 20, then on 15th of August to 30, and on 16th of August to 35. So on 16th of August 2019 for product ID 1, the price is 35. For 2, on 14th of August 2019, it was set at 50, and the next change was on 17th of August. So on 16th of August, it is having the same price that was changed to on 14th of August, that is 50. And for product ID 3, the change was made on 18th of August. And since the question says that if there is no change, right, so assume the price of all products before any change is 10. So for product ID 3 on 16th of August 2019, the price is 10. So that is what we have in our output. Now, in this question, we can use this date as a anchor point. And believe me, even if this question sounds very complex after reading it, we can actually do this using all the basic concepts that we have learned in this series so far. So no advanced methods, ranking, window functions, etc. is needed. But this question is actually going to test every basic concept that we have actually learned in this series. Let's see how we can do that. Okay, so the first thing is, as we said, that 16th of August 2019 is the day that we need the prices on. So that is an anchor point. So what if our step 1 in the logic is that for each of these product IDs and the changes from 16th of August 2019, how far they are? Because the closer they are, then we can know that, okay, was there a change around 16th of August 2019? So what I'm saying is, let's say from this table called products, What I'm doing is, let's create another column. So let's keep all the columns that are currently there. So select star and now create another column using the date diff function. So what we are doing is, from 2019, that is August of 16. So 16th August 2019, calculate the difference in the change date for every row. And let's alias this as the difference. Let me go ahead and run this and let's see what do we have in our output. So here we can see that in our output from 16th of August 2019, this is 2 days before that. Again, similarly for this 2 days, 1 days before 16th of August, this is 16th of August, so 0 days before that. Then -1 basically is 1 day after 16th of August and 2 days after 16th of August. Now this is very important for us because we can use this table to actually solve this. Now, for people who do not know about common table expressions, it might sound that I'm going into advanced territory, but the thing is, what I want to do is I want to have this saved in a particular table, whatever the name be, but I want to save this in a table. So usually the way to do that is, you can create a temporary table, create temp table, let's say data as. But the problem with this lead code environment is that it will not allow me to create a temporary table. So you see, it says like there is check the manual correspondence and all that. So it does not allow me. So there is another way, which is actually using a common table expression. So think of common table expression is, you do something, so you perform all these operations, right? So all the columns, then you calculated the difference from 16th of August 2019 and just save it into something called data. So the syntax for that is, why I am doing this is, I cannot do that and I can, still go ahead and do this. But the problem is that it will make our code very cumbersome. Why? Because we need to use this part, use this table a couple of times in this. So that will make our code repetitive and won't look as good as we want it to be. And it won't be clean as well. So just bear me with on this. So the syntax for common table expression is, you start a common table expression with and whatever name you want to give, you can write anything, it does not matter. So with data as, the only thing that you need to do is just put whatever you want to be stored in this common table expression called data, just put that in parentheses. So now if I just go ahead and do, let me just go ahead and do select star from data. Okay, now let's see. So basically what do we have is whatever we had, right? So this is the table that we had initially, and now this is saved in something called data. So just think of this as a table. Now what we can do is we can proceed. Okay, so now our step 2 is, for every product ID, we can try to find out what is the minimum difference that is not less than 0. Because less than 0 means, so -1 means 1 day after 16th of August. And it does not make any sense for us because we need the price on 16th of August. What is happening after 16th of August? We do not care about it. So on or before 16th of August, what is the minimum difference for each of the product ID? If we can get that, then we can say that, okay, so this is the closest a change was made to a new price for a particular product ID. Okay, so how can we do that? You can simply go ahead and group by the product ID and keep only those rows where a difference is not less than 0 and return the minimum difference. So what I'm saying is, from this table called data, we are keeping only those rows where difference is greater than 0. And then what we are doing is group by the product ID, group by the product ID, return the product ID. So return the product ID and get the minimum of the difference. So that will tell you the closest day on or before 16th of August 2019 the change was made. So let's alias this as minimum difference. Okay, let me go ahead and run this. Let's see what do we have in our output. Okay, so for product ID 1, 0, and for product ID 2, 2. Why? How does this make sense? So you will see that on for product ID 1, the change was made on 16th of August 2019. So obviously that means the closest change was made on the same day. But for product ID 2, the closest change was made on 2 days before 16th of August. For product ID 3, the change was made after 16th of August. And we will take care of those product IDs as well. Do not worry. So now what we can do is, so let me switch to Excel and have that. So this was the products table. And if I just copy this, let me paste it here. So this was our data table. And then after grouping by and trying to find out the minimum difference, we have this. So let's save this as D2, which has product ID and minimum difference. Then what we can do is we can use this data table as well as the D2 to join on the product ID and say that, okay, for this product ID, do we need to use this or do we not need to use this? And we will develop the logic on that as well. So what I'm saying is, so this entire thing is basically what we are doing is, we are calling this as D2. So if I go ahead and alias this as D2, and what I'm doing is from the data table, let me left join this table called D2 on, so let me just drag it down on data dot product ID is equal to D2 dot product ID, and let me go ahead and keep all the columns from data table, but just I am only interested in the minimum difference column from D2. So I will do D2 dot minimum difference. Okay, let me go ahead and run this. Let's see what do we get in our output. Let me drag it above. So in our output, what we have is, so this was data. So this is basically, these numbers are telling you that from 16th of August 2019, how many days they are before or after. And then minimum difference is telling you that, okay, for product ID 1, 0 means, so on 16th of August 2019, there was a change. Similarly, this, what is this telling you? So 2 days before 16th of August 2019, there was a change for product ID 2. And that was the closest change for product ID 2 near 16th of August 2019. And remember, for 3, there was no change before that. So we have a null here in this case. So now once we have this, then we can use these two columns to actually get whether this new price is useful for us or not. So what we can do is, if this difference is equal to your minimum difference, that means that that was the latest price for that product. So for example, 0 and 0. So 16th of August 2019, 1 for product ID 1, this is the latest change, and obviously this 35 is what we need in our output. So this is useful for us. But for product ID 1, changes made on 14th and 15 does not make any sense. So this is not equal to this, minimum difference is not equal to difference. So what we can do is, we can say, okay, your price is 0. And in these cases, when you are not able, because this is not an integer, so SQL won't be able to compare these cases. So you just let it be null. So what I'm saying is, let's use a case when statements. So case when statements are same as if statements. So case when is basically if else statement, if we think about in the logical sense. So if something is true, return this. If something else is true, return something else. And if nothing is true, return whatever is your default value or something like that. So what we can do is, we can use the case when statements here. So what I'm doing is, use case when your, so when your difference is equal to minimum difference, so that means that price is helpful for us. So difference is coming from data table and minimum difference is coming from this D2. So case when data dot difference is equal to D2 dot minimum difference, then new price is helpful and useful for us. When data dot difference is not equal to D2 dot minimum difference, then we can just simply say 0, because that price is not useful for us. And the third case would be, the SQL is not able to compare these two columns. So else we can simply go ahead and say, okay, let it be null, we will deal with it later. Else, and since we started, whenever you start a case when statement, you always need to end that, and then you can also alias this. So what is the name of the column that you want? You can say like price or whatever, that does not matter. Okay, let me go ahead and run this. Let's see whether we get our output. Okay, So now we have a table. Let me drag it to the left so that it's easier for us. Okay. So now what we have is, so here it was not equal and obviously the price is zero. What does this simply mean? That, hey, for product ID 1, there was a change on 16th of August. So a change made or a price on 14th of August does not have any value for me. Similarly, for 15th of August does not have any value for me. But on 16th of August, since the change was made, so this price is valuable for me. And this is the price for product ID 1 on 16th of August. Similarly, for product ID 2, one change was made on 14th of August 2019. So yes, and that is the closest because after that, the change was made after 16th of August. And after 16th of August, I do not care about that because that does not make any sense to me for in this question. So you see, now you have this and here you are not able to compare. So leave it now. Does not matter to us. Okay. Once we are clear with this, then think about it. How can we do this? Because in our output for every product, we need the price at on 16th of August. And we have been using 16th of August 2019 as a anchor. So think about it. The reason for us to do zeros here is just if you group by the product ID and sum this, you can get the price. So what I'm saying is, let me go ahead and use this so this entire thing, right? So this is what we got. So this is entire table that we have and we can use this table. So what I'm doing is from from this entire thing that we got right now, and let me alias this as what, capital T, table T. What I'm doing is group by T dot product ID, and then what I'm doing is return T dot product ID and do a sum of price column. So T dot price, and let me alias this as price. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so now in our output we have for product ID 1 it was 35, 50, and for 3 null. Okay, we will be dealing with this because there is a small fix with this, but actually if you look compare with our expected output for product ID 1 and 2, we are getting what is required in our output. Okay, let me switch to Excel and try to recap what we have done so far. So here we had difference. This is your data. Using this D2, what we did was we populated this minimum difference. So for minimum difference, now what we did was we used case when statements to get the price column and said that whether this price was useful for me. Then what we did was we grouped by the product and summed the price column. So if you just look at product ID 1, so product ID 1 is column this and these two. So 0 plus 0 plus 35. So that is what we have in our output, that 35. For product ID 2, we have, so product ID 2 is 50 plus 0. So 50. And for 3, sum of null is returning us null. But if it is returning null, what does that signify? It signifies that there has been no change on or before 16th of August, and therefore in those conditions we need to return 10 as the price of that product. So remember we used if null, that if something is coming out to be null, you can replace it with something else. So you see, you can do that. So let me just drag it down. So sum this entire thing, and if it is coming out to be null, so if null, so you sum the stuff. If it is coming out to be null, replace it with the value 10. Let me go ahead and run this. Let's see what do we get in our output. So now if you see, this is accepted. Our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. Yeah, this is accepted and this is how we did. So yes, very tricky question, very complex question. We have to think through this a lot. But if you are following this series and learning the very basics of SQL and how it operates, we can actually do this without using any fancy SQL window functions, etc. Now, if you know that, actually you can do this in even concise method. And when we will be learning about those window functions, we will try to do questions using that as well. But you see, here we have not used any advanced stuff. We learned about all these joins, etc., if null, sum, group by, calculating the difference, etc. So this is the 35th video of the series called Last Person to Fit in the Bus. And if I look at the companies this question has been asked in, so Amazon and Wayfair a number of times. So let's look at what the question has to say. We are given a table called Q with 4 different columns: person ID, person name, weight, and turn. Person name is a variable character data type, and remaining 3 are integer data types. Person ID column contains unique values. This table has the information about all people waiting for a bus. The person ID and the turn columns will contain all the numbers from 1 to n, where n is the number of rows in the table. Okay. The turn determines the order of which the people will board the bus. That is, where turn is equal to 1 denotes the first person to board, and turn is equal to n denotes the last person to board. Weight is the weight of the person in kilograms. There is a queue of people waiting to board a bus. However, the bus has a weight limit of 1000 kilograms, so there may be some people who cannot board. We are asked to write a solution to find the person name of the last person that can fit on the bus without exceeding the weight limit. The test cases are generated such that the first person does not exceed the weight limit. Okay, let's look at this example. So here we have certain people, their turns, weights, names, etc. Now, we cannot exceed the total weight limit of 1000 kg. So first person to board the bus is turn equal to 1. The weight is 250. Then the second person would be Alex, and the weight is 350. So up till this moment, the total weight on the bus is 250 plus 350, that is 600. Then turn number 3 is this John Cena, whose weight is 400. So 600 plus 400 is 1000, and 1000 means your weight limit is reached. So the last person to board this bus is without exceeding the 1000 kg weight limit is John Cena, and that is what we have in our output. So in this question, we need to calculate the running total. That means that at a particular moment, what is the weight on a bus? And for these type of questions, window functions come in very handy, but we will try to solve this question using a self join, and how we can even calculate running totals using joins as well. Okay, let me switch to Excel so that we can develop a query. So this same table, I have copied it here in the Excel sheet, but just arranged by turn in ascending order so that it is easier for me to understand. Okay, so think about it. How can we get the name of the last person who can board the bus without exceeding the weight limit? So when the person with turn equal to 1 hops on the bus, the weight of the bus is now 250 kgs. Now, so basically this is what we have. Now when you go to turn equal to 2, then what is the weight of on the bus? You have basically, so this one. So 250 plus 350 is what we have on the bus. Now, once you go to turn equal to 3, what is the total weight on this bus? 250 plus 350 plus 400. So this is what. So you see there is a pattern here. At turn equal to 1, it was just one row. At turn equal to 2, to get the sum, you have to 250 plus 350. Then turn equal to 3, you have to take all the 3 rows in this. That is why to calculate running totals, window functions are such a great tool. But let's see how we can achieve the same thing using a self join. So let me just copy this, copy this part again here so that it's easier for me to explain. Paste it here. And let's say this is again the same table Q, and then just let's say this is version Q1 and this is version Q2. Okay, now if you think about it, whenever you are at a particular turn, you need to have the value of that particular turn and anyone who came before that. So at turn equal to 1, what is the total weight on the bus? 250, and since there was no one before it, so 250. But when you go to turn equal to 2, you need to have the weight of the person whose turn was 2 plus whose turn was 1, that is 350 plus 250. When you go to turn equal to 3, you need to have the weight of the person whose turn was 3 but also turn 2 as well as turn 1. So you see, we need to get all the people who had the turn equal to or less than that part. So what if I go ahead and write this? Can I write this? So from this table called Q, let's alias this as Q1 version. So Q1 left join the same table, and this is what we call a self joins. Q version Q2 on Q1 dot turn is greater than equal to Q2 dot turn. Okay, let's see what will this do. So here we have Q1 and Q2 version. So here we will be having, okay, let me just, have these so that we are able to populate these as well. So it would be easier for us to understand. Okay, so Q1 dot turn should be greater than equal to Q2 dot turn. And that is where we are performing a join. Okay, so if I start with Q1 dot turn is equal to 1 and 1 is greater than or equal to only 1. So for the first row, we will be having, so this one comes from Q1 is populated here, and this row is coming from Q2 and it is going to be populated here. Now move to turn equal to 2. So turn equal to 2, firstly it will say, okay, 2 is greater than 1 and 2 is equal to 2. So it will have two rows. Firstly, this row where this will come here and again here. The first one will be having this row because 2 is greater than 1. And then the second row would be this one, which is 2 is equal to 2, and so on. Let me just populate the entire thing and come back. So this is what it will look like. I have colored these. So for turn equal to 1, this is the only row that we are going to have. Turn equal to 2, we are going to have two people. The turn equal to 2 as well as turn equal to 1 part. Then for turn equal to 3, 3 rows and so on. So we have all this. Okay. Now, once we are doing this, then we need to do that at a particular turn, what is the total weight? So if you think about it, if you group by this Q1 dot turn and sum the Q2 dot weight part, at every turn, what is the total weight on the bus? You can get that. Why? Because if you do Q1 dot group by Q1 dot turn, so at turn equal to 1, what is the total sum? 250. At turn equal to 2, what is the total sum? 250 plus 350. At turn equal to 3, 250 plus 350 plus 400 and so on. So you see, you are able to calculate a running total using a self join. So what I'm doing is, let's do group by, so group by Q1 dot turn and then return Q1 dot turn and then sum the Q2 dot weight part, and let me alias this as running weight. So running weight. Okay, let me go ahead and run this. Let's see what do we have in our output. So if we look at it, so at turn equal to 1, 250, turn equal to 2, 250 plus 350, that is 600, 1000 and so on. Okay, so we have at a particular turn, what is the total weight on a bus? Once we have this, then we are only interested because the weight limit is 1000. So after 1000, whatever the weight comes out to be, we do not care about that. You see, this is the case of filtering using a aggregate value. So here your running weight should be less than or equal to 1000. How can we do that? We can, after group by, we can use the having clause. So having the sum of Q2 dot weight less than equal to 1000. Okay, we are only interested in up to that turn where your weight is not exceeding the weight limit of the bus. So if I go ahead on our output, so here now you have turn equal to 1, 250, turn equal to 2, 600 and turn equal to 3, 1000. Now, once you know that, okay, these are the three turns until when your running weight is less than equal to your limit, then how can we find out, okay, at what turn our weight was less than or equal to 1000? If you just simply rearrange this in descending order by running weight, then the first line is basically the last turn of the person who actually can fit on the bus without exceeding the weight limit. So if I do this thing, order by, so order by sum of Q2 dot weight, so this part, copy this, paste it here, and in decreasing manner. So if I go ahead and run this, let's see what do we have in our output. So here we have, okay, so this is the last turn where you are not going to exceed the weight limit. Okay, so once we have this, then we need in the question we need the last person who can fit on the bus. So if I just do limit equal to 1, because we only need the last person, right? So limit is equal to 1, that is going to give me, so limit is equal limit 1 and then run. So this is going to give me the turn of the last person where we are not exceeding the weight limit. Now we are only concerned about the turn part. So let me just remove this running weight. It was for explanation purposes. So now here from this query, we get the turn of the last person who can fit on the bus without exceeding the weight limit. But in our output, we do not need the last turn. We need the person name of the last person. Okay. So we can simply go ahead and perform a filter. That is, this entire thing will return you the last turn where you are not going to exceed the weight limit. And then associated with that would be a person name. So from this table called Q, we are only required to keep those rows where your turn is equal to whatever turn value we got from this, and you simply return. So return the person name. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so if I drag it above, so this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted and this is how we do it. So yes, kind of a tricky question, but if you know window functions, this would be easier to do. This question also highlights the use case of window function, one of the use cases of window function, but we can achieve the same result using a self join as well. And we learned about how running total works and what running total actually means. So this is the 36th question of this series called count salary categories, and let's look at what the question has to say. We are given a table called accounts with two different columns, account ID and income, and both of them has a data type integers. Account ID is the primary key, that is column with unique values for this table. Each row contains information about the monthly income for one bank account. We are asked to write a solution to calculate the number of bank accounts for each salary category, and the categories are defined as a low salary, all the salaries strictly less than $20,000. Average salary, all the salaries in the inclusive range 20,000 to 50,000. And high salary, all the salaries strictly greater than 50,000. The result table must contain all the three categories. If there are no accounts in a category, return 0. Okay, order of the result does not matter. Let's go through this example and see what do we need in our output. So here, how many of these accounts have less than $20,000 salary? So only one. So low salary 1. More than 50,000 we have 3. So high salary is 3. And average, there is no salary between 20,000 and 50,000 included. So for average salary, it should be 0. And that is what we have in our output. Okay. So in this question, this particular line, that result table must contain all three categories, makes it quite tricky. Because if you go by this, so here you can add a third column called category based on the certain conditions, that if it is less than 20,000, it is low salary, between 20 and 50, then it is an average salary, and more than 50, it is a high salary. But we need to do something more than that. So for example, if I add that column, so hey, for example, from this table called accounts, if I say that, okay, let's keep all the columns, select star, and then use the case when statements to basically add a third column called category based on the income. So if I do case when your income is less than 20,000, then you have a low salary. If, right, and then when your income is between 20,000 and 50,000, then you have average salary. And of course, the third condition is high salary. So else it is a high salary. Okay. And since we started a case when statement, we need to end this and as, let's call it categories. Okay. Let me go ahead and run this and let's see what do we have in our output. So here we have a third column called category, which classifies the low salary, medium salary, or high salary. The spelling should be okay. Let me go ahead and run this again. Okay. So now once we have this, then had this line not been written in our question that result table must contain all the three categories, we can simply group by the category and count the number of account IDs, and that would have that output that we required. But the problem is it says even though the category does not belong here, you have to have that in our output. So to do that, let us switch to Excel and try to see what is the logic that we can develop. Okay. So the third column that we added was category, and this is what we have. Okay. Now what if we create another table which has the all the categories that are required in our output? So let's say, for example, we create a table whose name of the column is category, and we have a low salary. So if we join these two, right? So low salary is equal to low salary, so there you will be having this row. Then average salary, it won't find anything, so it will have null values. And for high salary, it will find three different matches, so three different rows. So what I'm doing is, okay, so this is what we have. Now we need to create a table called cat, which has all the categories. So what we can do is, let's put this entire thing into parentheses. Okay, and then let me just drag it below. Okay, now let me create a table. So to create the table, we need to use the union clause. So return low salary as it should be capital. Okay, low salary as category, union, return average salary, and then union, return high salary. So this code is going to create this table called category. Now using these two, so this is a table, right? So from this table, so this entire thing, if I put this in parentheses, so this is a table, and which is we are calling cat, right? So this is what we are calling cat. Okay, now from this table, so from this table called cat, if I left join this table, so whatever we created, so the table that already has two columns, and we are creating a third column, and let's alias this as table, say, let's say capital T. Oh, and left, we are, since we are left joining, so we need to provide, okay, on cat dot category is equal to T dot category, and let me return everything. So if I just do select star, let's see what do we have in our output. Okay, let me just drag it above. So now we have the category from the table that we just created, and then these three columns are coming from the table T. Okay, now here we can get that, okay, for every category how many rows we have. Now if I just go ahead and group by the category and count the account ID. Remember, a property of count is, if you provide count star, it will count all the rows irrespective of whether there are nulls or not. But when you do a count of a particular column, it will only count non-null values. So if you group by the category and count the account ID, for low salary, it will be, okay, one account only. For high salary, it will count three accounts. But for average salary, there is no non-null account. So it will count it as zero. And that is how we are able to get that output. So what we can do is, so this is what we have, right? So after performing a join. So if I go ahead and group by, so group by this column category is coming from cat table. So cat dot category. And if I return cat dot category and count the account ID coming from the table T. So count T dot account ID. And why I'm not doing this thing? Because here it says account ID is the primary key. So column with unique values. So we do not need to do that. And let's alias this as accounts count. So as accounts count. Okay, let me go ahead and run this. Let's see what do we have in our output. Okay, let me just drag it above. So this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how I do it. So yeah, why I did that. This question can also be solved using three different unions. Lead code does not allow us to create temporary tables, but you can think about this, right? So this entire table can be just written one table above this, then this can be another table, and these cables can be directly used to get another values as well. So here this question was, for every category count the number of accounts. What if the question said, okay, count that, then also get the minimum of that particular category and maximum of that particular category, and so on. So If you do that by union, you will need to change a lot of stuff. But here you don't need to do anything. All we did was, okay, from this entire thing, you can just do count and then place a comma and then minimum of the salary, maximum of the salary, etc. So you see, this makes our solution very generalized. So this is the 37th video of the series called Employees Whose Manager Left the Company. And if I look at the companies that this question has been asked in, so Adobe, let's look at what the question has to say. We are given a table called employees with 4 different columns: employee ID, name, manager ID, and salary. In SQL, employee ID is the primary key for this table. This table contains information about the employees, their salary, and the ID of their manager. Some employees do not have a manager, that is, manager ID is null. Okay. We are asked to find the IDs of the employees whose salary is strictly less than $30,000 and whose manager left the company. So there are two conditions that we need to check. When a manager leaves the company, their information is deleted from the employees table, but the reports still have a manager ID set to the manager that left. Order result by employee ID. Let's look at the example and see what do we need in our output. So here we have several employees, their names, their manager IDs, and salary. So we need to check two conditions. Firstly, employees whose salary is less than $30,000. So we only have two employees, employee ID 1 and 11, whose salary is less than $30,000. And secondly, we also need to make sure that those employees whose salary is less than $30,000 have their manager left or not. For Khalil, the manager ID is 11 and 11 is still in the employees table. The question says that if your manager leaves, then that particular manager's information is deleted from the employees table. Since manager ID 11 is already present in the employees table, this person is still working. Now, if we move to Josiah, manager ID 6, you can see that there is no manager ID 6 in the employees table. So that means employee ID of the person whose salary is less than $30,000 and whose manager left is 11. And that is what we have in our output. Now this question is part of subqueries of SQL. So basically, what is a subquery? Subquery is a query inside a query. So let's look at how that subquery part will come in picture here. So we need those employees who needs to satisfy two conditions. Firstly, from this table called employees, their salary, so where salary is strictly less than $30,000. And secondly, we also need to make sure that those employees manager ID should not be present in the employees table. Then only we can say that, okay, that particular manager has left the company. So we can write and manager ID is not in, and then we need to find the, so this is where we are writing the subquery that, okay, return the employee ID. So all the employees that are present in the employees table. So from employees, this will give you the list of employee IDs from the employees table. And if your manager ID is not in that, then what you do is you return the employee ID. So return the employee ID. And since we also need to order this by employee ID, so we write order by employee ID. Okay, let me go ahead and run this. Let's see what do we get in our output. So yeah, this is accepted. Let me just drag it above. So, and our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Not a very difficult question, but what we had to do was we had to satisfy two conditions. For first, it was very easy because it was just row by row where clause. But for the second, to make sure that manager has left the company, we need to make sure that it is not actually present in the employee table. And for that, we use the subquery. So this is the 30th video of this series called Exchange Seats. And if I look at the companies this question has been asked in, so Amazon and Bloomberg a number of times. So let's see what the question has to say. We are given a table called seat with two different columns: ID, which is an integer data type, and student, which is a variable character. ID is the primary key, that is unique value column for this table. Each row of this table indicates the name and ID of a student. ID is also a continuous increment. We are asked to write a solution to swap the seat ID of every two consecutive students. If the number of students is odd, the ID of the last student is not swapped. Return the result table ordered by ID in ascending order. Okay, so let's go through this example and see what do we need in our output. So here we have odd number of students in the seat table along with their IDs and their names. Okay, now we need to swap for every two consecutive. So for example, ID equal to 1 and 2 needs to be swapped. So Abbott's new ID becomes 2 and Doris's becomes 1. Similarly, for Emerson, it becomes 4, Green, it becomes 3, and for James, since there are odd number of people, so it remains 5. And that is what we have in our output. Let us switch to Excel and try to develop a logic on how we can solve this question. So here, this is the seats table or the seat table, right? And these are the information that we already have. Now, what we need is we need to swap the IDs. So, for example, for Doris, it should become 1, and for Abbott, it should become 2. Similarly, for Emerson, it should become 4, and for Green, it should become 3. And since there are odd number of students in this particular table, so this is the last one and therefore it should remain 5. So here the logic is that if your seat ID is an even number, you need to decrease it by 1, no matter what the case. Even if there are odd number of students in this seats table, still if your ID is even, then you need to decrease it by 1. So if ID is even, then decrease by 1. Okay, now this is the first condition that we need to keep in mind. Secondly, if your ID is odd, then two things can arise. Either it is the last value, in which case it should be kept as it is. If not, then you need to plus 1. So if ID is odd, then we need to check two cases. Firstly, if ID equal to maximum value, then you need to keep as it is. If not, then you need to plus 1. Okay, so let's try to code this using MySQL. So what I'm doing is from this table called seat, let me keep both the columns, select star, and then create a new column which has the new seat ID. Now we can, since there are different cases, so we can use the case when statements. So case when, firstly, we need to do is that if you check for if the ID is even, then you decrease it by 1. So case when ID modular 2 is equal to 0, that means if you divide it by 2 and a remainder is 0, then you simply subtract 1 from it. Now we need to also check when your ID is odd. Now to do that, you can do ID modular 2. So when you divide it by 2, if the remainder is 1, this means that it is odd. But in odd, you have two conditions. Firstly, and if your ID is equal to the maximum value in this seat table, because if it is equal to that, that means there are odd number of students in the seat table. So here you can write the subquery. You can get, okay, return the maximum of ID column from the seat table. So if both of these conditions are satisfied, ID is odd and ID is equal to the maximum, then you just keep the ID as it is, because it is a case of this one, right? 5. Else, the only condition remaining is it is an odd and it is not equal to the maximum part. In that case, you just simply sum 1, right? So ID plus 1. Okay. So now, and let me go ahead, and since we started our case when statement, we need to end it, and let's alias this as, let's say, new ID. And let me go ahead and run this. Let's see what do we have in our output. Okay, not yet complete, but if you look at it, now we have the desired result. So for Abbott, it was 1, is now changed to 2. For Darius, it was 2, now changed to 1. Similarly for Emerson and Green, and for James, which was 5 and odd number of students, so it was kept 5. So now what we need is, we need the new ID and the student. If we look at our output, new ID, and that should be aliased as ID as well. So what we can do is, we can, instead of keeping all the columns, what we can do is, whatever column that we created, we can rename it as ID, and then we also need to keep the student column after this, and then we need to order this by ID in ascending order. So what we can do is, we can simply go ahead and write order by the ID column that we created and not the original one. Let me go ahead and run this. Let's see what do we get. Okay, so now this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. Yes, somewhat medium difficulty, but what we had to do was, we need to check the ID column to see if it is odd or even, because if it is even then you need to just subtract 1, but if it is odd then you need to check for another condition whether there are odd number of students in the seat table. If yes, then you keep the biggest odd number ID equal to the same value. If not, then you just simply add 1. So this is the 39 video of this series called movie rating, and if I look at the companies this question has been asked in, so SAP, let's look at what the question has to say. We are given a table called movies with two different columns: movie ID, which is an integer data type, and title, which is a variable character. Movie ID is the primary key, that is column with unique values for this table. Title is the name of the movie. Then we are also given a second table called users with again two different columns: user ID, again integer data type, and name variable character. User ID is the primary key, that is column with unique values for this table. We are also given a third table called movie rating with four different columns: movie ID, user ID, rating, all of them being integer data type, and created at, which is a date. The combined columns movie ID and user ID is the primary key, that is column with unique values for this table. This table contains the rating of a movie by a user in their review. Created at is the user's review date. Okay, we are asked to write a solution to find the name of the user who has rated the greatest number of movies. In case of a tie, return the lexicographically smaller username. So basically arranged in ascending order. Secondly, we are also required to return the movie name with the highest average rating in February of 2020. In case of a tie, return the lexicographically smaller movie name. Okay, so here in this question, we need to have two different outputs, and the result format is in the following example. So let's go through this example. So here we have three different movies and four different people and various ratings of various movies. So let's look at firstly which user has rated the maximum amount of movies. User ID 1 has rated 3 movies. User ID 2 has rated 3 movies. User ID 3 has rated 2 movies. User ID 4 has rated 1 movie. So two users, user ID 1 and 2, Daniel and Monica, have rated 3 each. But it says that in case of a tie, we need to arrange this in ascending order, arrange the names in the ascending order, and return the first one or the smallest one. So for this particular part, Daniel is what we need in our output, the user which has the greatest number of movies. Okay. Then we also need to get the highest average rating in February of 2020. So movie ID 1 has 4 plus 2. So 6 divided by 2 is 3. So average movie rating of movie ID 1 is 3. Then for a movie ID 2 in February of 2020, we have 5 plus 2, 7 divided by 2, that is 3.5. And then for movie ID 3, we have 3 plus 4, 7 divided by 2, that is 3.5. So there are two movies, movie ID 3 and 2, which have 3.5 movie rating. So movie ID 2 and 3 is Frozen 2 and Joker. Now lexicographically, F comes before J, so Frozen 2 should be in our output. So Daniel and Frozen 2 should be in our output, and that is what we have in our output. So to solve this question, we need to firstly have one query which gets the first part, and then another query which gets the second part, and we need to perform a union. So what we need to do is, firstly we need to find out user who has rated the greatest number of movies. So to do that, we need to join these two tables to get different users and their names and the number of times they have rated it. So for example, if I go ahead and write from this table called movie rating, and let me alias this M, and left to join the table called users aliased as U on M dot user ID is equal to U dot user ID. And if I go ahead and return all the columns, although that is not required, but let's see what do we have in our output. So let me go ahead and run this, drag it above to the left. Okay, so if I look at my output, so we have this movie ID, user ID, rating, created at, then user IDs and the names attached to it. Now we need to find out the person which has rated the highest number of movies. So what we can do is we can go ahead and group by. So group by the name column. Name column is coming from users table. So u dot name, and then we can return u dot name. Let me just drag it below, u dot name, and let's count the number of distinct movies each has rated. So distinct movie ID. Okay, let me go ahead and run this. Let's see what do we get. So now if we look at it, we have Daniel has rated 3 movies, Monica has three, Maria has two, and James has one. So obviously we need to keep the ones who have rated the most, and that too in lexicographic manner. So we can go ahead and do order by. So order by this count, right? So order by this count. So copy this in decreasing manner, and in case there is a tie, then you arrange by the name in ascending order. So if I go ahead and run this, let's see what do we have. So now if we look at it, our output is so name and count number of movies they have rated. If there is a tie, so Daniel comes before Monica. Now in our output, we need only the name, right? And this column is aliased as results. So let me go ahead and remove this part because we do not need the count part in our output. So let me alias this as results. And then we are only required to keep the first person, right? So limit 1. Let me go ahead and run this. Let's see what do we get. Okay, so now we have the first value, that is results, and Daniel. So this is the person who has rated the maximum number of movies. Now let's go ahead and try to find out this part. We can keep this entire thing into parentheses because this is one of the results that we got, right? One of the results that we got. Okay. Now we also need to have, so let me just start writing for the movie that has the highest average rating in February of 2020. So now to do that, what we can do is again perform a join of movie rating, but this time on the movie column, so that we need to get the, because in the output we need the title. So what we can do is from this table called movie rating, alias this as M1, let me left join the movies table aliased as M2 on M1 dot movie ID is equal to M2 dot movie ID. And if I go ahead and do okay, but when we left join, we only need to keep those rows which are created at February of 2020. So we learned about this previously in the series. How can we format the date? So here, if you look at this part, right, let me just drag it on the right. So here we need to make sure that we are only considering those rows where created at has year 2020 and month as 02. So to do that, we can keep only those rows where date format of the column created at is only, so percentage capital Y is keep the year in YYYY format, and then dash, and then percentage small m, so 01 to 1 to month. Okay, this is equal to 20. Let me just left drag it so that it's easier. Is equal to 2020 February. So this will only keep the February of 2020 rows. And then we need to group by, right? So if I group by the movie name, because in the output we need the movie name, right? Frozen 2. So movie name will come from the movies table, because if you look at the movies table, you have the title here. So we can write M2 dot title, and in our output we need the title, so return m2 dot title, and then this should be ordered by average of rating. So ordered by average of rating comes from the movie rating table, so it is m1 dot rating. So it will order by average, so maximum average should come first, so decreasing manner, and then if there is a tie, then by movie title, so m2 dot title in ascending order. Okay, now this will give you all those values arranged by average in descending order, and in case of a tie by title in ascending order, but we are only required to keep one value, so limit 1. And then both these queries, their results will be populated. And then if I go ahead and do union all, okay, so basically get a result from this query, get a result from this query, and union them. So let me go ahead and run this. Let's see what do we get in our output. So let me drag it above. So now this is an accepted. If I look at my output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. So yeah, this is accepted and this is how we do it. So yes, medium difficulty and the solution does look like very big, but the thing is, it's not very difficult because in our output, we need two different solutions, and both of them can be achieved using two of the given three tables. And that is why, firstly, we found out okay, which user has the greatest number of movies. And then we also find out which movie has the highest average in February of 2020. And then we union the results. So this is the 40th video of this series called Restaurant Growth. And if you look at the companies, this question has been asked in point 72. Let's look at what the question has to say. We are given a table called customer with four different columns: customer ID, name, visited on, and amount. In SQL, the combined columns customer ID and visited on is the primary key for this table. This table contains data about customer transactions in a restaurant. Visited on is the date on which the customer ID has visited the restaurant. Amount is the total paid by a customer. You are the restaurant owner and you want to analyze a possible expansion. There will be at least one customer every day. Compute the moving average of how much the customer paid in a 7 days window, that is current day plus 6 days before. Average amount should be rounded to two decimal places and the result table should be ordered by visited on in ascending order. Okay, so here we need to calculate moving average. Let's look at the example and see what do we need in our output. So here we have various customers, they visited on date and the amount they paid. Okay, so this table starts at 1st of January 2019 and 7 day period is 1st of January 2019 till 7th of January 2019. So every day one particular customer is visiting. So the total amount paid in the 7 day period is 100 plus 110 plus 120 and all the way up to 150, which will come out to be 860. Similarly, the next 7 day period is between 2nd of January 2019 till 8th of January 2019. And if you sum this part up, then you will have something else and so on. So that is what you have in our output. So 7 day period until 7th of January 2019, this was the amount, this was the average amount, and similarly for 8, 9, and 10. Okay, so in this question, we need to calculate the moving average, and these kind of questions can be solved easily using window functions. But since we learned in the 35th video of this series that we can also get the desired result using self joins and subqueries as well. So let's try to solve this question using self join and subqueries. Okay, so first thing that we should do is, since on a particular day multiple customers can visit. For example, if you look at this on 10th of January 2019, there were two different customers who paid different amount. So first step should be, let's group by the visited on and have a particular amount, the total sum paid by different customers on a particular visit date. Because the logic that we are going to develop, this step is important so that it will reduce redundancy. Okay, so what I'm saying is, from this table called customer, let's group by, right? So let's group by the visited on column, and then let's return visited on, and then do a sum of the amount column, and let's alias this as amount. And let me go ahead and run this. Let's see what do we get in our output. Okay, let me just drag it to the left so that it's easier for us. Okay, drag it above. Okay, so on every particular day, now we have one row which shows, okay, this was the total amount paid by all the customers on a particular date. Okay, then let's store this into something called a common table expression, which we also learned about in this series earlier. Basically, what we are doing is we are storing this in a table called whatever we want to. So for example, the way to do this is we need to write with common table expression name. You can write any name. Let me write CSTMR, customer as, and this entire thing should go into parentheses. Let me drag it down. Okay, so what this is let me do select star from customer. So we are just storing this result, the result that we still right now have, into something called customer. Okay, let me go ahead and run this. Let's double cross it. Okay, so okay, we have the same thing. Now let's switch to Excel and try to develop a logic. So here, this was the customer table, and using this customer table, we created a common table expression called CSTMR, which is basically this. So this is what we have. Now what we need to do is, we learned in the 35th video that if we perform a self join, that is join this table on itself using the logic, if you want to calculate running total or moving averages, you should join two versions of this table on the logic that version 1 dot visited on is greater than equal to version 2 of visited on. So what I'm saying is, let me just copy this again so that it's easier for me to show this. Okay, so let's say this is C1 version and this is C2 version, and then let me go ahead and write the code. So what I am doing is, from the first version, right, as C1, let me left join the same table, but this time version number 2 C2 on C1 dot visited on is greater than equal to C2 dot visited on. Okay, let me go ahead and run this. Let's see what do we have in our output. Let me just drag it above so that it's easier for us. Okay, so what we basically did was, okay, so this one should be greater than equal to this one. That is what we performed. Why did we do that? Because if you just look at this particular table, and if someone will ask me what is the running total at a particular date. So if I group by this column and sum this part, right? So for example, on 1st of January 2019, the total would be 100. On 2nd of January 2019, the total would be these two rows sum, right? So 100 plus 110. On 3rd, it will be 1, 2 plus 3, right? And so on. So you see why we are using that logic. But in this question, we need to have a 7-day window period. What we want is starting from 7th of January. So what we need to do is, in this table, we need to exclude certain rows. That is, we need to filter. First condition should be that the difference between this column and this column should be between 0 and 6. Why? Because the period should be not more than 7. Because for example, if you do this logic, right? For this logic, right? So C1 dot visited on is greater than equal to C2 dot visited on. So if I come here, for example, if we look at this one, right? 8th of January 2019. 8th of January 2019 is greater than or equal to 1st of January 2019. So there will be a row in the output which will have visited on from C1 date as 8th of January, and this is going to be 1st of January. But what is the difference between these two? 8 days. If you include these two dates, so they are going to be 8 days. We don't need that. We only need the 7-day part, right? So the first condition should be the difference should be between 0 and 6. So first condition is where date difference, so date difference between C1 dot visited on and C2 dot visited on is between, right? So between 0 and 6. Okay, let me go ahead and run this. Let's see what do we get. Okay, so now if we look at our output here, if you see, right, so now the 8th January does not have any row which has 1st of January 2019. It starts from 2, because why? The difference between these two is 6. So that is the maximum that you can go. Similarly for 9, it will start with 3rd of January. Okay, that is one thing. Then we also need to see that, okay, there are some of these, for example, these ones, right? 1st of January 2019 and all. These we do not need, because we do not need that in our output. If we look at our output, we only have starting from the 7th day, right? So how can we exclude those? So we can use a subquery in this case. How? Just think of it. If we add another condition that the C1 dot visited date should be greater than or equal to the minimum date that we have in this table. So the minimum date that we have in this table, which is 1st of January 2019. And if you add the 7-day period into it, that will come out to be 7th of January 2019. So in our output, what do we need? 7th, 8th, 9th and 10th. So another condition could be that, okay, if your visited on is greater than equal to the minimum date from the customer table plus 7 days. Okay, so how can we do that? Let's try to inculcate that filter as well. So, and the second condition should be C1 dot visited, C1 dot visited on is greater than or equal to return the minimum from, right? So the minimum of visited on date from the customer table, but not the minimum of visited, minimum plus 7. So how can we add dates? We learned about a function called date add. So date add, and then let me just write. Okay, so date add, and in this particular, how do we add days? We need to write comma interval, and then interval 6 days, because the minimum is 1st of January. If you add 6, then you will land up at 7th of January. So interval 6 day. Okay, now let me go ahead and run this. Let's see what do we get in our output. So now if I drag it above, then if you see, okay, so now here we are only left with whatever is required for us. So for example, for 7th of January, we need to have 7th 1, 7 2, 7 3, 7 4, 7 5, 7 6, and 7 7. So here, if you look at it, you will only have until 7 7. Okay, so now for every date that is required in our output, we have the values that were contributed or paid by various customers. Okay, now we can go ahead and group by the visited on column and sum the amount, because that is going to give you in our output the total amount, right? So here you need the amount and you also need the average amount. So what we can do is, so from this code, from this particular code, we are able to get this. And then if I go ahead and do group by C1 dot visited on, and then for every visited on date, so C1 dot visited on, and then you sum the amount column and alias this as amount, because you need that as amount in our output as well. So amount column, and then we need to calculate the average rounded to 2 decimal places. If you look at rounded to 2 decimal places, and alias this as average amount. So we need the average of amount column, but this should be rounded to 2 decimal places, and then aliased as average amount. And also at the end, we need to sort this by visited on in ascending order. So here we need to write order by C1 dot visited on in ascending order. Okay, so I think this looks good. Let me go ahead and run this. Let's see what do we get in our output. Okay, so you see the importance of writing these C1s and C2s. It says column amount in field is ambiguous. Why? Because amount is coming from the customer, right? So if we go at customer, so amount is coming from this as well as this. So we need to sum the C2 dot amount part, right? So here we need to write C2 dot amount, and same here as well. So C2 dot amount. Let me go ahead and run this. Let's see what do we get. So now if I drag it above, we can see that, okay, this is accepted. Our output is same as expected output. Let me go ahead and submit it to see if it passes all the test cases. Yeah, this is accepted, and this is how we do it. So yes, medium difficulty. If you know about window functions, you can actually use windows to solve this question much easier. But since we have not learned about window function, I also told you about a alternate way where you can use a self join and a subquery. So in this question here we have the self join, and this is a subquery which we use to calculate the moving average of the 7-day period. So this is the 41st video of this series called Friend Request Part 2, who has the most friends. And if I look at the companies this question has been asked in, Amazon and Facebook, kind of an important question. Let's look at what the question has to say. We are given a table called request accepted with 3 different columns: requester ID, acceptor ID, and accept date. The combined columns requester ID and acceptor ID is the primary key, that is combination of columns with unique values for this table. This table contains the ID of the user who sent the request, the ID of the user who received the request, and the date when the request was accepted. We are asked to write a solution to find the people who have the most friends and the most friends number. The test cases are generated so that only one person has the most friend. Okay, let's go to this example and see what we need in our output. So here we have various requesters, the acceptors and the accept date, and we find the person which has the most number of friends. So if I look at it, so requester ID 1 and acceptor ID 2. So basically now these people are friends. So for one, for ID 1, one of the friends is 2, another friend is 3. So ID 1 has two friends, 2 and 3. Now ID 2 has one friend which is 1. ID 2 also has another friend called 3. So again 2 also has two friends. ID 3 has one friend, two friend, three friend. So ID 3 has three different friends and ID 4 has only one friend whose ID is 3. So maximum number of friends the ID which has is 3 and the total number of friends the person has is 3. So that is what we have in our output. Now the language of this question is slightly confusing. Actually this is not what they are actually asking for, who have the most friends, but we will talk about it later when we try to develop our logic. So in this case, just think about it. If I need to get for every particular ID how many friends the person has, it would be very easy to do if all the rows also have a swapped version of it. What I mean by that is, so when I say one sent a request and two accepted the request, now they both are friends. In that case, requester ID and acceptor ID does not make much sense now, because one is a friend of two and two is a friend of one. So if we had a row where it was that okay, one sent a request to 2 and was accepted, then let's have another row called 2 and 1, and similarly for all these, and then if you group by this particular column, you can count the number of people in this second column. So what I mean by that is, if I if let's say return the first column, right, requester ID as it is, and the second column is acceptor ID, and then from this table called request accepted, and then what I'm doing is have another version of this, but we are swapping it. So let's have another version, but here firstly we are returning the acceptor ID, and then we are having a requester ID, and then let's union them both. I am currently writing union, but the correct answer will come with union all. What is the difference between union and union all? Let's discuss that first. So when I write, so for example, if I have two ones, right? So for example, I have 1 and 1. If I do 1 union 1, the output is going to be 1. So because there are duplicates, so it will only keep one of them. But if you do 1 union all 1, it is going to have 1 1 in our output. You see, union all keeps all the values irrespective of whether there are duplicates or not. Okay, so this is what I am doing. Let me go ahead and run this and let's see what do we have in our output. So if I go ahead and see that, okay, now we had up till now, so this was what we had, right? So 1 2 1 3 2 3 3 4, and then the swapped version, that is what we are calculating. So 2 1 3 1 3 2 and 4 3, and that is what we have. Now just here by looking at it, if you group by this particular column and count this, then you are going to get the number of friends each of these people have. How? If you group by the requester ID, right? So here it will have, okay, one group would be 1 1, and it will count, okay, there are two people. That is what we calculated manually as well, that one has two friends, then two has 1 2, two friends again, three has 1 2 and three friends, and 4 has only one friend. So you see, this is how we are able to calculate the number of friends of each of the IDs. So now this becomes, so this entire thing which we got becomes a table. So what we can do is we can put this entire thing into parentheses, and let's alias this as whatever is coming out of it as a table T. Now, and from this table T, what we are doing is, let's group by the first column, and the first column is requester ID. You can do the other way around as well. You can group by this and count this as well. Because we swapped it, now the text requester ID and acceptor ID does not have any much meaning left. So group by requester ID, and then what I'm doing is, let me go ahead and return the requester ID, and this should be aliased as ID in our output. So as ID, and then we need to do count of the acceptor ID column. So acceptor ID. Okay, and this should be aliased as number. Okay, and okay, let me go ahead and run this right now. Not yet complete, but let's see. So now here we have for every ID how many number of friends the person has. So obviously 1 has 2, 2 has 2, 3 has 3, and 4 has 1. So we are required to only keep the person with the highest number. So how can we do that? We can just simply go ahead and write order by the number column in decreasing manner, and since we are only required to keep 1, so limit 1. And let me go ahead and run this. Let's see what do we get. Okay, so now here it says accepted and all green, and our output is same as expected output. Remember, we talked about this union is not going to give you a correct answer, but union all will. If I go ahead and submit it, let's see what this gives. So you see here it says it didn't pass one of the test cases, and here is the example of why it did not pass a test cases. So for this particular case, it was expecting the ID 3 has 4 friends, and our code return ID equal to 3 has 3 friends. Let's look at this. So here, how many friends 3 has? 3 has one of the friends whose ID is 1. 3 also has a friend whose ID is 4. This row also is basically the swapped version of this. 3 is a friend of 4, and then 3 is a friend of 2. So 3 is a friend of 1, 4, and 2. So in reality, 3 is only a friend of 3 people. But here, how they are calculating 4? So they are saying that if 4 is sent a request to X and 3 was an acceptor, this is a different case than 3 sent a request and 4 was an acceptor. Now just think about it. If I sent you a request and we both become friends, this question is basically suggested that I am a friend of you and you are a friend of me. So they need to be double counted. I know, right? So this does not make any sense. That is why I was saying the language of this question is somewhat tricky and not 100% correct, that it is asking you to find the people who have the most friends and most friends number. In reality, what they need is, even if you have a swapped version 3 4 and treat it in a different way than this, why ours is returning 3? The problem is that here, if you look at it, right, so 1 3, it will have another row called 3 1. Okay, then 4 3 will have another row called 3 4. Now there is one row that already exists as 3 4, and we just learned that union, if there are duplicates, it will only keep one of them. So at the end, what is happening is there is one row called 3 1, one row called 3 4, and one row called 3 2, and that is why when you group by ID, then for 3 there are 3 number of friends, and that is what it is returning. But they also want to have this 3 4, which is already present as a separate part as well. Now one of the reason that I can think of is mainly because of this accept date, since this accept date are different. But yeah, like they should have made this clear more. Okay, so what I'm doing is, let me just, instead of doing union, just union all. Now let me go ahead and run this. Let's see what do we get in our output. So now again, the same thing accepted. Our output is same as expected output. Let me go ahead and submit it so it pass all the test cases. So you see now this passed all the test cases, and this is how we do it. So yeah, kind of a tricky question. The language not as exact as what you want from lead code, but yeah, this is how we do it. And if you are guessing where did we use the subquery, so basically this entire thing is a subquery which is creating a table called T, which we are using to count the number of people with the number of friends that they have. So this is the 42nd video of this series called investments in 2016, and if I look at the companies this question has been asked in, so tutor, kind of an important question. Let's look at what the question has to say. We are given a table called insurance with 5 different columns: PID, TIV underscore 2015, TIV underscore 2016, lat, and long. PID is the primary key, that is column with unique values for this table. Each row of this table contains information about one policy where PID is the policy holder's policy ID, TIV 2015 is the total investment value in 2015 and TIV 2016 is the total investment value in 2016. LAT is the latitude of the policyholder's city. It is guaranteed that LAT is not null. LON is the longitude of the policyholder's city. It's guaranteed that LON is not null. Okay, we are asked to write a solution to report the sum of all total investment values in 2016, that is TIV underscore 2016, for all policyholders who satisfies these two conditions. Firstly, have the same TIV 2015 value as one or more other policyholders and are not located in the same city as any other policyholder. That is, the latitude longitude combination should be unique. Round the total investment in 2016 to two decimal places. Okay, let's go through this example and see what they want to say here. So here we have an insurance table with four different policy holders. What they are saying is, firstly, we need to check that in 2015 policy holders value of investment should be same as one or more others. So for example, policy holder 1 has a total investment of 10, whatever the unit may be. So 10, but policyholder 3 and 4 also had 10. So the only rows to consider just by going by the first condition is row number 1, 3 and 4. 2, why not? Because they have an investment of 20, but 20 units is not an investment of any other policyholder in 2015. So that is the first one. Second should be that they should not be located in the same city as any other policyholder. So if you look at it, so 1010 is a unique value for policyholder ID1. No other policyholder has the same latitude longitude. We just saw that policyholder 3 and 4 also satisfies condition 1, but if you will look at for policyholder 3, the latitude longitude is same as another person and therefore it is not unique. So the only two rows that satisfy both the conditions are policyholder 1, where the investment value in 2015 is equal to one or more other people as their latitude longitude combinations are unique. So for these kind of people, so policyholder 1 and 4, the total investments in 2016 is 5 plus 40, that is 45, and that is what we have in our output. So basically this is a case of using filtering by subqueries. So what we need to do is, from this table called insurance, right, we need to keep only those rows firstly where the investments, that is TIV underscore 2015, so TIV underscore 2015 should be in. And then what we can do is, from this table, insurance table, if we group by this and count the number of rows and have only those rows where the count is greater than 1, what does that mean? So for example, if you group by this, right, so for 10 it will be having 3 count, for 20 it is only going to have 1 count. That means 10 was for more than 1 people in 2015, so therefore only those rows should be kept. So what I'm saying is, from this table called insurance, this is a subquery that we are writing. If I group by the investments in 2015 and keep only those rows where having, so since we are filtering based on aggregate value, we need to use having count of policy holder IDs, so number of people who have that kind of investment is greater than 1, then for these rows only return the TIV underscore 2015. So it is only, so let me just do select star here and let's try to see what do we get in our output. So we should only be left with policyholder ID 1, 3, so row number 1, 3 and 4. Let's look at if we are left with that in our output. So you see 1, 3 and 4. This is only condition 1 that is being satisfied. Condition 2 is the combination of latitude longitude should not be same as any other people as well. So, and what we need to do is, and the combination, this is what we learned, that you can use a combinations as well directly in the where clause. So combination of lat long column in, it should be unique. So here again same stuff you can do, but this time you can do by latitude and longitude. So from this column called insurance, if we group by latitude and then longitude and have only those rows, so having count of PID is equal to 1, that means only one person had that latitude longitude combination, which means it is unique. So have that, and then from them you return the combination of latitude and longitude. Let me go ahead and run this. Let's see what do we are left with. Okay, now if we look at in our output, so we are only left with two rows which satisfies both the condition. Investment same in 2015 and latitude longitude combination is different. So for them, what do we need? We need to sum the TIV underscore 2016, that is investments in 2016. So we sum TIV underscore 2016. Now this should be rounded to two decimal places as well. So round this entire thing to two decimal places, and this should be aliased as TIV 26. So as TIV underscore 2016. Okay, I think this looks good. Let me go ahead and let me just, so that it's easily visible for us. Okay, so this is the entire code that we have. Let me go ahead and run this. Let's see what do we get in our output. So, okay, this is accepted. Let me just drag it above. Okay, and if we look at our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. So not a very difficult question, but yes, here in this question, we had to use two subqueries to solve this. Firstly, to satisfy condition number one, that have the same investments in 2015 value as one or more other policy holders and are not located in the same city. So two different subqueries to solve, and then once we had the desired rows that we wanted in our output, then we just simply perform the investments in 2016 sum rounded to two decimal places and aliased as whatever was required in our output. Okay, so this is the 43rd video of the series called Department Top 3 Salaries, and if I look at the companies this question has been asked in, so Microsoft and Google a number of times in last couple of years. So very important question, and also this is a hard category. Let's look at what the question has to say. We are given a table called employee with four different columns: ID, name, salary, and department ID. ID is the primary key, that is column with unique values for this table. Department ID is a foreign key, that is a reference column of the ID from the department table. Each row of this table indicates the ID, name, and salary of an employee. It also contains the ID of their department. We are also given a second table called department with two different columns, ID and name, and ID in this case is a primary key for this table. Each row of this table indicates the ID of the department and its name. Now, a company's executives are interested in seeing who earns the most money in each of the company's departments. A high earner in a department is an employee who has a salary in the top three unique salaries for that department. We are asked to write a solution to find the employees who are high earners in each of the departments. So people with top three unique salaries in each department. Order of the result does not matter. Okay, let's go through this example and see what we need in our output. So here we have various employees, their salaries and department ID, and we have a department table which determines, okay, what is the name of that particular department. Okay, so if we go by department ID 1, so department ID 1, we have five different employees: Joe, Max, Janet, Randy, and Will. And let's look at who all have the top three highest unique salaries. So the highest salary is Max, 90,000. Then the second highest is 85,000, but 85,000 is for two people, Randy and Joe. So in our output for department ID 1, we should have 90,000 in Max, 85,000 Randy, 85,000 Joe, and the third highest is Will, that is 70,000. Now for department ID 2, there are only two employees, and these two are in the top three, obviously. So that is what we have in our output. If we look at, so IT, we have Max, Joe, Randy, and Will, and sales, Henry and Sam. Okay, so now this question can be done in two ways. Firstly, which is a easier method, is using a window function. What we can do is we can, for every department ID, arrange by salary in decreasing manner and rank them. Okay, so this is assigned rank 1, then 85,000 is assigned rank 2, and then the 70,000 is assigned rank 3, and so on. Similarly for department ID 2, rank 1 and rank 2. But there is another way to do this. Since we are learning about subqueries, it is called a correlated subquery. We are going to solve this question using correlated subquery, but firstly I will go ahead and explain you what a correlated subquery is and how exactly it runs. It is very confusing for people to understand initially. I will try to give you line by line demonstration to show actually what is happening. Okay. So since in our output we need the department name and employee and salary. So department name is in a department table and employee table has the name and salary of the employee. So the first thing that we should do is firstly we should join these two tables so that we have the desired columns. So from this table called employee, and let me go ahead and alias this as E1. Let me left join the department table aliased as D on E1 dot department ID is equal to d dot id. Let's return all the columns. Let me go ahead and run this. Let's see what do we get in our output. So here, if I look at it, so now I have a table where these four columns are coming from employee table and these two are coming from the department table. Actually, we do not need this id table. So what we can do is we can just simply keep e1 dot star and then d dot name as well. Okay, so now once we have this, then what we can do is this becomes our outer query. So for correlated subqueries, there are two things that you should keep in mind. Firstly, there is an outer query and then there is an inner query. And a correlated subquery works from outer to inner query. And I'm going to demonstrate that as well, like actually what is happening. Okay. So now let me switch to Excel and try to, recapture what we have done so far. So here we have the employee table, which was E1 that we aliased, and this is the department table. We joined on department ID of E1 and ID of department, and then this is the table that we got. Okay, so now this becomes our outer query. Now what we need to do is, see, the logic is exactly same as what you are going to use in the window function, but here we are just doing it in a very different manner. Out of these, right, so if you look at this out, right, so this is the result of what we have from our join, right? And if you look at our output is of that, right, of that we are only keeping the top three unique salaries people in every department. So basically it is about, in from this join we are only going to keep certain rows and we are excluding other rows. Now how a filter is being working? Okay, so let me, okay, so from this we have this, then what we are doing is from this we are going to keep certain rows. Now where, so since we need to filter, we write where. Okay, now we need to write the inner query. Let me just write it and then I will explain how it is actually keeping the top three unique values. So the inner query is from the employee table with, but it is another version of employee table. We are doing where even dot department id is equal to e2 dot department id, and even dot salary is less than e2 dot salary. And in these cases what you do is you return count of distinct e2 dot salary, and this entire thing should be less than 3. Okay, now I know that like this might sound very confusing, but like let me just go ahead and demonstrate what actually is happening. So firstly, how are you able to identify this is a correlated subquery? Here this query, this is the inner query, right? This is the inner query, and here you are using something from the outer part as well. So here you have from employee as E2, you are using E1, right? So E1 is from outer part, the department ID, and making sure that it is equal to E2 dot department ID and E1 dot salary, again using from the outer query and comparing with something else. Okay, so what actually is happening? Let me switch to Excel. Okay, so this is what we got from the join, right? This thing, and this is what we have written. So count of distinct E2 salary from employee E2, where E1 dot department ID is equal to E2 dot department ID and E1 dot salary is less than E2 dot salary. And this entire thing should be less than 3. Okay, what actually is happening is for every row in the outer query, it goes and checks for all the rows in inner query. And just by this statement, you might be thinking that actually this correlated subqueries are actually not a very optimized solution. Because think about this, here you only have 7 rows, but what if you had million rows, and let's say you have 100,000 rows in this. So for every row it is going to check 100,000 times, and 1 million multiplied by 100,000 times this query is going to run. So obviously it is not an optimized solution, but we are just trying to learn how it is working. So what I mean when I say for every row in the outer query, it is going to check all the rows in the inner part. So here it says, okay, let's say this is the first row that it took. Now, should I keep these row or not? Because if you just go ahead, right? So here out of this, so this is what we have from the join. Now we are performing a filtering where we are trying to see whether we are going to keep certain rows or not, and how we are going to determine whether we are going to keep those rows or not. This is using a correlated subquery. Now what it does is, okay, so you have id, name, salary, department id and name. Now it says even dot department id, this one is even, right? So even dot department id is equal to e2 dot department id, right? So let me just, okay, so here what it says is, okay, is your even dot department id equal to e2 dot department id? Here yes, so let me just write it yes here. Then is even dot department id equal to e2 dot department id for row number 2? No. Similarly for this, no. And then yes, 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 and yes. Okay. Now there is another condition, and even dot salary is less than e2 dot salary. Even dot salary is the even dot salary less than e2 dot salary? No. So here we would be having no. Is even dot salary less than e2 dot salary? No. So again, no, no. And similarly, if I go ahead and populate this, okay, so this is what it will have. Now, to decide whether this row should be kept or not, firstly, it went and tried to find, okay, what is the condition with the department ID and what is the condition with the salary. And once we had that, then we are only left with one row in this inner part, E2, right? So this one where we have yes and yes. For this particular row, this entire thing is reduced to only one row. And then what we are doing is we are counting distinct E2 dot salary. What is the distinct value? Only one, right? So 90,000. Is that less than 3? Right? So count is going to be 1. So 1 is less than 3. Yes. So finally, you keep this row. Did you see that? Like what happened? Let me just copy this entire thing here so that it's easier for us. So, okay. After round 1, we are left with this. Okay. Now let's go ahead and go to row 2. Okay. Now row 2 is this, whether this should be kept or not. Okay. Here it firstly it says even dot department id. Let me just delete these parts so that it's easier. Okay, now round 2, even dot department id, is this equal to this? No. Then yes, yes, no, 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 and no. Okay. Secondly, is this even dot salary less than e2 dot salary? Yes, right? So for first row, yes, and then no, and so on. So let me just go ahead and populate this. Okay, so here we do not have any single row where we have two yes. So what is this being reduced to for row number 2? Nothing, right? And if it is nothing, and you remember the property of count, that if you count star, it is going to give you all the rows. But if you count a particular column, then it is going to give you non-null unique values. How many non-null unique values are there? If this entire thing is reduced to nothing, there is 0 non-null unique values. And is 0 less than 3? Yes. So that is why this part is also going to be kept, right? So here, if I just write it here, so row number 2 is populated. Now, same with row number 3. What will happen in this case? What will this be? Let me just quickly, go ahead and populate this and see what it happens. So for row number 3, this is what we have. And we only have one row where we have yeses. So this entire thing for row number 3 is reduced to this. And what is the total count of distinct salary? 1. 1 is less than 3. So yes, this row will also be kept. Okay, now here we have Okay, now this is populated. Now let's look at this one, row number 4. What will this look like? So for row number 4, we have these ones. Again, there is no single row where we have two yeses. So this entire thing is nothing. And if you count non-null unique values, it is going to be 0, and 0 is less than 3. So you keep this row as well. Copy this here, paste it here, right? So you see how this query is working and keeping certain rows. Now let's look at this row, right? This is going to be interesting. So 5, right? So here let me just remove this part. Okay, so for this one it is yes, yes, it is no. So now here we have, how many rows do you have here? 1, 2, 3, 4, right? So you have 4 rows. So you have one salary 85,000, 90,000, 85,000, and 70,000. So you have 4 salaries, but if you count distinct, what is the value? 3. Why? 85,000, 85,000 is a repetition, so you count it as 1. Then there is 90,000, so 2, and 70,000 is 3. Now, is 3 less than 3? No. So that is why row number 5 is not going to be populated here. Similarly, if you go ahead with 6 and 7, it is going to keep that. So here, if I just go ahead and, let me know if you are not able to understand this part. But yeah, so this is going to be in our output finally. So now if you look at it, this is exactly the same thing that we got in our final output, right? So you have Max, Joe, Randy, Will, and then Henry, Sam. Here, Max, Joe, Randy, Will, and then Henry, Sam. So you see, this is what we get. And the only thing remaining to do is in our output, we only need certain names. So what we can do is, firstly, we name the name of the department. So we can write d dot name as department. Then we need the employee name. Employee name is in E1, right? So we can write E1 dot name as employee. And then we need the third part is salary. So we can do E1 dot salary as salary. Okay, let me go ahead and run this. Let's see what do we get in our output. If I go ahead and scroll up, okay, so this is accepted. Our output is same as expected output. Let me go ahead and submit it so it passes all the test cases. Okay, so this is accepted as well, and this is how we do it. Okay, so right, so you see, this is not a very efficient method, but this is how we do this using a correlated subquery. Two things to know about subqueries. Firstly, there is an outer part, right? So this entire thing is an outer query, and then this entire thing is an inner query. And secondly, inner query uses some values from the outer query, and that is why this is a correlated query. If you just simply run this part, this query, it is not going to run. So you have to have an outer query, and secondly, it always takes from outer to inner, and that is how it runs. So this is the 44th video of this series called Fix Names in a Table. And if I look at the company, so this question has been asked in Adobe interviews. Okay, let's look at what the question has to say. We are given a table called users with two different columns, user ID and name. User ID is the primary key, that is column with unique values for this table. This table contains the ID and the name of a user. The name consists of only lowercase and uppercase characters. We are asked to write a solution to fix the names so that only the first character is uppercase and the rest are lowercase, or the result table should be ordered by user ID. Okay, so if we look at this example here, we have name written in a very different way, but in our output, we need the first letter to be capitalized and everything else to be in lowercase. So it should be capital A and LISCE in lowercase. Similarly, capital B and OB in lowercase. And that is what we have in our output. So let me switch to Excel so that we can develop a logic. So here we have the users table. So for example, if I take the first name Alice, right? So this is Alice. Remember, unlike Python, indexes in SQL start at 1. So Alice is 1, 2, 3, 4, and 5, the different characters. So our strategy can be, since we need the first one of every word to be a capital or a uppercase and everything else to be lowercase, so we can divide this into two parts. Firstly, from this entire name string at index 1, length 1, because what is the length of the first character? 1. So take that, do an uppercase, then everything starting from index equal to 2 to end, make that lowercase, and then join these two things. So what we can do is from this table, right? So from this table called users, in our output, we need the user ID as well. So we write return user ID, and then what we need to do is firstly take the first one, right? So how can we take subset of a string in MySQL? You can use several functions, but one of them is substring. So sub str, so it will take a substring out of it. Here, which column we want to take the substring from? Name column. Then what position do I need to start? We saw that, right? For this, to capitalize, we need to start at index equal to 1. So 1, and then what is the length? 1. So first character only 1. You extract that substring out and you perform a upper. So basically you do the uppercase for this particular part. Okay. And then what you need to do is you also need to get the remaining part, right? So remaining part, it start at 2, go up till end, and lowercase. So what I'm doing is substring, right? So substring name column again, start at index 2 and go till, right? So let me just, write, bring it down here. So go till, now at the end, for every particular name, the length will be different. So remember we learned about length as well as char length functions earlier in the series, and we got to know that char length is a better way to calculate length in characters. So just think about it. If we go to Excel, so what is the total length of this? If you calculate the total length of the entire character Alice and subtract 1, that is going to be the length of this, these four, right? So 5 minus 1 equal to 4. So similarly, what you can do is you can calculate, so char length, length in characters of the entire string name, and then you subtract simply 1. And once you have both of these parts, okay, and the second part should, once you extracted this part, right? So this is just extracting the second half. This is extracting this part. Now we need to make sure that this is lowercase. So we write lower this entire thing, right? And then once we have this, then what we can do is we can join these two things. So basically what we can do is concat this entire thing and alias this as what is required in our output, name. So name, and this should be ordered by user ID in ascending order. So we write order by user ID. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so this is accepted. If I drag it above, our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So yeah, this is accepted, and this is how we do it. Another way to do this would be, instead of using substring, there is something called left and right. So same concept is can be applied, that okay, from start from the left, extract the first character, and then start from the right, extract the entire length minus 1, right? So if you are starting from here, you, where is the end point? So you go up till 1 minus the total length. So that is how you can do this as well. And similarly, you concatenate. So this is the 45th video of this series called Patients with a Condition. Let's look at what the question has to say. We are given a table called patients with 3 different columns: patient ID, patient name, and conditions. Patient ID is the primary key, that is column with unique values for this table. Conditions contain 0 or more codes separated by spaces. This table contains information of the patients in the hospital. We are asked to write a solution to find the patient ID, patient name, and conditions of the patients who have type 1 diabetes. Type 1 diabetes always starts with a diab 1 prefix. Order of the result does not matter. So here, let's look at this example and see what do we need in our output. So we need all the information, right? That is patient ID, patient name, and conditions for patients who have type 1 diabetes. And how to identify type 1 diabetes? The condition will always start with diab 1. Now, when it says it will always start with diab 1, it means one of the words should always start with diab 1. So here, this row, right, patient ID 3 Bob should be in our output. 4 and George, so acne diab 1 should again be in our output. So that is what we have in our output. So here you see we need to match a certain pattern, and in these kind of questions, regular expressions is a universal thing that is applied across multiple languages, be it Python, Perl, any programming language that you usually write code in. Similarly in SQL. And there are certain set of rules in regular expressions which you should learn, which will help you in all the languages that you are trying to do this. And especially like when you are working with strings, it comes in very, very handy. Okay. So here, what is our logic? So the question says that every type 1 diabetes always starts with diab 1 prefix. So the very simple logic to solve this question is, in the conditions column, check if for a particular patient ID and patient name, any of the words start with diab 1. Now, so there is a great resource from NTU, like so the university in Singapore, where you have a lot about regular expressions as well as regex here, right? So for example, here you, if you do this, right, to any one digit non-digit characters you can match, etc, etc, right? So it's a great resource to use. So basically what we need is this one, because we need to match the starting of the word, right? And how to match the starting part, this is where we have, right? So backslash b, boundary of a word, that is start of the word or end of the word, you can match something. So we can apply the same logic here, is that from this table called patients, we are going to keep only those rows where conditions, and the syntax is whenever you are using a regular expression in MySQL, you should write the keyword regexp, that is regular expression. So where conditions, regular expression, now we are going to evaluate it. So it should be starting of the word should be diab 1, right? So di b, so this signifies, we just saw that this signifies starting of the word, and it should be diab 1. Now there is another thing that you should keep in mind, in that there are certain things in regular expressions that have special meanings. So if I go to this, right, resource, and if I just go down, you will find that there is a section where it talks about yeah, regular regex special characters and escape sequence. Let me just zoom it a bit. Okay, so here we have these various dots, brackets, caret sign, dollar sign, etc. They have special meaning. So to match these characters, we need to prepend it with another backslash. So what we need to do is, instead of writing one backslash b, we to make sure that this signifies what we are thinking it should signify. So we learned that backslash b should be match any word that starts with whatever follows this. But to make sure that that is the case, we need to write another backslash. Then this will actually start and go and to the conditions column and see, okay, every word should start with diab 1. Then only you keep those rows. And in our output, we need all the three columns. So we simply go ahead and do select star. And since the order of the result does not matter, let me go ahead and run this. Let's see what do we get in our output. This is accepted. Our output is same as expected output. Let me go ahead and submit it with pass all the test cases. So this is accepted, and this is how we do it. So easy question, but you have to know basics about regular expressions. So basically regular expressions comes in handy when you are working with strings mostly. And then there are certain ways where you can, match certain patterns just by using shorthand notations of it. Then there are certain characters which have special meanings. So there you need to use escape sequences as well, right? I'm going to, link down this resource, as well as there is another resource, right, from learn by example. Both of this will be in the description or below if you want to learn more about it, or you want to have a quick reference guide of what different anchors mean and what it actually finds in the string. So this is the 46th video of this series called delete duplicate emails. And if I look at the companies this question has been asked in, so Apple, Oracle, Amazon, Uber, a lot of times. So kind of an important question. Let's look at what the question has to say. We are given a table called person with two different column, ID and email, ID being the primary key for this table. Each row of this table contains an email. The emails will not contain uppercase letters. Okay. We are asked to write a solution to delete all duplicate emails, keeping only one unique email with the smallest ID. For SQL users, please note that you are supposed to write a delete statement and not a select one. Okay. After running your script, the answer shown is the person table. The driver will first compile and run your piece of code and then show the person table. The final order of the person table does not matter. Okay, so basically what this mean is what you do not have to write a select query, because at the end it is going to return the person table. So I will just show you that even if you write anything, it is actually going to return the person table as it is at that particular moment. Let's look at the example. So here we have two different emails, but john@example.com is a repetition. So in case of repetition, we are only going to keep the one with the smallest id. So out of 1 and 3, one is smallest, so one john@example.com, and then since bob@example.com is not duplicate, so these two rows should be in our output, and that is what we have. Okay, the first thing that is, for example, whatever, so as we were mentioning that from this table, right, from this table called person, even if I do anything, right, so where, let's say, if I want to do id equal to 1, and let me write select star, I just want to demonstrate that what does this question actually means to you. So even if I did id equal to 1, the output that we are getting is all the three columns. Why? Because the question says that the answer shown is the person table. That is what we need to keep in mind. Okay, let me just remove this. Now, to do this, the logic should be that if you have duplicate emails, right? So for example, if you have duplicate emails, you can go ahead and perform a cross join so that for every row you have all the combinations, right? So what I'm saying is, from this table called person, right? Let's alias this as P1. Let me cross join the word table, but this time with a different alias P2. Okay, what will this return? I cannot show you here because as we just saw that it is going to still return the person table. So let's switch to Excel and see what will this return for us. So this was person table with P1 and person table P2, and if I perform a cross join, this is what we are going to have. Okay, now based on this, we need to find out, okay, which of the emails are duplicated and the id is not the minimum for them, right? Because that is the row that we need to delete from the person table. So after performing a cross join, this is what we have. Since if there is a repetition of an email, so obviously your email from the first version P1 and P2 should be equal, because for examples like this, right, so these does not make any sense because this is John at example, this is Bob at example. These rows does not have any sense to us, right? So the first condition we can do is where P1 dot email is equal to P2 dot email. Okay, so in this cross join result, what are the rows now we are left with the where clause? So obviously this one. Okay, so these are the 5 rows that we are left with. Now what we need to find is, we need to find the duplicate emails which do not have the highest id, because that is what we need to delete. So in this case, if I do something like this, right, so if I write and p1.id is greater than p2.id. Okay, so if I go ahead, so these are the 5 rows that were left after the first filter, that is p1.email should be equal to p2.email, and which of these have p1.id greater than p2.id? Not this row, not this row, not this row, only this row, right? And obviously not this row, right? So this is the only row that satisfies both the condition. So from this, right, so from this part, right, so after performing this, if I do, let me do select p1 dot star, what will this return? Obviously I cannot demonstrate you here, but what will this actually return? This will return p1 dot star, so that means this will return this one, right? And this is what you need to delete from this, right? Because here the output should be 1 john at example.com, 2 bob at example.com. So this is what you need to delete, right? So you see, if I instead of select write delete here, so delete whatever was outputted after performing a cross join, and these two filters is going to be your output. So let me go ahead and run this. Let's see what do we get. So yeah, this is accepted. Our output, you see that 3 and John at example.com was deleted, right? Let me go ahead and submit it to pass all the test cases. Yeah, this is accepted, and this is how we do it. So yes, even though it says easy, it is kind of a tricky question because it is the first question where we do not have to write a select statement and we need to write the delete one. Okay, so you see this is how we need to do and find out the which one of these were duplicates, but their ID was not the minimum. So we found out that part and then we deleted that from the person table. Okay, so this is the 47th video of this series called second highest salary. And if I look at the companies this question has been asked in, so Adobe, Amazon, Microsoft, Accenture, Google, Apple, McKinsey, Oracle, right? So a lot of companies have asked this a number of times. A very important question. Let's look at the question. So we are given a table called employee with two different columns, ID and salary, ID being the primary key, that is column with unique values for this table. Each row of this table contains information about the salary of an employee. We are asked to write a solution to find the second highest salary from the employee table. If there is no second highest salary, return null, that and none in pandas. So let's look at the example here, right? So what is the second highest salary in this? 200, right? And we have that in our output. But in this example too, since there is only one salary, right? So there is no second highest salary, so the output should be null, right? Okay, so the first thing that we can do is to solve this question is we can arrange the salary in descending order, right? So what we can do is from this table called employee, if I go ahead and do order by the salary column in decreasing manner, right? And let me return everything, right? So let me return select star. Just this is just for demonstration purposes, but let's see what do we get in our output. So here if we see our salary is arranged in descending manner. Now I want the second highest salary. If the question would have asked what is the highest salary, then you can simply do limit 1 and that is going to give you the first highest salary, right? But once you want the second highest salary, so if you can offset the value by 1, what does offset mean? That is, you skip the first one and whatever you get in the second, that will become your second highest salary, right? So what I mean by that is, if you wanted to have the first highest salary, right? So if you just wanted the first highest salary, you would simply do limit 1, right? And if I go ahead and run this would give you the highest salary, which was 300 in that case, right? But if you wanted the second highest salary, what you can do is you can keep limit 1, but hey, just before this you want to offset it by 1, so you can write 1 comma 1. So this will, skip the first row, and then for the second row it will keep the only row, right? So here you will be seeing salary is equal to 200, right? So this is now your second highest salary. Okay, but there is still one problem here. In one of the example, let's say there was two rows with the same salary. So let's say there is another row called ID equal to 2 and salary is equal to 100. Now if you order by salary in decreasing manner, there would be two rows, 100 and 100. And even if you offset by 1 and keep the second highest salary, that is going to return you 100. But just think about it, actually 100 is not the second highest salary in that case as well. So instead of that, you need to return distinct salary, right? So firstly you return the distinct salary and then you offset by 1. Okay, so let me go ahead and run this. Let's see what do we get in our output. Here we are being returned a empty string, but in our output we should have a null. So we learned about this in the earlier in the series, that when such cases arises, either you can use the max function or you can use the select function. So if if you put this entire thing into parentheses, right? If you put this entire thing into parentheses and just simply write return this thing, and you should be aliased as whatever is required in our output, right? So the second highest salary. So as second highest salary, right? Let me go ahead and run this. Let's see what do we get in our output. Okay, so in both of these cases, now this is accepted, right? Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So you say this passes all the test cases, and this is how we do it. Not a very difficult question, but what we had to do was, we use the concept of offset for the first time, right? So what does offset do? It will basically, skip the number of rows that you want to offset, right? So if you offset by 1, so it will go to this row, right? And then try to calculate stuff. And then why did we do distinct salary? To keep in check when there would be repetitions as well. So this is the 40th video of this series called Group Sold Products by Date. And if I look at the companies this question has been asked in, so Adobe and some of the startups, let's look at what the question has to say. We are given a table called activity with two different columns, sell date and product date. There is no primary key that for this table. It may contain duplicates. Each row of this table contains the product name and the date it was sold in a market. We are asked to write a solution to find for each date the number of different products sold and their names. the sold product's name for each date should be shorted lexicographically. That means by alphabets in ascending order. Return the result table ordered by sell date. Let's look at this example. So here we have various activities date, right? So for example, if we look at 30th of May 2020. So on 30th of May 2020, there was headphone sold, basketball sold, as well as t-shirt sold. So if you arrange it lexicographically, firstly it should come basketball, then headphone, then t-shirt. Similarly for others, if you look at this, right, 2nd of June 2020, there is a repetition, right, because there is no primary key in this table. So there are masks, but this is a repetition. So in our output, you should only have one mask for 2nd of June 2020. So if we look at our output, let me just drag it to the right so that is easier. So for 30th June 2020, there are three products sold, arranged in alphabetical manner: basketball, headphone, and t-shirt. Similarly, on 2nd of June 2020, there is only one product that was sold, mask. Even though there is repetition, we do not need to include that. So yeah, this is how we do it. So since it says for every sale date, so by now we already know that we need to perform a group by the sale date. Then we can count the number of distinct products to get the number of sold. But how do you get this one? So we will learn about a new function here. So let me just drag it to the left. So what I'm doing is, from this table called, right, so from this table called activities, we, since we need for every cell date, so we group by the cell date, and then at the output we need return cell date. Then if we count the distinct product column, then that will give you alias this as number sold. That is what we have in the output, so number sold. But how do you get this column? So there is a function called group concat. What it does is, for every group, whatever there is in that particular group, it will concat those things separated by whatever separator you give it. So here commas are the separators between members of the group. So if I go ahead and just use that, so here after this we need to get group concat. So this is the function name. And what do we need? We need the products. So group concat the product, and this should be arranged in lexicographic manner. That is, it should be ordered by product as well in ascending manner. And this should be aliased as, there is one thing that is still remains, but aliased as products. So let me alias this as products. Okay, let me go ahead and run this. Let's see what do we get. Okay, so if we look at our output, let me just drag it to the left. So here we have all the stuff that we need, but because there was a repetition on 2nd of June that we looked, so here mask appears twice. So obviously we do not need all the products, we need the distinct products. So what we can do is group concat the distinct products. And also in our output, we should order this by sell date as well. So we can go ahead and do order by sell date in increasing manner. And now let me go ahead and run this. Let's see what do we get in our output. So now this is accepted. Our output is same as expected output. Let me go ahead and submit it to pass all the test cases. So this is accepted, and this is how we do it. So not a very difficult question. The only thing that we had to do was group by the cell date, count distinct. This is we already learned earlier in the series, but there is a new function that we had to learn, which was called group concat, where we can group various things in a particular group. Then we can also return whether you want to make it distinct or repetition is allowed. Then you can also order in that group concat function. So this is a 49 video of this series called list the products ordered in a period. And if we look at the companies this question has been asked in, so Amazon, let's look at what the question has to say. We are given a table called products with three different columns: product ID, product name, and product category. Product ID is the primary key, that is column with unique values for this table. This table contains data about the company's products. We are given a second table called orders with again three different columns: product ID, order date, and unit. This table may have duplicate rows, and product ID is a foreign key, that is a reference column to the products table. Unit is the number of products ordered in the order date. We are asked to write a solution to get the names of the products that have at least 100 units ordered in February of 2020 and their amount. Order of the result does not matter. So here we have the products table as well as the orders table, different orders and 5 different products. So in February of 2020, we need to find out what all products have at least 100 units ordered. So if we look at it, right? So for example, product ID 1 in February of 2020 have 130 units. So product ID 1 is lead code solution. So that should be in our output. For product ID 2 or in February of 2020 only 80. So not in the output. Product ID 3 not in the output because less than 100 as well. Product ID 4 there is nothing in February of 2020. So and product ID 5 in February of 2020 there is 50 plus 50 100. So product ID 5 is lead code kit 100, and that is what we have in our output. So here, since we need the product name and the total units, both of them are in these different tables. The first thing that we should do is we should join these two on the product ID column. So what we can do is from this table called orders. Now why we are keeping orders on the left? Because we are dealing with the orders, because in February of 2020 what all products have at least 100 units ordered. So going with the orders table is a better method. So orders, let me go ahead and let's alias this as O. Let me do left join. You can also do inner join, does not matter in this case. So left join the products table aliased as P on O dot product ID is equal to P dot product ID, and let me keep only the all the columns from orders table. So O dot star, and since in our output we are only required for the product name, so let's just keep only that column from products table. So P dot product name. Okay, let me go ahead and run this. Let's see what do we get in our output. Okay, so if I look at our output right now, let me drag it to the left. Okay, so here what we have is, so various products, their order date, unit, and product name. Let me switch to Excel and try to see that, okay, this is what we have, right? Products table, orders table, and when we join, we have the three columns from products table as well as the orders. Now we are only concerned with February of 2020. So we learned earlier in the series that there is a function called date format where you can format the dates in any manner that you want. Since we are only concerned with February of 2020, so from this join, we can keep only those rows where date format of the column order date belongs to orders table. So O dot order date is like what? So firstly capital Y for year and then dash and then small m for months represented as 00 to 12. Okay, so this should be equal to February of 2020. So February of 2020 is 2020 and 02. Let me go ahead and run this. Let's see what do we get in our output. So now in our output, we are only left with those rows where the order date is February of 2020. So from this, if I go ahead and see what do we have in our output right now after performing the filter, these highlighted rows. Okay, now from what we need to do is we need the name of the product and the number of units ordered for only those products whose number of units ordered is at least greater than equal to 100. So you see there is a filtering based on an aggregate, that is you group by the product ID and the product name and have only those product names whose sum of the unit column is greater than equal to 100. So what we can do is from this group by the product ID. Product ID belongs to the order table, right? So if I go ahead and do O dot product ID and product name, again, one caution here that it says that even product ID is the primary key. So that will be unique, but do not go directly ahead and group by product name only, because there can be multiple product IDs with the same name. So in such cases, always try to group by things that are unique in nature. So that is why group by product ID. But then you might be thinking, then if we are grouping by product ID, why we have to do product name? Because you remember we learned about group by, that whatever you group by, only those columns can be returned as non-aggregate values. So here we need the product name in our output as a non-aggregate value, right? So you're not aggregating something here. You are aggregating the unit part. That is why you can sum that, right? So here you can write P dot product name, and then in our output you need the O dot product or actually in the output you do not need the product ID, you only need the product name. So this is another thing that we learned earlier in the series, that even if you group by multiple columns, you do not need to return all those columns. So we, in our output, we only need the product name, and then we need the sum of unit column. So sum of unit belongs to order, so o dot unit, and this should be aliased as unit. But if you just run it here, there is a problem. Let me go ahead and run this. Why? Because the question says only those products who have been ordered at least 100 in February of 2020. Right now in our output, we have all the products, right? Irrespective of whether they were ordered greater than or equal to 100 or not. So we need to make sure that, okay, having the sum of O dot unit greater than equal to 100. So now let me go ahead and run this. Let's see what do we get in our output. Okay, so now if we look at it, our output is same as expected output. Let me go ahead and submit it to submit past all the test cases. So yeah, this is accepted, and this is how we do it. So not a very difficult question, but we had to apply a lot of learnings from earlier in the series, that how to perform joins, then how to use date format function, then when to use having, when to use where, when you can use both, what is the order of them. Okay, so this is the 50th video of this series, find users with valid emails, and let's look at what the question has to say. We are given a table called users with three different columns: user ID, name, and mail. User ID is the primary key, that is column with unique values for this table. This table contains information of the users signed up in a website. Some emails are invalid. Okay, we are asked to write a solution to find the users who have valid emails. A valid email has a prefix name and a domain where. The prefix name is a string that may contain letters, uppercase or lowercase, digits, underscore, period, and or dash. The prefix name must start with a letter. The domain is a @leetcode.com. Order of the result does not matter. So let's go through this example and see what should be in our output. So firstly, the mail should have a valid prefix and a valid domain. So for example, mails like this one, right? Because there is no domain. Similarly, here the domain name is different. So these two will be eliminated. Then it should always start with a number. So this one is also eliminated as well. So right now what we are left with is Winston at bella-sally.com, and then here we also have this, but here it says it can only contain either underscore, period, or dash. Here we have a pound sign, so this will be excluded in our output. So there are only three mails that are valid, who have valid prefixes as well as domains: Winston at leetcode.com, bella-@leetcode.com, and sally.com at leetcode.com, and that is what we have in our output. So basically this is an easy function where we need to use regular expressions. We learned about regular expressions earlier in the series when we started the advanced string functions, regex, and clauses as well. So what we need to do is, from this table called users, from users we are required to keep only those rows where mail, and since we are using regular expression, we need to write regexp, and then we need to give the pattern that it has to match. Okay, so the question says the prefix name must start with a letter. Okay, so how to check at a beginning? We learned about this, and I will share this document in the description box below. There is a great resource from NTU where you have a lot of examples, etc. So here, but if you go through it, to check at the beginning of a string, there is a caret sign. So this basically does is start at the beginning of the string and see whether it starts with a letter. Now letter can be uppercase or lowercase. So in those cases, what we do is we go for square brackets, which basically creates a character class. So you can give ranges. So you can have A to Z capital or A to Z. So it should, what does this basically mean is everything should start from a letter, either uppercase or lowercase. Let me just, go step by step. So select star. Let me go ahead and run this, and in the output we should not have this one, right? Because this starts with a period. So let me go ahead and drag it above here. So in our output you see that that particular thing is not mentioned, right? So this is eliminated. Okay, then it says then it can only contain letters, uppercase or lowercase, digits, underscore, or period. So basically again you can create a character class where you can give, okay, either it should be letters, upper lowercase, digits, underscore, period, or dash. So what you can do is another character class. So basically you give them options. So either you can have letters, so A to Z or A to Z. Then either you can have digits, so 0 to 9. You can have underscore, you can have period, you can have dash. So any of this. And now how do you signify any or one of them? Because a email called, let's say, w@leetcode.com, that is also a valid email, right? So it is possible that after it starts with a letter, there is nothing and still, it is a valid email. So to demonstrate that, okay, yes, the any of these should be there, but it is zero or more. So match zero or more of anything from this list. So to do that, you need to write asterisk. So asterisk is basically look in this list, and if you find anything, well and good. If not, no worries at all. Okay, so this is up until this we have the prefixes part. Then it should end in domain at the rate leetcode.com. Okay, so we need to write at the rate leetcode.com. Okay, now here there will be a problem. If I go ahead and do this, this will return an error. Why? Because in regex there are certain characters which have a special meaning, and dot is one of them. So here if you go here, right, let me just zoom it a bit. So here if you see, there are a certain list of characters which are having specific meaning, so which is period, plus, asterisk, question mark, caret, dollar, right, brackets, different types of brackets, etc. So and the significance of this is leetcode.com. So it right now at this present you might be thinking that it is trying to match leetcode.com, but it is not. It is saying leetcode, then have anything in between. It does not matter what, but there should be something between this, and then you match it, right? So it's basically like saying that B, fill in the blank, T, then you can have BAT, bat, BOT, bot, or any letter B97, right? So that dot represents the something. So that is why, if I go ahead and submit this, it is going to give me an error. You see, in this case here we have a question mark. This dot says anything between E and C, it is able to match. It does not matter. So that is why it is able to match this, and our output is this. But actually this is not a valid domain name. So expected should be nothing in this case. So you see, this is the problem. So to make sure that SQL understands that no, we are not saying have any one characters between E and C, but literally match it with dot. So we learned about skip characters, that you need to write skip. And that is now the SQL knows that, okay, now you have to match leetcode.com. Dot signifies literal dot. But then you might ask, if dot has a special meaning in regex and I have to assign escape characters, then why not assign escape character? And especially we learned about that dot as well as dash also has a special meaning. So remember this, when you are representing a character class, so basically anything between the square brackets, that is read at as it is, but outside of that regex reads that as a different thing, right? So okay, now once you have this, then let me go ahead and run this. Okay, so still there is small problem here. Even though it says accepted, it is possible that here you started with a character which should be a letter, then you match something and then at the rate leetcode.com. But if you leave it here, there are problems for this. Because what if at the rate leetcode.com and there is something else, ABC, after this? Because you are not specifying that your email should end here. Anything after that makes this a invalid email. So let me go ahead and submit it. It will, tell you what the problem is going to be. Again, you see, up till here it is matching our pattern. But what it after something like this? This is not a valid email, right? But ours will match. So at the end, we need to make sure that .com and then that's it. So at the end, you need to write $sign. So now let me go ahead and run this. Let's see what do we get. So now if you see, our output is same as expected output. And now if I go ahead and submit it, it is going to pass all the test cases. So you see, this is accepted and this is how we do it. So yes, Tricky question, and you have to make sure that you follow whatever is given in the question to the dot. And then we also learned about character classes, how to give options, why periods and dashes in character classes do not require escape characters. So this is what escape characters are: do not require these, but outside of that they do require it. Why having just leadcode.com is problematic, and why we require escape characters in there. So yeah, this is